will be a Starfreelancer. Learn new skills. Set your goals. Increase your skills. Browse over 100 plus videos and ebooks. Jump to starfreelancer.eu.
Hello dear students, in this lesson we'll learn what a Git rebasing is and what force update is. I will show you how and when you can apply Git rebase command. I will explain you what rebase actually means. Also, I will explain you the difference between Git merge and Git rebase. After we will understand theory, we will take a look at real example and we'll learn how we can use rebase command on daily basis. You are going to see how to keep your Git tree clean. During the lesson, you are going to learn how to solve conflicts that could appear during the rebasing on the other branch. On real examples, I will show you what Git rebase with option continue means and how to complete rebasing process. After we changed local commit history, I will show you what force update is and how force with lease option may help us. And at the end of the lesson, I am going to share with you 4 rules of happy work with Git by Andrei Pataha. Just joking as always. And to start with, let's discuss the problem which we faced during the previous lesson. If we resolved conflicts with pull command, you saw that one more commit was created. And you also saw that I can't merge with rebase strategy to master, I can only merge with new commit. So, our problem is how to keep Git history tree clean. To proceed showing you new commands, let's understand first what rebase is and how it works. In general, there are 2 main ways to integrate changes from one branch into another. They are Git merge and Git rebase. We already learned in previous lessons more about Git merging branches. Now let's understand on the high level what is a rebase. Let's recall an example when we had diverged branches. The easiest way to synchronize 2 branches is to merge them. So, to merge C3 and C4 snapshots, we have to create one more snapshot, thus one more commit, C5. This option works just fine, and we saw how it works. But do we have another option that will not create additional senseless commit? Yes, we do. Rebasing on the other branch. What does that mean? We can take changes that we have in C4 commit and put them on top of C3. That means you can take changes that were done on one branch and apply those changes on the other branch. In our example, I can execute command git rebase master while being on the experiment branch. This will lead us to the Git history that you can see on this slide. You can see that C4 snapshot is going right after C3. This will allow to create pull requests and merge branches in GitHub with rebasing strategy. In this particular scenario, we can switch back to the master branch and do fast forward merge, like it is shown on the slide. And in this case, you can see that there are no any other commits for merging branches, and we have clean Git history. We're also going to have a lesson about interactive rebase a bit later in this course, where I will show you how you can use rebase command to combine commits or to change commit messages. But in this lesson, we'll learn rebase command only from the point of merging changes from different branches. On the previous slide, you saw git rebase command to rebase changes from another branch. But in real life example later today we are going to use a bit another variation of this command, git pull with rebase option. So what is the difference between git rebase and pull with rebase option? Git rebase command rebases the branch which we want. Git pull with rebase option can be treated as shorthand for git fetch and then git rebase command. You will be able to fetch all latest changes from the remote repository prior to rebasing our code on top of it. Because if I would just use git rebase master command, Git would only take into account what local repository is already aware of, but not the changes from the remote repository. This is very important practical tip. That's why this video course is so valuable to all my students, because even if you would read documentation and use git rebase, you wouldn't reach the expected goal. And it is not clear that pull command has rebase option, if only you read all Git documentation. Probably, by this very moment of our lesson you are wondering, what is better, git merge or git rebase? Which one should I use? To give you the full answer, I'd like you to understand one more time what repository's history means from different point of views. Repository history is the record of what actually happened. From this point of view, it might seem like not a good idea to change Git history. From this angle, using rebase is similar to lying about what actually happened in your repository. But is this valid comment all the times? Or there are some exceptions? What if there are a series of merge commits that brings us almost zero information about code version improvements? That brings us information that branches were merged. Okay, and what? That is logically that branches should be merged at some point. But I'm more interested in the functionality of the specific version of code rather than the fact that there was code merge. That is the other point of view on what repositories history means. My personal opinion is that we should treat our Git history as a story of how our project was made. If we are writing a story, there is no harm in doing side notes and tracking each step. But when times come to release the story and show it to the world, I want to tell more coherent story without all my drafts and dead-end paths. But despite my personal opinion, I believe you understood that there is no right answer which approach is better. And just keep in mind that all projects are different and there is no silver bullet for each project. There is no one-size-fits-all approach, but being a true professional, you have to be aware about different points of view. That's why I believe it is important for me to share this with you. Okay, now when you understood the theory of Git rebasing, I suggest looking at our practical example. Team, to understand the demo in this lesson, you have to understand the demo from previous lesson, because we have the same context as in previous lesson. We'll proceed from the point where we finished previous time. Let me call git log command of last 3 commits. Git log-3. Here you can see that I have merge commit. When we resolve together merge conflict, you can see here that this merge commit of this and this commits. You can check checksum here. And here is the reference to login pop-up during login commit. That is commit that we merged from TA304 branch. And we see in parentheses that it is from origin master branch. And we have our own commit which we did in scope of this branch, carousel on the home page. To demo you another option of handling merge conflict and to demo rebase to you, I suggest resetting our state to the state of this commit, carousel on the home page, before we even did a git pull origin master command. Right now you are going to see git reset command, which we are going to learn in the separate lesson. I have to use it in this lesson so that you would keep track of all my changes in the Git repository. I believe that showing all my actions in Git to you is the best way to learn such powerful tool as Git. I will perform the next command and I will explain you in short what it does. Git reset. This command can reset state of your file system to the specific revision. Option hard. Reset command has different modes. We'll learn all possible modes in the separate lesson. Hard means that files from the other revision will be restored and all changes from other revisions will be removed. Head. Head is a pointer to the current place in Git. That is our last commit. -1. This means reset state of our file system to the state that was one commit ago. That is right before we pulled changes from the origin master branch. Let's press enter. And here we are on the carousel on the home page commit. Let's check commit history now. Git log command. Awesome! We can even check our file system. Let me show you that we don't have login CSS file from another branch. cd styles ls-l. And you can see that we only have carousel CSS file and we don't have any login CSS file here. Cool. Let's get back to the src directory. cd::. And now, instead of doing git pull origin master, let me execute another command that we have learned today. Git pull with option rebase origin master. This was expected. In case we wouldn't have any merge conflicts, rebase would be very smooth. But that is way too easy for you. Let me show you how to resolve merge conflicts during the rebasing. I believe you remember that we expect merge conflict in home.html file. But this time we have a bit different message. We see that error happened during the rebasing, and commit couldn't be applied. Here Git leaves a hint for you what to do in this case. We have to resolve all conflicts manually. After that, we have to either add or remove files to the staging area and execute git rebase continue command. I don't recommend you skip this commit like it is shown here, because our goal is to resolve conflicts and finish rebasing. In case you understand that you did a mistake and something is going wrong, you can execute git rebase with abort option. By the way, here in parentheses you can see indications that we are in the process of rebasing right now. But let's resolve merge conflicts. nano web content /home.html. Let me quickly resolve these conflicts. After conflicts are resolved, I close and save this file. Now, as it was said before, I have to add files to the staging area. Git add dot. And now we can proceed our rebasing. Git rebase continue. Git offers me to adjust my commit message, but I want to keep it the same. Carousel on the home page. That sounds just perfect. So I just close the file. And I see a message that I was successfully rebased on the other branch. Now let me update my branch in remote repository to update my pull request. Git push. Oh, I see error here. Updates were rejected. Why? Because I already had a branch in the remote repository. My origin TA305 home carousel branch has different commit history rather than my local branch now, because rebase command changes Git history, and Git is not smart enough to understand this. For Git, it just looks like a mess. Now our local branch and remote branch has different history of commits. Let's take a look one more time at the history of commits of the remote branch. Can you see these two commits? And can you see commits checksum? Now let's return to git bash and check commits there. Git log -2. Can you see this? We put our carousel on the home page commit right on top of the master branch. That is actually what rebase does. And pay attention to checksum here. Can you see that commit with the same message has different checksum? Okay, we understood that our commit history is different on different branches, but what to do now? I need to tell Git which version is correct. I know that my current branch is the most relevant branch, so I have to update my origin branch so that it would have the same commit history as my local branch. To do this, I need to perform the next command. Git push with option F. F stands for force update. Be extra careful when you do this, because force update will erase changes that are currently present in the remote repository in this branch. If you are going to use rebase command, that means sometimes you would need to use force update option. But, one more time, be extra careful. Use this option only with your branches, only with branches that only you are aware of. Because in case somebody created branch from your branch, and you change commit history, and your branch was merged, that will cause extra efforts for the engineer who created branch from your branch. Real life example: QA automation engineer who is going to help you with writing UI tests for your home carousel created his own branch from your branch. You updated commit history and merged it to the master. QA engineer can't merge smoothly his branch, neither to your branch nor to master right now without rebasing and solving conflicts one more time. Or imagine that QA engineer merged his or her changes into your branch, and by applying force update he overrides those changes, and your commits were lost. This even sounds complicated, so please try to avoid this. Today we are going to create few rules that will save you a ton of time and your nerves in the future. I call these rules 4 rules of happy work with Git by Andrei Petaha. Rule number 1. Always create branches from the master branch, but not from the other development branches. Rule number 2. Force update only your own branches that you can be sure nobody using. Because of the risk of losing data, force is very risky mode. What is less risky? The rule of thumb is using force with lease option. What is this about? Force with lease is a safer option that will not override any work on the remote branch if more commits were added to the remote branch by another team member. Based on this, let's make rule number 3. When you need to use force update, always use force with lease option. I can't even count how much times this simple rule saved me tons of time. So, we use force with lease option. Let's press enter button. Taking into account nobody updated my branch, I successfully updated my branch in the remote repository and my pull request. Let's check my PR now. Can you see this? I have one commit instead of two. And also, checksum of the commit carousel on the homepage is changed. Now I can use rebase and merge strategy. That is awesome. We did this together. And now it is time for the rule number 4. Rule number 4. Always rebase on origin master branch before creating a commit. Now you know how to rebase on master. I would even say that this is the best practice to rebase on origin master as often as you can, to fix conflicts gradually, and to test your implementation on the latest version of the code during the development. To not spend a lot of time when you worked 1 week on your task and after solving all conflicts you realized that feature doesn't work as expected. Okay, we did really a lot today. Let's recap what we have learned today. In this lesson we learned what a rebase is. We understood the difference between merge and rebase. We tried to answer the question what is better to use, git merge or git rebase from different points of view. On real example you saw how rebase command works. You know when you need to execute git rebase continue command. Also, we learned when we need to use force update mode and how force with lease option can help us to not overwrite other commits. And at the end of the lesson we reviewed 4 rules of happy work with Git. We learned a lot today. I'm really happy you saw this lesson. Thanks a lot for your attention, dear students. Have a great the rest of the day and see you in the next lesson. Hello team, in this lesson I'm going to show you how interactive rebase works. Today I will show you when and how you can use interactive rebase. On real examples I will show you how you can change any commit message from your repository history and will show you how to combine 2 commits into one. After this lesson you will learn how to squash commit. I will share with you best practices of working with Git and keep Git history clean. Let's start. And we will start from the example that we had in previous lesson. Imagine that being on the task branch you understood that you have to do one more commit. Probably you forgot to add some styles. For the sake of example, let me adjust carousel CSS file. nano styles/carousel.css. I will just put new lines here to not spend a lot of time on modifying this file. I add these changes to the staging area, git add dot. And now you need to include latest changes into your branch. What you can do? The first option, which we have already learned and which I want to remind you, is to amend the last commit like this. Git commit with option amend with option no edit. This will allow you to change your latest commit without changing commit message. But let's pretend you didn't want to amend commit for some reasons and want to create one more commit. Or you are dealing with commits that were merged into your branch by a colleague of yours who doesn't know Git as good as you are. And that's why you have extra commit for this change. Let me create a commit now. Git commit with option M, CSS class for home carousel slider is added. Okay, and now you have 2 commits on your branch. Let's add one more commit. We need this to have at least 3 commits to play with on our branch. That is for the sake of the demo. The same as before, I will quickly adjust our CSS file, and I will create one more snapshot. nano styles/carousel.css. Adding new lines here. Git commit -a-m one more CSS class for home carousel slider is added. Okay, now we have 3 commits. Imagine that you are not happy with commit message and want to change it. What options do you have to adjust last commit? Git commit with option amend. But what if you don't want to change commit message for your latest commit? What if you want to change commit message that goes right before the last one? Interactive rebase will help you with this. What is interactive rebase? Interactive rebase in Git makes it easy to clean up your commits before they get rebased or moved onto another branch. Git rebase with option I, head, 3. I stands for interactive freebase. We want to proceed with interactive freebase for last 3 commits. That's why I wrote head, that is the pointer to our current state, -3, that means 3 commits back from the current one. Let's press enter now. Awesome! Here we see our 3 last commits, starting from the latest to the newest. And I see that to change message I have to write R letter near the commit where I want to change commit message. And I want to change not the last commit message, but commit message that goes before the last one. So I put R letter next to CSS class for home carousel is added commit message. I save file by pressing Ctrl and S and close the text editor. In this window we can change commit message as we wish. Let's add more details. CSS class for scrolling carousel on the home page is added. Now let's save this file and close the text editor. Here you can see notification that we successfully rebased and updated the branch. Let's check commit history. Git log -3. And we can see that commit message for this commit and checksum of this commit was changed. Great! After we changed the message for commit, we took a look at our branch commit history one more time and realized that it is way too many commits about the same thing. We have 3 commits right now for the one single piece of functionality. We know that in case we would push this change to the remote repository, our tech lead might be disappointed. Why? Because for the one single task, create styling for carousel on the home page, we have 3 commits right now, instead of having one single commit. Your tech lead may ask you to squash your commits in order to keep Git tree clean. What does squash mean? In other words, you can combine 2 or more commits into the one to ensure clean Git history. You can melt commits so they would disappear, but not the changes which were done in scope of these snapshots. Let's imagine the case that during the development of your task you did multiple commits and after that you realized that it would be better to have either one commit or group commits in a bit different manner. How to do this? Interactive rebase will help us also with this task. Git rebase with option I, head -3. You're already familiar with this command. You can specify as many commits backwards as you want instead of 3. I'm specifying only 3 right now because we all remember 4 rules of happy work with Git from the previous lesson. I can modify only commits that are on my branch, but not commits that already exist in master branch. I press enter. The same commit history as we already saw today with updated commit message. We can see that to combine commits we can use either squash or fix up. We'll use squash when we want to change commit message and fix up when we want to keep commit message of the first commit. Most likely, if you combine multiple commits, you want to reflect this in the commit message. That's why more often you're going to use squash rather than fix up. Important thing to mention here, you can't squash the first commit in the list. In other words, here in the first row you should have peek to be able to squash other commits. I wrote S letter near other 2 commits. S stands for squash, and in case you forgot you can find other shorthands here. I press Ctrl and S to save the file and close it. Now I'm asked by Git to adjust commit message. I see the commented lines and commit messages of my other commits. Let me clean this up a bit and leave the one message which I'd like to keep. In addition to this one, I want to add few words. Is styled. I save the file and close it. I see message that I successfully rebased. What else potentially may happen here? Potentially, you can see message about merge conflict during the rebasing. Similar to the one you saw in previous lesson. Taking into account you combine commits, there might be merge conflicts. But you already know how to deal with conflicts during the rebasing, since we showed this in the previous lesson. Let's check our commit history now. Git log -3. Great! You can see our commit with updated message and pay attention, new checksum. If checksum is different, you already know that push to remote repository will be rejected. Beside our updated commit here, you can see other commits from the remote master branch. And we can't see here our commits where we adjusted CSS file, because they are melted, but the changes are in place. We can open our CSS file just to check this. nano styles-carousel.css. then find that new lines added in first commit and new lines added during the second commit are in place. We can count number of new lines, but I believe it is even visually obvious. We did all we wanted. And you already know that in case there is a difference between commit history in my local branch and remote branch, we need to force update our remote repository. And on previous lesson you already learned best practices, and we are going to use force with list now. Git push force with list. We added additional changes and combined them in one snapshot and updated our pull request. This will make your tech lead happy on your future project, I promise you. Now let's recap what we have learned today. In this lesson we learned what interactive rebase is. You learned how to start interactive rebase. You saw how you can change any commit message in your repository. After this lesson you also know how to combine few commits together. We learned best practices of working with Git today. That's all for now. Thanks a lot for your attention. See you in the next lesson. Hello dear students, in this lesson we are going to learn in detail what is git reset command and how we can use it. We'll start from the problem statement and when we might want to use it. Afterward, we'll learn in theory how it works. To understand how git reset works, we'll compare it with git checkout command. We'll review 3 different modes how git reset may work: soft, mixed and hard. Besides the theory overview, on a real example I'm going to show you how you may use this command in your repository. Let's start. So, when you need to use git reset command. Git reset command is a really powerful tool that will help you to undo changes. It might happen that you created snapshots that you don't need anymore. Or probably, for some reasons, you want to remove commits from your local branch, but you don't want to remove changes from your working directory. For such cases, git reset command might be used. You can find tutorials on the internet, but in my opinion, they are really hard to understand for the people who have never had experience with Git. That's why in this lesson I will try to explain this topic from the practical point of view to help you understand the topic better. To understand how git reset command works, let's compare it with git checkout command. Here is our master branch, and here is our head pointer that points to the latest snapshot on this branch. So, what happened when we call git checkout command when we try to switch to another commit? We can execute git checkout command with the revision checksum where we want to switch our head pointer. In this particular scenario, if checksum is b, then I can move head pointer by executing command git checkout b. But the master branch is still pointing out to the latest commit here. If you remember, during one of our lessons we discussed detached head state. This is exactly the scenario of detached head. So, what does reset command do that is different from checkout command? In case I will use git reset command with checksum of the specific revision, Git will move both head pointer and current branch pointer to this specific revision. That's what Git always does, no matter what option will be used with reset command. Can you see the difference on this visualization? Hope it is clear now what reset command does. But besides the updating of commit pointers like head pointer and branch pointer, reset command will also update the state of our staging area and update the state of our working tree. That is our files in our file system. Updates in the staging area and working tree will be different, depends on what mode of reset we are going to use. As you learned from agenda, there are 3 possible modes: soft, mixed and hard. Let's learn right now what will happen in case we reset in soft mode. If we use git reset with soft option, we still move head and branch pointers to the specific revision and that's it. Nothing above that. Changes from your working tree will be there and in the staging area. In simple words, the changes that you did in files before resetting commit. These changes still will be present in files of your project. Moreover, these changes will be in the staging area. In case after reset in soft mode you would call git status command, you would find all your changes added to the staging area in green color. Execution of git commit command is going to lead you directly to the state where you were before resetting. Here on this slide you can see that soft mode keeps all changes in the staging area. In case you are going to use mixed option, it is similar to soft with only one difference. Changes still will be present in the working directory, but they won't be present in the staging area. In simple words, you still will be able to find your changes in files, but when you will call git status, you are going to see that all changes are not added to the staging area. You would need to perform git add and after that git commit command in case you want to restore the state before resetting. The previous two options you may want to use when you're kind of okay with changes that you have done, but you have to do some modifications in the git history. The hard option for reset is really hard. This is the most direct and dangerous option that is frequently used. After executing git reset command with the hard option, Git will make sure that your staging area and your working tree match that of the specific commit. In simple words, your file system will be the same as it was after commit, which you specified in reset command. When this mode is needed. Personally, I used this command a lot when I realized that I messed up completely the state of my files and I want to get everything back as it was when it worked, at least somehow. Sometimes you might want to reset the state of some specific revision. Probably you want to reset state of your local repository to the state that you have in remote repository. You might want to do so in case something went wrong during the rebasing. Today, during the demo, I will show you how to reset your changes in different modes. Now, when you understood the theory, let's practice a bit and I will show you how you can use git reset command in different modes. We are on the master branch. Let's check our git history. Git log-3. Here are the commits that we did during this course. You remember we added stock management service and created separate snapshot for that? Afterwards we created cart management service file and created separate snapshots for that. And after that, I did create HTML file home.html for our lessons to understand merge conflict topic. Do you remember that? Let me show you, for example, that after soft reset to the state of the stock management commit, cart management service and home HTML are still present in the working tree, but the state of the branch and head pointer is different. Git reset with option soft E71A5B. I entered first characters of this commit and press enter. Let's check our commit history to understand where we are now. Git log-3. You see here in parentheses that our head and master pointers are on this commit. Let me check git status. Git status. And you can see that two files from the two commits are present in my file system and automatically added to the staging area. To return my project to the state where it was before the reset, but with the new commit, I have to commit them one more time. Git commit with option M, cart management and home HTML. And we created new commit with these changes. Now I want to demo to you mixed mode. Let me find command that we recently used and just change it a bit. Here it is. Let me remove soft here. By the way, mixed mode is a default. That means you shouldn't necessarily write mixed here. You can just remove any options here. That would mean resetting in the default mixed mode. Let me check git log now. Git log-3. I'm on the commit where I want it to be. And let's check status now. Git status. And you can see that files are present in my working tree, in my file system, but they are not in the staging area. Can you understand the difference between soft and mixed mode now? To return the previous state, I should execute git add dot command and after that commit changes. Let's use the same commit message as previously for the sake of the demo. Awesome! And let me show you the last but not the least option, hard. Let's reset in hard mode to this commit. Spaces are added to the hello world file. We should see how the state of our file system will be different. Home.html, cart management service and stock management service files would disappear. Git reset with option hard 26726F. Let's check commit history now. Git log-3. Okay, our head pointer and branch are pointing to the commit that we expect. But what is with our file system now? Git status, and we can see that there is nothing to commit, and that is my working tree clean. I am in the src folder right now. Let me check the state of the file system. ls-l. We can see that I have only discount calculation service and hello world file. I don't have neither cart nor stock folders where my other files were stored. Now you can see how a git reset with hard option can reset the state of the file system. One more trick. Probably in some lessons you saw that I reset state of the branch without referencing to the specific commit checksum, but using relative navigation from the head pointer. Let me show you one more time. Git reset with option hard head ~3. You can see how I can move head and branch pointers to 3 commits back from the point where I was. This is pretty convenient as for me. Probably you would also use this variation of reset command. And one more real-life scenario. Imagine that you wanted either to squash commits or revert message, or something else went wrong during the rebasing or during the development and you want to reset the state of your working tree, your file system, as it is in remote repository right now. What I recommend you to do. The first thing that I always do is execution of fetch command with all option like this. Git fetch with option all. This is just to make sure that you fetch the latest state of the remote repository. After that, reset with the hard option to the state of origin branch. In this particular case, we played with our master branch. And I want to restore the state of origin master branch. Git reset with option hard origin/master. And you can see that I am on the latest commit right now. Today you saw that in reset command you can use commits checksum, relative amount of commits from the head pointer, and even specific branch. I believe now you know about reset command even more than some senior software engineers. Hope you enjoyed the lesson. Let's recap what we have learned today. Today we learned what is a git reset command and when we can use it. We understand the difference between git checkout and git reset command. You learned 3 modes of reset command: soft, mixed, and hard. On the real example you saw how to reset state of the branch few commits back from the head pointer or to the specific commit. Also, you learned how to reset state of the branch to the state of the branch in the remote repository. That's all what I planned to talk about in this lesson with you. Thanks a lot for your attention and see you in the next lesson. Hello dear students, in this lesson we are going to learn with you git stash command. I'm going to tell you when you might need to use it. You'll understand how to reapply changes from your stash. On real examples I will show you how to manage multiple stashes and even how to create a branch from your stash. And also we are going to learn different commands that will allow you to clean your stash and to perform other operations with it. Let's start. First of all, let's understand potential problems that stash command may help us to resolve. Imagine that you're sitting at your computer and work on some task. And all of a sudden, you receive a call from your manager. Your manager screams that you urgently need to fix some other thing or you have to start work on the other task immediately, but you didn't finish your current task. Your manager told you that you have to give up everything and start work on the new task. The state of your file system doesn't allow you to create a commit right now. Probably because you even can't build your project successfully, or you are just in the middle of something important to finish. And it looks like that you have to put all your changes aside to get back to them later. Hope that you understood the problem and real-life case that may happen with you almost on daily basis. But how to address this issue with the help of the Git? Git stash command will help us with this. Stashing takes the dirty state of a working directory, that is your modified tracked files, staged changes, and saves it on a stack of unfinished changes that you can reapply at any time, even on different branch. What a stack is, I will explain a bit later. Don't worry. I believe that the best way to understand how git stash command works is to show it to you in git bash. I am on the master branch right now and my working tree is clean. Let's imagine I am in the process of implementation of some important task. I create new branch. Git switch with option C TA306 important task. Okay, and being on this branch in src folder I modified home.html file. To not switch the windows between different code editors, let me do small changes right here in the terminal using nano text editor. Nano web content /home.html. I added some important changes here. P, some important line, P tag is closed. After I did all my changes, I saved the file. And now I received message from my manager who is in panic and asks me to start work on the super important task. I don't need changes from home HTML file that we have just created, during another task implementation. Let me check status of my branch. Git status. And you can see I have one file modified. And currently it is in the state when creating snapshot with it doesn't make a lot of sense. So I will put it temporary in my stash. How? Simply by executing the next command, git stash. Great, now our changes are in stash. Let's check status one more time. And you can see that right now it is nothing to commit. But now I can be sure that my changes won't disappear. I am returning to the master branch to create the new branch, git switch dash. Here I create a new branch, git switch with option C TA307, super important task. Okay, and now I can continue work on my new important task. My changes that are currently in stash are not present on this branch. Let me show you this. nano web content/home.html. And we can't find our important line here. Cool. Now, let's imagine that you realize that you need those changes here and you need them back. How get your changes back from stash? You need to apply changes from your stash. To do this, let's use the next command, git stash apply. And instantly you see the status of the branch and indications that home HTML file is modified. Let me open it to double check. Yes, I see my important line here. Awesome! Now, important information about stash. This command creates stack of changes. Do you understand how a stack of changes may look like? Let me show you quickly. In computer science, stack is an abstract data type that serves as a collection of elements. It works according to LIFO principle. One more fancy word. What does LIFO stand for? LIFO is an acronym from last in, first out. This is method of storing data in data structures according to which the last element get into the container leaves the container the first. And on the screen you can see visualization of stack. Imagine that each element here is a separate batch of changes. When you use git stash command, your changes are on the bottom of this container. When you use git stash apply command, the changes from top of the stack are applied to your branch. And if you use git stash command multiple times, the new changes will be on top. Does it make sense? Now imagine that you used stash command multiple times, and you have a lot of changes in your stash stack. How to view all changes that you have in your stack of changes? Let me show you. To list all changes that you have in your stack, use the next command, git stash list. And specially for this lesson I prepared few items to have multiple elements here. You can see that our last stash has index 0 and it is on the top of our stack. That means you can apply it on different branches. But probably you may be wondering how to apply other changes from the stack. For the sake of the demo, let me apply changes from this stack with the index 1. Git stash apply, and after that I will use the name of the stash that is specified here. Stash add and 1 in curly brackets. Before I press enter, I want to warn you that you are going to see error message. I press enter, and as I promised, here is the error. Don't worry, everything is under control. I did this on purpose to show you this error message that you may see sometime. Git sometimes will show you this message to warn you that your changes might be overwritten after some specific operation, and this is one more case to use stash as a temporary storage for your changes. I already have these changes in my stash, so let me just commit them. Git commit -a-m commit. Sorry about this commit message, just don't want to spend time on the details that we already discussed. Hope you understand that such unmeaningful commit message is not the best practice, and I use it only for the sake of the demo to not lose the focus from the git stash command. Now, when I created a snapshot, let me try to apply one more time other changes from the stash. And you see that some changes were applied here, namely, login CSS file was removed, and changes in home HTML file were also applied. There is even a conflict in this file since it was modified in different versions. You just have to open this file and to resolve conflicts. For the sake of the demo, let me reset the state of the current branch to its origin state. Git reset with option hard to the head pointer. Let's talk about another problem. Do you remember what is in my stash list? Let me show it one more time. Git stash list. How do you think? Will I remember that there are changes in home HTML file in this stash tomorrow? Or in a month? That's why usually it is a good practice to give a name to each stash. Let me do some changes in the repository. For example, let me remove login CSS file. rm styles/login.css. rm is a standard command in Linux terminals to remove files. Let me stash my current changes with a specific message. Git stash save login CSS is removed. And let's press enter. Now, when I will see the stash in the future in my stash list, I will instantly understand what changes it contains. Git stash list. And here I can see my last stash. And it is on the top of the stack. Great! Okay, now let me explain you one more thing. Probably you noticed that I applied different stashes, but they are still in my stack. How to apply stash and remove it from the stack? For doing this, you have to use pop command instead of apply like this. Git stash pop. We see that I applied my last stash and login CSS is removed. Let me check my stash list now. And now you can see that it is disappeared from here. Let's move on. One more thing that we didn't discuss yet is that you can stash only changes that are in the staging area or changes that were done in files that are tracked by Git. Imagine that we created a file and after that we were interrupted. We have to stash it. Let me quickly create a file here. Touch some important file.java. Right now this file is untracked by Git. Let me show you this. Git status. And in case I would try to stash changes, only removal of login CSS will be stored. Let me prove you this. Git stash. And now let's check Git status one more time. And you see that my new file is still in untracked state and is not in the stash. How to add it to the stash? We have to use special option for that. Let me show you. Git stash with option U. U stands for untracked files. Instead of U, you can use A option. A stands for all. Beside untracked files, it would also stash files that are ignored according to our gitignore file. But I doubt that you would ever wanted to include ignored files to your stash. That's why let's use U option here. I press enter. Let me check Git status now. Git status. Awesome! Finally it looks like our new file was stashed. And now imagine that you want to create a branch from your stash. Imagine that when you finished work on the super important task, you already removed all old branches and you have to create a new one. How to create new branch from stash? Use the next command. Git stash branch TA307 new. You can specify here any stash ID you would like. Without specifying stash ID, the first stash from the stack will be used. And you see that I have new untracked file on my new branch. Git also moved me to the new branch. You can see it here in parentheses. And what to do in case you don't want to apply your stash, but you just want to remove it? Use the next command. Git stash drop. You can specify any stash ID here, for example, stash at 0. Now let's check stash list. Git stash list. And you see that our first stash in stack was removed by us. In case you want to clear all stack of stashes, use the next command. Git stash clear. And in case we would check our stash list now, we are going to see nothing. And here's empty list. Nothing is here. Great! It looks like that is all what I planned to share with you in this lesson. Let's recap what we have learned today. Today we learned what a stash is. Now we know how to use git stash command. On real examples we learned how to manage multiple stashes. We learned how to stash untracked files and how to clear your stash if needed. We also learned what is the difference between git stash apply and git stash pop. That's all for now. Thanks a lot for your attention. See you in the next lesson. Hello team, today we're going to have super interesting topic. In this lesson I'll show you how you can restore literally everything what was ever present in any snapshot in Git, even if it was overwritten either by force push or hard reset. Today we will learn such command as git reflog. We are going to understand when and why we have to use it. We will imitate cases when we lost some changes and we need to restore them. After this lesson, you will be able to use reflog command with different options and variations like a pro. You are going to learn how to restore lost commits in the new branch, or reset current branch to the commits that were lost. Let's understand first, why do we need to use reflog, and what problem it may help us to solve. It may happen that at some point during your Git journey you may accidentally lose a commit. Like I told you before, it may happen during the forced delete of your work or during the hard reset. Or you used interactive rebase to squash commits, and resolving of conflicts during the rebasing went wrong and some changes were lost. So how to get lost changes back? In Git, if something were ever committed, might be restored. Git won't be able to restore files that were never in the staging area and were never committed before. I suggest starting learning of the Git reflog directly from the practical exercise. Let's start. To show you how to restore changes, let me intentionally lose some data. I'm on the master branch. Let me show you latest commits. Git log -3. Let me hard reset 2 last commits. Git reset hard head -2. Okay, the branch is reset. Let's check commit history. Git log. Now we can say that we lost 2 commits. Okay, there is no harm for me to restore the changes from the origin branch, but it might happen that the origin branch was also accidentally overwritten or completely removed. You won't believe me, but such cases may happen. At the first glance, it looks like that I only need to remember the checksum of the lost commits, but we didn't memorize them, agree? The most complicated in this task to learn checksum of those commits. And the easiest thing to answer this question is to call git reflog command. What is a reflog? As we are working with Git and moving pointers, Git silently records what is our head pointer and how does it look like. That means that each time we either create a new snapshot or switch branches, the reflog is updated. You can investigate the history of all changes in your repository by executing the next command, git reflog. We can see information about each operation that was done here, about each commit, each reset on origin master branch. You can find information here about different branches by the reference in the parentheses. Also, you may find checksum of each state right here. By the way, this is the last program. This is a program for text terminals for Unix-like systems. To close it, just press Q key. To remember it, Q stands for quit here. Let me press Q. Okay, you already saw where's the place where you can get checksum of the commit that you want to restore. I know that for some students the way how reflog looks like is not very informative. We can't see the detailed commit messages. We may find only description of the operation but not the details about the commit. What would I suggest to you is to use the next command, git log with option G. Here you may find list of all commits with the reflog reference. Here is our commit that we have lost. Let me create a new branch with the state of that snapshot. Git branch lost changes. And now I have to specify commit checksum that I want to restore. E50BAD. Great! Now let's check commit history. Git log lost changes. Just to remind you, to check the commit history of the specific branch, we should specify branch name next to log command. And we can see that our new branch contains commits that were lost. So, as far as you may understand, you can restore anything what was present in any commit in your local repository, or anything where head pointer of your local repository ever pointed to. Also, one more important note. By default, information in reflog is stored for 90 days. Usually it is enough. It is very unlikely that you lived your happy life for 91 days and after that realized that you need to restore some lost commit. Let me show you one more syntax of restoring changes. I'm on the master branch, and I didn't switch to the new branch with the name lost changes that we created with the lost commits. On the master branch, I still don't have my lost commits after the hard reset. Let me reset with hard 2 more commits back. Here is our git reset hard. To prove you that we really moved few commits back and that we have lost even more commits, let me show you commit history. Git log -3. and you can see that we lost our E50BAD commit. Let me show you reflog one more time. To not show the whole reflog, let me show you the reflog only for the past 1 hour. Git reflog with option since equals to 1 hour. And I see limited amount of reflog. You can use day instead of hours if you wish. So here is the state of our head pointer before reset. It has index head, @, and true. Let's reset state of the current branch to this position. Git reset with option hard, head, @, and let's check our commit history one more time. Git log. And here we are. We successfully restored state of our file system and state of our branch that was before the last reset. I believe this information will help you a lot in the future. That's all what I planned to share with you today. Let's recap what we have learned today. So today we learned what a git reflog is. Now you know how to use this command. During the lesson we restored our lost commits by creating branch from the lost commit or by resetting the current branch to the previous state before some commits were lost. Also, we learned how to show reflog filtered by time passed. That's all what we have for today. Thanks a lot for your attention. See you in the next lesson. Hello team, today we are going to discuss with you one more important command that may help you to modify commit history. Today we'll talk about cherry pick command. As usual, we'll discuss when we need to use this command. After we'll understand when we need to use cherry pick command, we'll proceed with our practice exercise to understand how we can use it. In this lesson I will share with you my experience of using cherry pick, and I will tell you why this command is not considered as a best practice, and even despite that, why we may need to use this command sometime. I am going to teach you how to cherry pick multiple commits at once and how to resolve conflicts during cherry picking. And at the end of the lesson, I will share with you best practices of using cherry pick. So, when we have to use cherry pick? There are different cases when you might want to use cherry pick command. Some of them. Deliver hotfix to the end user as fast as possible. Imagine that you created release branch. Release branch should contain only source code that is going to be part of the build of your application that is going to be deployed on your production environment, where it will be available to the end user. And imagine that you realize that during rebasing or merging of the latest changes before creation of the release branch, you missed important change and now you have a defect in the release branch. The fix for this defect is present in the snapshot in your feature branch. It was tested, it was approved. So, the only thing that you have to do is to move the commit from the feature branch to your release branch. And to move one snapshot from one branch to another, we have to use git cherry pick command. Or imagine another case. Undoing changes and restoring lost commits. Not all branches are merged into the master branch, and some commits might be lost. Using git reflog command, you may find snapshots that you need and cherry pick it into your branch. One more scenario. Regular team collaboration. In case you and team members work on the same feature and you have some shared functionality, you may want to test something on your branch that includes other changes. For example, backend engineers created a data structure that frontend team also needs to use, and frontend developers may use cherry pick command to get those changes into their branch. Probably during the life of the developer, you will find other real-life cases when you may use cherry pick command. But I believe you understand why you may want to use it. And now attention! I don't want you to share with your tech leads information that Andriy Petaha told you that using of cherry pick is the best practice. I want to say that cherry pick command usually considered as not a good practice, and regular merges are preferred instead when it is possible. But sometimes you may want to use this command. Why git cherry pick is considered as not a best practice? Notice, I said literally consider it not as a best practice, but not necessarily the bad thing. To understand this, let's review how git cherry pick works. It creates, attention, separate commit with different hash and has no reference to original commit. Content of commit will be fully duplicated, but Git will consider new commit and original one as two different commits. That's why some developers may consider cherry pick as a bad thing, because it may cause problems like having duplicate commits in multiple branches, messing up with Git history and others. But in case you are using this command attentively, there is no harm in it. For example, there might be cases when you can't merge some branch because it contains a lot of other changes that are not needed anymore. And at some specific moment of time, you need only one single commit. That's where cherry pick command may help you. So, use cherry pick with caution. At the end of the lesson, we are going to summarize rules that you have to follow during the cherry picking. Now, let me show you the real example of cherry picking in Git. For this lesson, for the sake of the demo, I prepared branch with few commits. Let me briefly explain you the state of my current repository so that you would understand the example. Imagine that I am working on the implementation of login functionality, and I created separate branch for that with the name TA308 login. You can see that I am currently on it. Let me show you the commit history of what I have already done. Git log with option 1 line -3. The option 1 line allows me to format output in a bit different way than usual. I press enter. Here what I have already done while being on this branch. I implemented styles for login button. Also, I implemented backend part of login feature. And here is a snapshot of the origin master branch. And imagine that during the testing of my work, quality assurance engineers found a lot of defects. And we are not in the position to merge my branch TA308 into the master branch. But everybody really liked the styling of my login button. And product owner requested to have the other buttons in the same style. That's why I want to prepare a pull request for only styles of my button, and we'll merge that branch into the master so that other developers also would be able to pick up that changes while I will be fixing all the defects with backend code for the next week or two. Just joking, you know that I would fix it faster. But just as an example. This shouldn't be a problem because I will rebase my branch with the backend code on the master before merging. Or even just remove styling snapshot from the current branch. Do you understand the real life case? Let me now show you how to do that. First of all, let me create the branch from the latest master branch. Git switch master. Git switch with option C TA309 button styles. Okay, I am on the new branch. And imagine that I did some changes in the login CSS file. Just did any random changes. Nano style/login.css. Let me write here some text. Some changes. And save it. Now let me commit this. Git commit with option A and with option M, some commit. I press enter. And now, being on this branch, I have to cherry pick this commit with checksum EC6B5EC. To copy that commit and apply it on my new branch, let me execute the next command. Git cherry pick EC6B5EC. In case we wouldn't adjust the login CSS file, we won't see conflicts here and your commit would be applied. But that is way too easy for you. I wanted to imitate state of the conflict during the cherry picking to show you the process of the conflict resolving during the cherry pick. You see that Git indicates that we are in the process of the cherry picking, and Git gives us advice to resolve conflicts and add files to the staging area. Let me check Git status. And you see here in unmerged path, it is said that there is a conflict in login CSS file. So let's open it in the editor and let's resolve the conflicts. Nano styles/login CSS. We'll imitate the fact that we resolved all conflicts. Now let's mark this file as resolved. Git add dot. Now let's continue our cherry picking process. To do this, let's perform the next command. Git cherry pick with option continue. And Git allows us to adjust commit message. By default, it keeps the origin commit message of the previous commit. Let's save and close this file. And we can see that we applied our changes here. Let's check our commit history. Git log with option 1 line -3. And here's our new commit. And attention, in case you would compare a checksum of this commit and checksum of original commit from TA308 branch, you're going to find that they are different. That means that these two are not the same commit. This one is just a copy of the first one. And now, few more important variations and options of cherry pick command. In case something went wrong during the conflict resolution, you can just abort the process of cherry picking like this. Git cherry pick with option abort. Also, if you wish, you may cherry pick multiple commits at once. To do this, just specify checksum of all commits separated by space like this. Git cherry pick EC6B5EC and 3F31666. Those are two commits from our demo. Now, when you know how to use cherry pick, let's talk about the best practices. The rule number 1. If it's not critical and you can apply necessary changes with merge, opt for merge option. It is considered to be a general practice to prefer merge option over cherry pick. Rule number 2. Avoid creating any duplication by using cherry pick. If you cherry picked commits and removed old branch or just reset the old branch, that's fine, and this will not lead to any issues. Potential issues may happen in case you keep two branches and have duplicated commits. Rule number 3. Sometimes it is considered as a good practice during the cherry pick to specify the hash code of the original commit. Git may help you to do this in case you will use X option like this. Git cherry pick with option X. This option will automatically add the information about the original commit into your new one. And here on the screenshot you may see how your commit message will look like. You learned a lot today about cherry pick. Let's recap what we have learned today. Now you know when you may need to apply cherry pick command because we discussed with you different cases when this command will help you. Also, you understood why cherry pick is not considered to be as a good practice. On real example you saw how to resolve conflicts during cherry picking. Now you know how to cherry pick multiple commits at once. And at the end of the lesson we learned best practices of using cherry pick command. That's all for today. Thanks a lot for your attention and see you in the next lesson.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Hello dear students, in this lesson we are going to discuss the topic that will be interesting for developers who work in such integrated development environment as Eclipse. We are going to learn today how to integrate Git with Eclipse for development comfort. Besides the Git buttons and widgets that we'll configure in Eclipse during the lesson, I will show you how you can use Git bash directly from the Eclipse. Together, on real example, we are going to learn how to execute basic Git operations from Eclipse. I'll make overview of widgets that will allow you to see Git history, navigate between branches, push and pull changes from the remote repository. After this lesson, you will learn how you can resolve conflicts in Eclipse interface. Let's start. And to learn the topic, I suggest jumping to the practice. Here is my Eclipse workspace. I created completely new workspace and reset perspective view to default to configure it with you from scratch. I've imported the Java project which we did together during the learning of the Git in the workspace. How to import projects into Eclipse I'm going to show you in the separate lesson, to not lose focus from the Git topic right now. When I imported the project, Eclipse automatically recognized that there is a Git repository. And you see that in square brackets it is even specifying my current branch. But nevertheless, I will show you how to add your Git repository to Eclipse manually, just in case. First of all, let's add all views here that we need. Click on Window, Show View, Other. Find here Git folder or use search bar to find it faster. I would say that Git staging and Git repositories, those are two that you need 100%. Well, at least in my opinion. I'm holding Ctrl button and with mouse left click selecting the options that I need. Let's also select Git ref log. And it is good that we have learned how to work with Git in the Git bash. At least now you already understand what all these views are about. You already know what is the staging area, what is the Git ref log, you already know what the Git interactive rebase is. After we selected all views we need, let's press Open button. Nice. Views were opened. Just to remind you that you can move these views wherever you like the most here in Eclipse. For example, let me move Git repositories widget here at the bottom with other views. And you can see that my Eclipse recognized Git repository in my project automatically. But just for the future and just in case, I want you to know how to add existing repositories to the Eclipse. Because it might be that Eclipse will not automatically recognize that you have .git folder in your project, and in this case you have to add it manually. For the sake of example, let me remove the Git repository from this view in Eclipse. Mouse right click, remove repository from view. Because I want to remove Git repository only from Eclipse view, and I don't want to remove the .git folder from the file system. And I don't want to remove the project in Eclipse associated with this Git repository. I want to keep project in my workspace view. That's why I press this button. Awesome! Now we don't have any repository here. You can create a new repository if you wish, that is similar to executing git init command. You may also clone existing repository with the help of the Eclipse wizard, and in case you already have Git repository on your computer, you can just add it to the workspace. I believe there is no need to go over each of these options in detail because creating a Git repository is just specifying directory where you want to create .git folder and pressing create button. Cloning repository is just specifying the path to the repository and your credentials in case you will clone repository with the help of HTTPS protocol. But from my experience, this option, add an existing local Git repository, is used most of the times by me. And I don't know why. Probably because I don't rely on the Eclipse tools to manage my Git repository. Usually I fetch all projects with the simple git clone command in the git bash, and after that I am importing project to the Eclipse and adding an existing local Git repository. Personally for me this option is the easiest one. But my job is to share with you all possible options and let you decide what works the best for you. That's why let me show you how I usually add existing local repositories to Eclipse. And now you should specify a folder where your local repository is located. I navigated to the folder that we created together during the course while learning Git and press select folder button. Here Eclipse shows me repositories that it found in this folder. I check this checkbox and press add button. And here's my repository back again. Let me expand it. It is very convenient to switch branches here. You may find here local and remote branches. Double left click on the master branch will move me to the master branch. Eclipse will ask your confirmation. Just click checkout. And you already know how git checkout command works. So, I believe you understood what happened behind the scene. And you may see small tick here next to the master branch name. Let me switch back to the TA309 branch. Right-click on the branch would allow you to do the operations that we learned to perform in Git bash. You may reset branch in different modes, soft, mixed, and hard. You may rebase your branch if needed, merge, delete, rename, and perform all other operations that you may perform in the Git bash. We don't have tags in our repository yet, so it is empty here. What a tag is will be discussed in the separate lesson. Here you may find your main references in your repository. You may check out there if you wish. In remotes, you may check to what remote repository you are connected right now. In stash commits, you can explore the state of your stash and your working directory that is technically your project. Let me collapse everything here. Based on my experience, I mostly use this section to navigate between branches, create new branch if needed, and remove old branches. Let's move on. This sign near the repository name means that I have some unstaged changes. You may find similar sign here in the Package Explorer. How to identify what change are we talking about? Let's check separate tab for that, Git Staging. Here you can manage what is in the staging area, write your commit message and commit changes if you want. You also can commit and push to the remote with a single button click here from this view. I see that .project file is marked as unstaged changes here. This is configurational Eclipse file that Eclipse created after we imported the project into it. Let me update gitignore to just ignore this file. I can't find gitignore file in the Package Explorer view, but let me open Navigator view for that. I click Window, Show View, Navigator. In this view, I can see all files as they look like in my file system. And here's gitignore file. Let me add here .project and save the file. And you may see that instantly .project file is gone from unstaged changes and gitignore appeared. You can press this green plus sign to add all files from this section to the staged changes section. Let's write commit message. Eclipse files ignored in Git. I can make a commit by clicking here, but probably I would commit and push changes to the remote repository simultaneously. To do this, I have to click Commit and Push button. Here in Wizard, you should set upstream branch for the current branch. That is exactly what we did when we specified U option during the push to the remote repository. Just click all these buttons until you see confirmation that your changes were pushed to the remote. We may check GitHub, but believe me, changes are there in the remote already. Let me show you a few more things. You can press mouse right-click on the project and here you will find Team section. This section is integration with Git in Eclipse, and you may find here a lot of different options like fetch from upstream, push or pull changes, and many others. Take your time to investigate this section and ask me in case you have any questions. To check commit history, you can press Show in History. Here you may see commit hash, commit message, author of the commit, and date of the snapshot. In this window, you can check what files were changed in scope of the particular commit. You may open the file to see the difference before and after the snapshot to understand what exactly was changed. This is a very useful tool during the investigation of the defects when after specific commit something went wrong. Also, here in the Git history, you may reset your branch to the specific commit or check out there. Just click mouse right-click and select exactly what you need. Now, I want to show you a few more configurations that I found extremely helpful. I want to tell you how you can add few buttons here on the toolbar. Click Window, Perspective, Customize Perspective. Now, go to the Action Set Availability and select Git here. After that, go to the toolbar Visibility and make sure that Git is selected here. Click Apply and Close. And now, here on the top you have very convenient buttons. No matter what you want to do, push, fetch from upstream, pull, check out to branch, rebase, merge or reset, you can start these operations simply by clicking the right button in the toolbar. And even in case you can't find either button that you need, or you want to execute some specific command with a specific option, you always may open Git bash directly from Eclipse and start working it. To open Git bash in Eclipse, find the icon of the console in the toolbar. Here it is. Click on it and select Git bash in the drop-down here. Git bash should be installed on your computer. In other case, you won't be able to find it here in the drop-down list. Now you may click OK button, and terminal is opened. Important thing to mention here, always pay attention to the directory where Git bash is opened. In case you have multiple Git repositories in the single Eclipse workspace, Eclipse may open you another directory. Or it may open you your home directory. To make sure that Eclipse will open to you the right directory, I always press the project first here, and only after that I click Open Terminal icon. Hope this information will help you. That is practical tip that is really helpful to students in my opinion. We didn't talk about reflog yet, nothing special here. I believe you already learned in the separate lesson what a git reflog is. Here you may find the reflog. If you would do mouse right click, you can find additional options that might be useful for you. And the last thing that I wanted to share with you today is to show you how you can resolve merge conflicts in Eclipse. Especially for that, I prepared separate branch where I reproduce merge conflict state. How to reproduce and what merge conflict is, Please feel free to learn in the separate lesson dedicated to the merge conflicts. In this lesson, I will put a stress only on the Eclipse tools to integrate with Git. Here is a separate branch with the merge conflict in it. I called the branch merge conflict demo. Usually, when you have merge conflict, Eclipse highlights to you files in which you have merge conflict with red dots like this. So now it is impossible to miss file with the merge conflict. When we open file, we see the Git signs where Git separated for us different state of the file from different snapshots. But Eclipse offers special tool to merge conflicts in files. Let me show it to you. Mouse right click on File, Team, Merge Tool. Here on top you are going to see commits hash that have conflict. Usually you can't edit text in the window on the right, but you can modify text in the window on the left here. You can click this arrow to place everything from the right window to the left window. When you are going to have more conflicts, there will be different arrows for each specific conflict. And after you modified the file on the left, you can press Ctrl and S to save the file. If we would check the same file in the text editor, we are going to find that all signs that Git put here are removed. Great! In the Git staging, you can put file to the staging area to mark conflict as resolved. When conflict is resolved, you may see small asterisk on the file. And after all conflicts are resolved and there are no more red dots, you can open Git bash and continue either rebasing or cherry picking, something what caused the merge conflicts. I believe we learned a lot today about Eclipse and Git integration. Now, I want you to take your time and click as much Git related buttons as possible to learn the material better. The best thing to learn this is to practice as much as you can. Meanwhile, let's recap what we have learned today. Today we learned how we may interact with the Git with the help of Eclipse. We learned what views in Eclipse we may use to execute Git commands. Also, today you saw how you can execute basic Git operations from Eclipse. Besides the Eclipse configuration, we also learned how to use Git bash directly from Eclipse. Today, we even did a commit and pushed that snapshot to the remote repository. And at the end of the lesson, I showed you how you may use merging tool in Eclipse. Hope you enjoyed the lesson. Thanks a lot for your attention and see you in the next lesson. Hello dear students, in this lesson we are going to discuss an important topic. You would use knowledge from this lesson during your whole life as a software engineer. Today we will talk about exceptions and how to handle exceptions in Java. I will explain what exceptions are. We will talk about hierarchy of exceptions. After this lesson you will understand what checked and unchecked exceptions are. Besides all this, we are going to learn how to handle exceptions. You'll learn what try-catch block is and what finally block is. We'll learn different variations of catch blocks. In this lesson we will also talk about how to declare that some method will throw exception. You are going to learn what specific is with throwing exceptions during inheritance and methods overriding. And at the end of the lesson you'll learn how to create your own custom exceptions to meet requirements of business logic. During the lesson I will share with you best practices and tips how to work with exceptions in Java to help you handle exceptions like a pro. Let's start from understanding what exception is. I will explain you in simple words. Imagine that you wrote a logic for your online store, and content managers may now upload information about products to your program. Managers store information about products in specific files with CSV format. That is comma-separated values format that is widely used in transferring and storing data. We will face with files of such format in the nearest future. We will not focus on the specific file format. Just imagine that managers can upload information with products to your program by passing specific file. And what if manager passes the file name and file path that doesn't exist on the file system at all? That is exceptional case. Your program doesn't have predefined logic by default to handle that. That is called exception. Your program can't predict that users who will interact with your program will pass invalid link to the file. It is not an issue of your application, that is technical limitation that all users should respect. But what to do in this case? We have to catch this exceptional case and write a code that would tell what to do next in such cases. For example, Do we want to inform our user that file doesn't exist and let him or her to upload file one more time? Or do we want to just ignore this fact and inform users that 0 products are added? Product owners can come up with numerous cases how to handle this case from user experience side. But we have to implement that. Does this example make things clearer? Can you understand now what an exception is? Okay, if you understood this example, let's move on. The next example would be a bit more technical. That's why let me show it to you on the real code example. Imagine that you implemented methods that should charge user during checkout process. We call it charge user. And this method takes user object as an argument and amount of money to charge. Especially for this example, I created simple class user that contains only one field, amount of money, and 2 methods, getter and setter, to manipulate with the state of this type. This simple user class will keep you focused on our example. Imagine that we want to update amount of money in user object. That's why you call setter method to set amount of money that is less than current amount by the order price. But for some reasons, there is no user object behind this reference. How this can happen? There are dozens of reasons. Database didn't return you information about the user, or some error happened on database side, or in case you want to take information about user from current web session, but user is logged out in another web browser tab. I can continue if you want, but I want you to understand that there are always chances that something will go wrong. And at the end of the day, user variable will reference to the null. When we will call methods on null reference, we are going to have a null pointer exception. Here's an example. In main method, you can see that I created user variable that is referencing to null value. That is just for the sake of example. In real life, in this line can be retrieving user from the database or from the session. For this example, it doesn't matter. And here I have order price. I want to charge my user during the checkout. I pass this variable to the method. Can you guess what will happen? You are right. My program will be terminated because of null pointer exception. Let me run this program to prove you this. And here's null pointer exception as I promised. I have it because I tried to call method some behavior on the object that doesn't exist. So there are no methods for null values. This is also an exceptional case in our program. Program can't understand what it has to do in case there is no object. And now, when you understood what an exception is, let's categorize them. There are 2 groups of exceptions, checked and unchecked. What is the difference between them? Let me explain in simple words. Null pointer exception that you saw is unchecked exception. It isn't checked during compilation time. Moreover, why it should be checked at compile time? If developer wants to call method on some object, developer should ensure that the rest of the program is written in the way to pass not null value to this method. And if there is null, there is no error of user interaction with the program. There is a defect in the way how program is written. On the other hand, checked exception is an exceptional case that is checked during compilation time. For example, user passed the file name to read from. This kind of errors is checked at compile time. Why? Because in this case there could be case when user will pass the file name that doesn't exist. And this case is obvious, and it doesn't depend on developer. So, checked exceptions exist to predict errors of user interaction with program, and they can be verified at compile time. Unchecked exceptions usually appear during the runtime and can't be checked beforehand. Can you understand now what checked and unchecked exceptions are? You already saw null pointer exception and understood unchecked exceptions. Before learning of hierarchy of exceptions in details, I want you to understand the example of checked exception. Here is the files class that contains methods to read content of the files and write content to the files. Imagine that we want to read text from file. And here, instead of this text, it can be that I have some variable that is passed to my program by user, for example. And you can see that in this case there is a compilation error. unhandled exception of type IO exception. And you can see that compiler checks a potential exception, and compiler insists on handling the exception. In other words, compiler wants us to write the code here that would tell what to do in case the file wasn't found. So one of our tasks today also to learn how to handle exceptions in Java. But before that, I want to complete the topic of exceptions hierarchy to make sure you understood it. So, you already saw in real examples what is checked and unchecked exceptions and what does that mean. Now let's look at exceptions hierarchy to understand what types of exceptions exist and whether they are checked or unchecked. And you already know everything in Java is an object. That means our exceptions are also objects of specific type. That's why on this slide you can see a hierarchy of classes that are used to create exception objects. On top of the hierarchy we have throwable class. That is basic class for all exceptions, and instances of this type are checked exceptions. Throwable is extended by two other key types. They are error and exception. Error type and all its descendants are unchecked. Why? Because errors are type of exceptional cases in our program execution when something went completely wrong and there is no chance to fix this already. There is no need to handle this type of exceptional case because you even won't be able to do anything. For example, out of memory error. If you are in the position when your app ran out of memory, there is even no memory for you to create a new object. Does it make sense? Another example is Stack Overflow error. It is thrown by JVM when stack memory is finished. Thread death error is thrown when you try to invoke a method on the thread of execution that was already stopped. And again, there is nothing what you can do about this. That's why all errors are unchecked. And another hierarchy is hierarchy of exception types. All descendants of exception type, beside descendants of runtime exception type, are checked, and only runtime exception with its descendants is unchecked. That is something that we just have to remember. I know that this might seem not logical to you, but it is as it is. The most popular checked exceptions that are extended from exception type are a group of IO exceptions. Those are exceptions that are associated with input-output streams. Also, there are a group of checked SQL exceptions. Additionally, you can explore hierarchy in your source code editor by reviewing hierarchy of exceptions. If you missed the lesson when I explained how to do that, I will show you this in a minute. And runtime exceptions, those are exceptions that are not checked by the compiler during compilation process. There are such exceptions as null pointer exception, as we already saw today, arithmetic exception, you saw this when we divided int on 0, class cast exception that is thrown when it is not possible to cast types, illegal argument exception, no such element exception, array index out of bounds exception. Those are all unchecked exceptions that are consequences of development errors. Compiler won't be able to check those because those can be identified only during the runtime. Is it clear? Awesome! Now when we learned hierarchy of exceptions, it is time to start look at examples and understand how we can handle exceptions. By the way, before we start, I promise to show you how you can explore type hierarchy in IDE. First of all, I open a type. I press Ctrl, Shift and T simultaneously to open exception type. And when I opened exception type, I press F4 key. And here on the left you can see that I opened type hierarchy. And I can scroll and navigate here to explore hierarchy of type exception. Hope this will help you during your self-education. And now let's get back to exceptions handling. As we already discussed, there is not so much sense to handle unchecked exception. You still can do that for some specific reasons if you want, but in most cases it is better to fix your code to not face with runtime exceptions at all. That's why during the next examples I'm going to use checked exceptions for demo purposes. Do you remember example with reading file that doesn't exist? Let me show you now how we can handle that exception. You have to surround the code that potentially can throw an exception with try-catch block. The syntax is simple. You write try keyword followed by brace. After that goes code that potentially can throw an exception. and after that you write catch keyword and declare a local variable of type that you wanna catch. In our particular case, we wanna catch IO exception. In case exception will be thrown, we will get into this block. So, here object of IO exception will be created and this local variable will be used to get access to the exception object. Why do I need this? In real life, you use reference to the exception object to log stack trace and to review it later. Here, for the sake of example, I retrieve an array of stack trace elements and print it in one line. Also, you can get root cause of the error in case there are any, or get message if there is any. For debugging purposes, we can print stack trace to console. Let me run this program to show you that we entered catch block. And here you can see tags that we printed to console from our catch block. Can you understand now how you can catch exceptions? If yes, then let's proceed. Now, let me show you another example. There is another syntax that allows you to use multiple exceptions in catch clause. Let me open another file. Imagine that you wrote code to handle IO exception, but now we also have code to get connection to the database. This method, getConnection, also can throw an exception. That's why you have to handle potential SQL exception. There are two options to do that. You can add an exception to existing catch clause like this by using OR operator. In this case, I tell that this variable e will be either of type IO exception or SQL exception. Because in case exception will be thrown in this line, we will instantly get to the catch block and we will catch IO exception. And in case exception will happen in this line, we will get to catch block and we will have SQL exception. This syntax works just fine if you wanna program the same behavior for multiple errors. For example, if we want just log error and that's it. But in case you wanna implement different logic to handle different exceptions, you have to implement different catch block. For example, in the first case, let's notify user that this file doesn't exist and ask user to provide path to a new file. In other case, let's notify user that there is an error with database and there is nothing what user can do about this. Does it make sense? Can you understand now when to use catch block with multiple exception types and when to use multiple catch blocks? Awesome, let's move on. There is one more rule for multiple catch blocks. In case there are potentially two types of exception that are from the same hierarchy, you have to specify the most specific type first, and only after that specify the most generic type. Let me show you this in example. Imagine that this line can throw IO exception, and constructor of a file reader can throw file not found exception, and we can write multiple catch blocks. But important thing here is that file not found exception is a child type of IO exception. When exception will be thrown, each catch clause will be checked. That's why you can't specify catch block with IO exception before catch block with file not found exception. In this case, you're going to have compilation error, unreachable catch block, because exception will be handled by the first catch block with generic exception type. Let me uncomment this code to show you this compilation error. And here you can see unreachable catch block compilation error. This example is very popular in tests during the interview, so please remember that. Okay, if you understood how to work with multiple catch blocks, let's look at the next example. Before the lesson, I also created another file to demo you the next case. Now I want to review with you try catch finally construction. By default, finally block will be executed with and without exception. Here you can see the same case but with finally block. Let me run this program again. And here in console you can see the text that we printed from our finally block, right after the stack trace. In some particular case you can use try finally block. Let me comment these lines, and you can see there is no compilation error. Usually we use final block to perform operations that should be executed no matter what happened, either exception happened or not. The code from final block should be executed. For example, in the past finally block used to close input-output streams. Now, try with resources block is used to close resources automatically. I will show you that during the lesson about input-output streams. Today you can use finally block to release some critical resources. Finally block will be executed all the times, but there are some exceptions that can prevent you from executing finally block till the end. Let's quickly review these cases. The first case. Finally block won't be executed in case program is stopped in finally block. That is the case when we stopped JVM. Finally block won't be executed till the end in case some exception will happen inside the finally block. Also, in case you have multi-threading program, finally block won't be executed till the end in case thread will be terminated. Now, I believe you know everything about finally blocks. Let's move on. I want to tell you now about throws keyword. For example, let me open the source code of read all lines method. Here you can see throws keyword. What does that mean? That means that this method potentially can throw an exception. In your custom methods, you would also like to specify that some method throws exception if you want to warn all clients of your code to handle some specific cases. In this case, it is specified that I have to handle I/O exception. Now, let's create custom method and declare that it throws exception. I open another demo file that I prepared before this lesson. You will be able to find reference to all files from the lesson in the lesson attachments. In this example, in class throwsDemo, I have some method that throws file not found exception. After that, I create an object of throwsDemo class and call some method. Let me uncomment this line, and you can see that there is a compilation error, because I have to handle potential error. And I have to do that even in case I don't have any code in this method at all. So, this throws declaration is like a warning for everyone who is going to use this method. There is some rules that we all have to know while overriding methods that throw exception. Let me show it to you on the example. In this file, for the sake of the demo, I created one more class that extends throwsDemo class, and I want to override some method. And you can see that I don't necessarily have to add throws declaration here, and that is fine. I can add throws declaration if I want. 1 second, let me add it here. Now, this method also throws file not found exception. May I throw other exception? What about I/O exception? Let me try. And now we can see compilation error. Exception I/O exception is not compatible with throws clause in throwsDemo some method. Now you know the rule. If you want to declare that some method throws exception, and you want to do this for overridden method, you have to specify compatible type of exception with the one from original method. So, in this case, we can specify either file not found exception or some child of file not found exception. This type of exception doesn't have any child types, but we can create if we want. I will remove this throws declaration. Now you know what throws keyword means. What to do in case you want to stop program execution in case there is some error? You have to throw an exception. How to do that? Let me show it to you. I navigate to file with the new example. Imagine that we have method that can transfer money from one account to another. It is called transfer money. It gets account from, account to, and money to transfer amount. By the way, for the sake of the demo, I created account class here in the same file. And the rule of thumb is to validate that all arguments are valid, and we can work with them. Here you can see if clause, where I check that from and to accounts are not null and that from account has enough money to perform a transaction. In case either one of these statements is true, that means that one of the argument is invalid, and we can't proceed with this method execution. That's why I want to stop program execution with illegal argument exception. I write throw keyword and create an instance of illegal argument exception. I can use any instance of any type that extends throwable class after throw keyword. In this particular case, I use already predefined type of exception. Let me execute program and call this method with null accounts. And I can see here illegal argument exception. That is how you can throw any exception you wish. Is that clear? Take pause and think for a second about this construction. If you understood it, let me explain you the next thing. Each type of throwable has constructor that takes string as an argument. This string is used as a message to our exception. Let me add here in constructor some message. For example, invalid arguments. And let me execute this program again. And here in the stack trace you can see explanatory message. Moreover, in case someone would like to catch this exception, each throwable has method getMessage that can return this string. But this is only in case you want to retrieve this message. What else we can do? Sometimes developers wrap checked exception with unchecked. When we have to do this? We have to do this in case when we have to throw exception during the implementation of the method that doesn't allow us to throw exception, but we should. This is really specific case, but we will face with it the first time when we will learn multithreading topic. I will explain you that run method in runnable interface doesn't throw exceptions, but sometimes we have to. There are also some other cases. I want you to learn this trick and use it when it is needed. Let me uncomment this line and explain you how it works. Each throwable type has a constructor that takes other throwable as an argument. This is used when we want to set an original cause for the exception. Here I throw runtime exception and pass to its constructor original exception. Let me run the program now. And here in console you can see that runtime exception was caused by file not found exception. In case somebody would catch this error, he can extract cause. Every type of throwable has method getCause that can return the reference to original exception. So, that's how you can wrap checked exception with unchecked exception. And the last but not the least thing for today, I want to teach you how to create your custom exceptions. In case you want to express some specific case and business logic with your custom type of exception, you have to decide first, do you want to create checked or unchecked exception? To create an unchecked exception, we have to declare our class that extends runtime exception, in case we want to implement an unchecked exception as I said. Let me open class with declaration of custom exception. Here we have not enough money exception. It is unchecked because it extends runtime exception. In case you want to implement checked exception, you have to just extend your custom class from exception type. That's all. Easy, don't you think so? For the sake of our demo, I'm going to keep not enough money exception unchecked. And now, when we have our custom exception, let me look at another version of the transfer money. In this version, we throw illegal argument exception in case from and to accounts are null, and in case there is not enough money on the account for money transaction, we throw our custom exception not enough money exception. Hope this example helps you understand when we might want to use custom exceptions and how we can do that. Now, let's review what we have learned today. Today we learned a lot of things. Now you know what exceptions are. We learned a hierarchy of exceptions. Also, you learned what checked and unchecked exceptions are. On examples, we learned how to handle exceptions. You saw how we can use try-catch blocks and try-catch finally blocks to handle exceptions. In this lesson, you learned what throws keyword is and how you can use it. We learned how to throw exception when we need. And at the end of the lesson, we learned how to create our custom checked or unchecked exception. Hope you found this lesson useful for you. Thanks a lot for your attention. See you in the next lesson. Hello dear students, in this video I'm going to make overview of Java Collections Framework. I want you to understand general structure of Java Collections Framework before we start going deeper in the details. And here's our agenda for today. We'll talk about what GCF includes. In this lesson you are going to learn the difference between collections and arrays. We are going to discuss what advantages collections have over the arrays. Also during the lesson we are going briefly to talk about two separate hierarchies in Java Collections Framework. That is hierarchy of collections and hierarchy of maps, and what are the difference between them. I believe this is going to help you significantly to understand the course structure and the next lessons in general. So, let's start. And to start with, let's answer the question, what does GCF, I will shorten Java Collections Framework if you don't mind, what does it consist of? GCF is a unified name for the group of the types and algorithms that are developed to store elements in them and perform manipulations on the group of the objects. GCF includes next things. Collection interfaces. These are abstract data types that describe the types that may group multiple elements in the single unit. As a software engineers, we are going to use collections all the time to perform operations with the group of objects. For example, product list in our web application. This might be a collection of products in the language of Java. And we could perform operations on the group of the products. For example, sort products or filter them to keep only products that has price more than $10, or split all the group of products on the equal chunks to show products page by page, and a lot of other things. Can you understand now why we might need collections? You may think, isn't that the same what we have arrays for? Taking into account you used arrays already, you might think that for the same purposes you would use arrays. A bit later, when we would talk about advantages of collections over arrays, you would understand why arrays and collections are two different things. Implementations of collection interfaces. Even despite the fact that abstractions for collections look the same, the implementations of this interface are different and fits for different goals. For example, some collections work the best for adding new elements at the end of the collection, and developers like that collections because of the constant time of retrieving elements from them. Other collections work better when you need to add elements in the middle or at the beginning of the collection. Other collections work the best in the concurrent environment. We are going to learn all these collections and to understand the difference when to use each collection type. Map interfaces. Map interfaces are different from collections in one important thing. Map is a container that contains pairs of key and value. For example, you may store the name of the product category, for example doors, and collections of all doors associated with it. You may have boots category, and collection of boots associated with that key. And in case you need to get all doors, you just make a request to the map, passing only key to it, to retrieve all doors. Does it make sense? Maps are also considered a part of Java Collections Framework because even if they don't have the same interface as collections, they have operations that allow us to view and interact with them the same way as with collections. Implementation of map interfaces. During the course we are going to discuss different implementations of the map, and we are going to understand when we will use each implementation of the map interface. Deprecated collections. Deprecated collections are also part of the Java Collections Framework. Despite the fact that it is recommended not to use specific collections, sometimes on the Java project you're still going to work with them. Because even nowadays there are a lot of old projects written on Java that require support and maintenance. Synchronized collections. There are also a special set of collections that are developed to be used in a multi-threading environment. Let me tell you the example to make you understand. Imagine that you have collections of users, and one administrator of the website removes the user from the collection, and another administrator of the website is iterating over each user in the same collection to update the state of the total orders amount. The conflict might appear when two administrators in the two separate threads of execution would update the same collection. In this course, I'm going to tell you how synchronized collections work and how to use them. Algorithms. Also, GCF includes algorithms. They are the methods that perform useful computations such as searching and sorting on objects that implement collection interfaces. The algorithms are said to be polymorphic. That is, the same method can be used on many different implementations of the appropriate collection interface. Wrappers. GCF contains a special wrappers that can turn your regular collection into non-modifiable collection, or wrapper that can turn your regular collection into synchronized collection that you can use in multi-threading environment. Now, when you know what Java Collections Framework consists of, let's discuss what advantages does it have over arrays. Let's go over this table to compare collections and arrays. This table will help you to understand what advantage collections have over arrays. First of all, you already know that arrays in Java have fixed size. Collections in Java can be extended dynamically. So, using collections, there is no need to create a new collection and copy the state of the previous collection into the new one when you run out of space in this old collection. This is a significant benefit for the development process. Secondly, arrays itself don't have any behavior and algorithms to work with them. For example, arrays can't filter themselves, or find the first index of appearance of element, or keep all elements sorted automatically, or have only unique elements and do not add elements that already exist in collection, and a lot of other things. If you remember arrays class, you may say that some of the algorithms are present in arrays class to work with arrays. But the amount of operations that you can do with arrays class is significantly lower than the number of algorithms that Java Collections Framework has. And moreover, we mentioned separate class and static methods in arrays class. That is not the same as behavior of the object like we have in collections. Thirdly, collections have single API, and no matter what is the specifics of each particular implementation of the collection, whether it stores only unique elements or supports reading of elements during the constant amount of time, it doesn't matter. All collections have common API, what significantly simplifies usage of collections and learning them. On the other hand, working with arrays, each developer may implement his own application programming interface to interact with array. For example, developer may come up with a method to add new element in array and extend it in case there is no more place in the array. Or developer may come up with a specific algorithm how to clear all elements in array. One developer will just create a new array with the default array size, another developer would just turn into null values all current elements in array. And you already may see the problem in such approach. There is no single API when you are working with arrays. By having such data structures and algorithms as collections, developers may concentrate on the important parts of the program rather than on the low-level work and inventing the wheel. Fourthly, what you need to remember, collections can store only reference types of data. Collections doesn't work with primitive types of data. If you want to store primitive types of data, because of the performance reasons, you still have to use arrays. And last but not the least, performance. Usually it is considered that performance of arrays is higher than performance of collections. While this can be true, in the modern world, in the most of business cases, we are talking about milliseconds difference for standard operations and for standard number of elements in either collection or array. But you have to know about this. I believe now you have the vision of what we are going to learn and what Java Collections Framework is. As you can see, there are really a lot of things to learn. Right now, let's recap what we have learned today. In this lesson, we learned what Java Collections Framework contains. On the high level, we understand what collections are and how they are different from maps. During the lesson, we reviewed main advantages of collections over arrays and also discussed what advantages arrays have over collections. That's all for now. Thanks a lot for your attention and see you in the next lesson. Hello dear students, in this lesson we are going to learn what collections are. This is a very important topic because collection interface is implemented by all collections implementations in Java. That's why understanding of collection interface is a key for understanding of all other collections in Java. So, today our primary focus is learning of collection interface. I'm going to show you UML class diagram. We'll understand what it is and how we can use it in the future to understand a type structure. During the lesson, we'll understand what methods collection interface has and why do we need them. We will review abstract and default methods of collection interface. And at the end of the lesson, we'll look at the collection source code. Let's start. I suggest starting our lesson from this slide. On this slide, you may see visualization of what collection is. To understand collection, imagine the bag. The big bag where you may put all your stuff. You may put there your product, user, card, and all other objects. And you can't retrieve exactly user or product or card by its index like you did in array. What you can do is to put all things from your back on the floor and go over them one by one. We are also going to learn in the separate lesson the specific type that is developed to go over each element. What else we can do with this back? To answer this question, let's take a look at collection interface and we'll learn what else we can do with our back of elements. Here is the class diagram. We are going to learn with you UML language, that is Unified Modeling Language, in detail a bit later. But this is what is used to call class diagram, and while being a software engineer you are going to see such diagrams very often. What do we have here? We can see that collection interface extends iterable interface. Iterable interface we are going to learn in the separate lesson, the same as iterator. But in short, this is the interface that stands on top of all collections interfaces, to make sure that it will be possible to iterate over each element in each implementation of collection interface. Today we are going to focus on collection interface and we will start learning it from this class diagram. Let me give you a quick introduction regarding symbols here. You can find indication whether this type interface or no. That is our interface text right above the interface name. We can see that iterable and collections both are interfaces. Here we can see list of methods that each specific type has. Plus sign means that this method is public. After that goes method signature, that is method name and method parameters followed by colon. And we can find return type right after the colon. For example, the first method in the list in collection interface is size method without parameters that returns int value. Does it make sense now? This knowledge will help you to understand class diagrams written down on UML language. And let's answer our original question. What else we can do with this back? We can check number of elements in it. That is what size method does. We can check if this back is empty or no. We can check if this back is empty or no. That's why we need isEmpty method. We can ask our back with elements, does it contain some specific element or no? Contains method will help us with this task. We have also methods that can turn collection of elements into array of objects and methods that can turn collection of elements into the array of specific types. For example, if your collection contains only elements of product type, we can convert our collection into array of product elements, but not into array of objects if we don't want. Can you feel the difference? After that, we can see methods that we already kind of discussed. That is add method. I can add element to the collection. I can also remove element from the collection. And to remove element from the collection, I have to pass this exact element. Another important behavior. We can check whether this collection contains all elements that other collection has. That is our contains all method. We can add all elements from one collection to another. To do this, we have to use add all method. And we can remove all elements from the current collection that other collection has. That is our remove all method. I believe you can see on the slide that methods that we have just discussed take other collection as method argument. If you want, you can keep only elements that are present in both collections. To do this, we have to invoke retain all method and pass the reference to another collection into it. In other words, this method removes from the current collection all elements that are not present in the collection that we passed as a method argument. The methods that are left here are self-describing. Clear method will remove all elements from the collection. And as you already know, equals and hashcode methods, that are the methods that each object should have. But the idea of specifying equals and hashcode methods in the collection interface is to put stress on the fact that these methods should be implemented in any implementation of collection interface, and that these methods should override default behavior from object class. And the last but not the least method in collection interface is the iterator. Pay attention to the iterable interface description now. It is also in collection interface because it implements iterable interface. As you can see, iterator method returns object of iterator type. In short, this object will help you to iterate over each element in your collection. We are going to learn what iterator is in the separate lesson. That is our collection interface. That is something what you have to remember. We just have such interface, and what we can do is just to remember it. Just as in alphabet, we don't ask why A letter is written exactly in this way. We just learned that this is A letter and how it sounds. And when we know that, we start building words with this letter. The same is here. We just have to learn collection interface and learn how to use it. So here on the screen you may see only abstract methods that should be implemented in each collection. But there are few more other default methods in the collection interface. What are they? To answer this question and to give you advice how constantly learn new things and check information that you get not only on this lesson, but in any tutorial, always investigate the source code of your JDK version. I believe you remember how to add source code to your code editor and where you may find it. Let's open collection type to investigate the source code and find methods that we didn't learn yet. I press Ctrl, Shift and T simultaneously. Here I have to type collection. I need collection from Java util package. And here it is. And here on the right we may see the list of all methods that are present in this interface. It looks like we went over all abstract methods. How I learned which method is abstract? Can you see the small a letter? That stands for abstract. But we didn't cover in our presentation methods that have D letter near. What are they? Here is the overloaded method to array. It just takes specific functions that will describe how to convert collection to array. To be able to apply this method, we have to know how to write in the functional style in Java and understand what functional interface is. Don't worry, this topic also will be discussed in the separate lesson. Just want you to understand at least on the high level what these default methods are about. Remove if method. This method takes predicate. Predicate is a specific type that can return true or false. Based on the specific function that you will pass as a method argument to this method, it will identify which element should be removed. For example, you may describe functions that will return true in case product price is more than $100. And in case this function will be applied to this specific product in collection, it will be removed. And this function will be applied to each element in the collection. You may find while loop here and see that iterator is used to go over the collection to test the condition for each element in the collection and remove it in case it satisfies the condition. Also, there is a default method that creates split iterator. Split iterator is a specific type that can traverse and make parts of elements of the source collection. And here is the method that exists in all implementations of collection interface. Stream method turns your collection into stream of elements, or in other words, sequential stream of elements. Stream API was introduced in Java version 8 and it was a breakthrough. In this course, in the separate lesson, we'll learn Stream API and we'll learn how to use it. As a practical exercise, we'll even rewrite our home tasks with the help of the Stream API. And here is a method that returns parallel stream. According to documentation, it returns possible parallel stream with the current collection as its source. Now let's recap what we have learned today. Today we learned what a collection is. We tried to imagine a collection as a bag for our understanding. Today you saw your first UML diagram, class diagram. Now you know how to read class diagrams to understand the type description. We reviewed all abstract methods in collection interface, and after that we reviewed collection default methods. Also, during the lesson we investigated source code of collection interface. That's all what I have for you for today. Thanks a lot for your attention. See you in the next lesson.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Hello team, in this lesson our goal to understand the main descendants of collection interface. Before going deep, I believe it is very important to understand the big picture and learn three main interfaces in collections hierarchy. Today we'll hold high-level overview of such interfaces like list, set, and queue. According to our agenda, we are going to start from the overview of the class diagram of collection interface with its main descendants. After that, I am going to explain you in simple words what are key differences between three interfaces and why we need them. I will explain you what list is, set, and queue. During the explanation of the queue, we are going to learn what FIFO principle is. Today's lesson will help you to understand the further structure of our lessons and understand the core hierarchy of collections. Let's start. Here is our class diagram. This one is the extended version of the one you saw in the previous lesson. I believe you are already familiar with collection interface. Now let's look at the most popular child interfaces of collection interface that we are going to learn. There are three interfaces that extends collection interface and that are implemented by all the collection implementations in GDK. They are list, set, and queue. They are all collections, but each interface is introduce new behavior or new quality of implementation of collection interface by extending it. Why do we need these interfaces? Let me briefly go over each one. Let's start from the list interface. You already know that collection is just a bag where you can put all your elements. The list interface introduces an ordered collection with the possibility to manage your elements by their index. In more simple words, list is an ordered collection of elements, with all benefits that follows from that statement. We can add element to the specific index in the collection, we can get element by its index, and we can replace existing element at the specific position. To set the new element in the specific position, we have to use set method with a specific index and element. If we want, we can remove element from the specific position in our list. We can get the index of the first occurrence of the element in the specific collection and index of last occurrence of the specific element. To perform these tasks, methods index of and last index of should help us. List also allows us to get list iterator. List iterator that is extended version of the regular iterator. In the separate lesson about iterators, I will explain you the difference. Sometimes we may want to create sublists. For example, to process big amount of data, we may split our list into 4 equal chunks and perform any operations we need in 4 separate threads of execution. I believe you are aware that Java supports multi-threading, and a bit later in the course I am also going to teach you that. Besides new abstract methods that were introduced, there are also 2 default methods that are absent in collection interface and that are present in list interface. They are replace all method. This method will take a function that can transform element of one type to the element of the same type. We may want to use this method when we want, for example, transform all string objects in the list to the string objects in the lower case. Sort method allows us to set the algorithm and to tell exactly how we want to sort elements in the list. A bit later we are going to learn such functional interface as comparator. Now let's proceed with the collections hierarchy. Let's talk about set interface. What do you think? What new methods are introduced in the set interface in comparison with collection interface? No one. The set interface doesn't introduce new methods. Then why do we need it at all? Let's recall what a set is from the mathematics. The set is a well-defined collection of distinct objects. The set interface is the main interface for the hierarchy of containers. By the way, collections are often called containers. So set is the main interface for the hierarchy of containers that contains only unique elements. There are different implementations of the set interface. During the development of GDK, engineers come up with the decision that they need to distinguish collection of elements and the set of elements somehow. The best decision was to introduce new interface. So, during the development, engineers may declare variable of type set. That wouldn't give us new methods to manipulate with elements in the container, but this instantly will give us the vision that this container contains only unique elements. To understand how implementations of the set interface work, we need to learn map interfaces first. You are going to understand later why. And now, let's review one more interface. Here is queue interface. There are a few new abstract methods were introduced here to manage the queue. They are offer, to insert an element into the queue. Remove, this method retrieves and removes the head of the queue. But in case there is an empty queue, the method throws exception. What is an exception? A bit later we are going to learn how Java programs may handle exceptional situations of program execution. Right now, you can understand exception like something what is not in expected way of program execution and what may potentially interrupt the program in case there is no code written that handles the exception. Poll. This method also retrieves and removes the head of the queue, the same as remove method, but with only one difference. In case queue is empty, there is no exception. Null value is returned instead. Element. This method retrieves but doesn't remove element from the queue. The same as remove method, it throws exception in case queue is empty. Pick method also retrieves but doesn't remove element from the queue with only one exception, that in case there is an empty queue, null value is returned. That's all new methods that were introduced in queue interface. No other default methods were introduced. Queue is needed when you need to implement first in, first out principle, so-called FIFO principle. Imagine that you process support requests and you need to process them in the specific priority and according to the date when you received them. The support tickets that you received the earliest, exactly these tickets should be processed first. And here you can understand what the queue is. The first support ticket that was received by queue, the first left the queue. I've already prepared super interesting home task for you to improve our online store and to practice your skills in writing queues. But that will be later. So right now I believe you understood the three main sub-hierarchy that goes right after collection interface. And also the structure of the next lessons should be clearer for you now. During the next lessons we are going to learn each interface in detail with all methods and to learn the most popular implementation of each interface. I want you to understand theory first, before we start coding. Believe me, this is very important. But very soon you would beg me to stop coding examples, promise you. Now let's review what we have learned today. Today we have learned what are three main descendants of collection interface. Now you know why we need list, set, and queue interfaces. Moreover, after this lesson you may understand the difference between them. While explaining what a queue is, we learned FIFO principle. Now you're ready for the next lessons. Thanks a lot for your attention. See you in the next lesson. Hello dear students, today we are going to talk about implementations of the list interface. We are going to discuss such implementations as array list, vector, copy and write array list, and stack. We have a lot of things to learn in this lesson. Besides the learning of the specific classes, we are going to answer the question when you have to use each particular implementation of list interface. I am going to share with you real-life examples where we will use list implementations. Today, during the lesson, I am going to show you the tool that will allow you to investigate the hierarchy of classes in Eclipse. During the lesson, we are going to compare different implementations of the list interface so that you could understand what pros and cons of each implementations are. In this lesson, we are going to compare only array list, vector, copy and write array list, and stack. Also, we are going to learn what marker interfaces are and what is random access interface. So, as you can see, we have a huge agenda for today. Let's don't waste our time and start our lesson. In previous lessons you already learned what list is, but let's try to answer the question, when we have to use list. In my opinion, list implementations can cover the requirements of the widest range of business cases. Why? Because of the next reasons. Support of data manipulation by elements index. You may want to retrieve product from specific index in your list of products. Or you may want to put user in the list of users in the middle of the list by its index. Or probably you always want to add the new users at the beginning of the list but not at the end. The possibility to use index to manage element positions gives you a lot of options for data manipulations that will help you in different business cases. Another reason? List implementations may contain duplicates. Sometimes you just need to have a container that would store all your products, for example. And you don't care about duplicates there. You just need to have list of all products, period. That's why we choose list over set sometimes. One more reason, possibility to create sublists. This feature is really attractive one for some specific business cases. Let me share with you one example from the real life. We implemented mobile app for the betting tips. In this app, we received data from the server. We stored the data in the list. There was such domain type as sport prediction data. Each sport prediction was done for the specific sport event that may happen either today or yesterday or tomorrow. So, developers created sub-lists of the sport prediction for yesterday, today, and tomorrow. We created 3 lists instead of 1 by splitting the original one. Why? We could pass the one list to each widget to draw the list on the UI interface only for specific date. That's it. By the way, here is the UI of the sport app. Interesting? You will be able to create similar apps, so don't worry. To implement such application, you have to know implementations of the list interface. Let's move further. Sorting. And again, one more feature that collection interface doesn't have. We may sort our betting tips based on the level of probability. That really improves interaction with the app. Moreover, I can offer user to sort sport prediction either by probability score or by betting tip author rating or by anything else. Wide range of use. And one more important reason to opt for list implementations, and this reason probably is the most important one that is not written in any book that you read. Engineers use list implementations the most of the times because they just don't need neither set nor queue implementations. Developers just need some container to store multiple elements in there and treat them as a single unit, without any extra features. Okay, now when you know when and why we opt for list implementations, let's investigate list hierarchy. On this slide, you may see that list interface is implemented by abstract list class. Abstract list in turn extends abstract collection and is extended by abstract sequential list. From this diagram, you may see that array list is extended directly from the abstract list, the same as vector and copy and write array list. And linked list is extended from abstract sequential list. Stack class extends vector. Engineers doesn't like stack for that because stack is not the list by its essence. It is closer to the reverse queue, to the DAC interface. We are going to learn it later, but because of the backward compatibility, creators of GDK didn't change anything here. Is it clear? Because stack in its essence implement last in first out principle, but it extends list interface but not DAC. Even despite this class will not be used very often by yourself during the development, you might be asked about it during the interview. That's why I decided to mention it here. What is also worth to mention is an implementation of random access interface. Today, during the demo, I am going to show you what random access interface is and what marker interfaces are. To proceed our lesson today, I suggest jumping to the Eclipse to investigate the source code. That will help us to learn the topic better. And to start demo, I'd like to share with you the trick that will also help you in the future during the development. Namely, I'd like to show you how you can easily find implementations of each interface and review the whole hierarchy. For example, here is the list interface. I should put the cursor into the editor area and press F4 button. Or you can also make mouse right click and select Open Type Hierarchy here. And we can see that the separate widget is opened here. Here I may see items that extends or implements list interface. For example, here's our abstract list. We can make double left mouse click to open it. And here we may find our array list. As you can see, there are really a lot of classes over here. We'll not learn each of them. Instead, we'll focus only on those that you will use during your work. Let's start from the most popular implementation of list interface that you will use in 98% of cases. That is just my assumption, but you would tell me later if I was right. Here is array list class. Why people love array list? Because it's really fast. In more simple words, array list is array with dynamic size. But this is in very simple words. Array list use regular arrays inside to store elements. Here it is. The variable is called element data. It may store array of objects. That means that technically we can put everything in this array. But we can't, because this field has package private modifier. Okay, then you might be wondering, If array list uses regular array to store elements, then it should have fixed size. Is that correct? That is correct. Arrays in Java have fixed size, but not the array list. Let me show you the code that adds element to the collection. Here is the add element method. It updates modification count variable first. Don't pay attention to that right now. After that, it calls another add method. I hold Ctrl key and press mouse left click. Okay, here is the private method. And you see the first line? We have if statement here. We check if s equals to the length of the array, then we initialize our element data array with the new array. Before we go further, let's look what this s variable is. I hold Alt key and press arrow left key to move back to the previous position where I was. And we see that the third argument in this method is a size variable. Size is also one of the fields in ArrayList class. Now let's get back. I keep Alt key pressed and also press arrow right key to get back to the place in the source code where I was before. Now you know that s is a size. What does grow method do? Let me answer that question. Okay, this method calls another grow method with int argument and passing size +1 there. And what do we have here? We see that int argument that we passed to this method is used to define desired minimum capacity. You may see here that old capacity is equal to array's length, and in case old capacity is more than 0, we calculate new capacity. How it is calculated, I suggest you to investigate by yourself by going deeper in method invocation chain. By the way, you may see here a bitwise shift, and it is great that by this lesson you already know how it works. If you don't know, please review my lesson from the Java course about operators. And after that, we use arrays class to copy our current array to the new one with the new capacity, and we return the reference to this array. So now you can understand that when there is no space for new element in the array, the values from the old array are copied to the new array with the new size. Okay, but what happens if we have just created object of ArrayList type and it's empty? Let's check the default constructor. We can see that element data is initialized with the empty array. This is constant empty array. But why do we need this default capacity constant? To answer this, let's get back to the grow method. Pay attention to the if clause here. If old capacity more than 0, and we know that when array list has been just created, its size is 0. And the second clause is if element data is not equal to default capacity empty array. We know that this statement is also false because we initialized our array with this constant. So that's why our flow of program execution goes to the else block where we initialize our element data array with the array of the length 10. Why 10? Because it will take max value between 10 and 1 during the creation of array. Does it make sense now? As a part of your homework, I would encourage you to go over each method in ArrayList like we did with add method to understand how array works. Probably you might be wondering whether you can create an array list with a specific capacity. Yes, you can. ArrayList has special constructor for that. Here it is. Why you may need to create an array list of different capacity? Let me explain you. Imagine that you created an array list with capacity of 10 elements. That means when you will add 11th element and after that 16th element and so forth, each time Java should copy the values from the previous array and add them to the new array. That would cause some spikes in our performance. Then, if you know that you are going to add to your array around 1 million elements right after creation of the array list, it is better to set capacity at the beginning to avoid some spikes in the performance. If we specify capacity for 1 million elements, we will avoid case when we constantly copying arrays and creating new objects of arrays, keeping the old arrays in our heap memory until garbage collector would remove them. Is it clear now why you might want to create array with the initial capacity? Great, let's move on. There is also one more interesting use case. Imagine that you added million elements to your array list, and after that you removed 9,100 elements. Okay, there is a 1,100 elements in your array list. But what's its capacity? Its capacity is still 1 million. To remove null elements from our array inside ArrayList, we may call trim2size method. This method trims the capacity of the ArrayList instance to the list's current size. Okay, now you know how dynamic array extension happens in ArrayList. I also promised you to explain what random access is. Can you see that ArrayList implements random access? Let's take a look at this interface. Can you see that this is the empty interface? It doesn't declare any contract for any behavior. Then why do we need it at all? Random access interface is a marker interface. Sometimes in JDK you would see so-called marker interfaces. Why they are called so? They called so because the only reason why they exist is to mark interface with a specific type to use this information in the future. Probably it is still not clear for you, but let me show you on the example. Here is the random access interface, which is used to mark any class that supports retrieving of element for the constant amount of time. That's actually one of the key features of ArrayList. The constant amount of time for reading any element is because of the nature of ArrayList and how it works under the hood. To read any element, you just need to get it from array by specific index, and this time is usually constant. That's why ArrayList is marked as an implementation of random access type. Now let's see where this information is used. If we would open collection class, this is class with utility methods. Don't worry, we will learn it in the separate lesson. Right now I just want to show you how information about marker interface is used. I press Ctrl and F key simultaneously to search through this file. And I want to search for random access word. And I have around 58 mentions. You can see that random access is used with instance of operator in if clauses to select specific algorithm that will work the best. Here in binary search method you may see that in case list that were passed as method parameter to the method is compatible with random access type, then indexed binary search algorithm will be applied. If no, then iterator binary search method will be called. And similarly, in the other methods, check for compatibility with random access interface is used to select the best algorithm. Right now, I believe you understood the use case and how marker interface may be used. That's great. According to the agenda, we also are going to cover today a few more classes. They are vector, copy and write array list, and stack. While covering those, I will be super fast because they are mostly the same as array list. So, I will draw your attention only to the things that are different from the array list. Here is the vector class. It is almost the same as array list. The same mechanism of storing data. Here is the element data array to store elements. There is only one big difference between ArrayList and vector. All methods in vector are synchronized. What does that mean? Let's take a look at the add method, for example. Can you see the keyword synchronized in the method definition? We didn't learn yet this keyword in detail, but we will. We will learn it in the details during the multithreading topic. But right now, you can understand this keyword as a restriction for multiple threads of execution enter the method body simultaneously. That means if two threads of execution want to add element, remove element, or replace element as a specific index, they won't be able to do this simultaneously. All these operations will be performed one after another. That would save you from the data inconsistency inside the vector. That's why vector is called thread-safe container. Does it make sense? Okay, let's go further. Let me open copy and write array list. The same story is here. Copy and write array list is a thread-safe version of the array list. Then what is the difference between vector and copy and write array list? Copy and write array list was introduced in Java version 5, while vector was introduced in the version 1st. In version 5, engineers come up with improvements in performance for the thread-safe version of array list. And we can say that copy and write array list is more efficient from the performance standpoint in comparison with vector. For example, let me open add method. Can you see this? There is no synchronized word here, but synchronized block instead. The way how synchronization is implemented in this class is different from the way it is implemented in vector. That is the difference between vector, array list, and copy and write array list. And now let's open the stack class. As you remember from the beginning of the lesson, stack extends vector. But take a look at the methods that are introduced in stack. What does this remind you of? You are right. That is almost interface of the queue. The names of the methods are almost the same. Engineers don't like stack because this is concrete class. That means there is no flexibility in using different implementation of the same API. It implements LIFO principle, last in first out. We are going to review this principle in the details when we will get closer to the queue interface. So, don't worry for now. The LIFO principle is implemented in DAC interface and in different implementation of that interface. But stack was introduced in Java version 1 and keeping promise of backward compatibility and to make sure that programs that are written on Java version 1st will be successfully executed on the Java version 15th and later, this class is still here. That's it. Now you know also the difference between array list, vector, copy and write array list, and stack. Now let's recap what we have learned today. Today we investigated the hierarchy of list interface. You saw how you may investigate source code and view hierarchy of any interface in Eclipse. Also, in this lesson we learned when we have to use implementation of list interface, such as array list, vector, copy and write array list, and stack. We learned in detail how size of the array may be dynamically increased in the array list. Now you know the difference between array list, vector, copy and write array list, and stack. During the lesson, we learned what marker interfaces are. On the example of random access interface, we learned how marker interface might be used. That's all what we have for today. Thanks a lot for your attention and see you in the next lesson. Hello team, today we are going to discuss one more implementation of list interface. I am talking about linked list. In this lesson we are going to learn how linked list works. We are going to review the source code and understand when we are going to use it. Also, we'll compare linked list and array list to provide you with the answer what list implementation you are going to use most of the times. Besides that, today in lesson we are going to have a lot of practice and I will share with you home tasks that will help you to practice your knowledge in lists. Let's start. And first of all, let's understand how linked list works and why it is called so. This is double linked list. Why it double linked? Let's look at the slide. This container consists of multiple objects of node type that connected between each other. Each node contains some data, linked to the previous node and linked to the next node. That's why each node has two links. That's where the name of the container comes from, linked list. It is double linked because each node has the links to the next and previous element. Does it make sense now? Let's review the real example of linked list. Take a look at the slide, please. For example, we have our first node, A node. It contains value 1000. Take into account this is the first element, the link to previous element is null. But link to the next element is linked to the B node. B node also contains value, that is 2000. Link to the previous node, that is A node. And link to the next node, C node. C node is the last one. That's why link to the next node has null value. And on the slide you can see that linked list always stores the reference to the first and the last node. It is clear now how a linked list is built? Understanding of this will help you a lot in understanding where and when you might want to use linked list. To proceed our lesson today, I suggest investigating the source code of the linked list. Here is the source code of the linked list class. As you remember from the previous lesson, it extends abstract sequential list that contains implementation of some list methods. Here you may see two fields of node type. I believe from their names it is clear where they are referencing to. The linked list always stores the reference to the first and the last element. Let's investigate how adding new element to the collection works. I want to open add method. Here it is. We can see that link last method is invoked here. Okay, let me investigate that one. New variable of the node type is created and initialized with the last node in the linked list. After that, new node object is created. Special constructor is called. We are passing reference to the last node, element that we want to add, and null value. Let me open this constructor to investigate what is happening there. And now we may receive two answers. The first answer is on the question what is node class. As you can see, node is a static nested class, and it's private. That means that instances of the node class can be created only from the linked list class. You also may notice that it is not so big and it doesn't have any behavior, only state. The state of the node class is described in three fields. They are item, next, and previous. And the second answer is in this constructor. So, the first argument is used to initialize previous variable. The second method argument is used to initialize the value of the current node. And the third method argument is used to initialize the next variable. Now, when we know this, let's get back to the add method. And when new node is created, last variable is pointing out to the new node. And in case last node was null, that means list was empty. Thus, new node should become the first element in the list. If no, then we have to change the next reference in the node that was the last not so much time ago. What I want you to understand, that to insert elements in linked list, it is enough just to change references to the previous and the next element. That's it. If you remember array list that we learned in previous lesson, you should already know that in array list we always need to copy values from previous array and to create new arrays if we want either remove elements from the middle or beginning of the list or to insert elements at the beginning or in the middle of the list. In the linked list, these operations may be done much faster and significantly easier. Also, I'd like you to pay attention to the fact that linked list implements DAG interface. Let me open it. DAG interface extends queue. This is lesson not about queue and DAG interface, but it is hard not to mention that linked list is also one of the most popular implementations of the queue interface. And to be honest, I used linked list more often when I needed implementation of the queue, but not implementation of the list. Why? I'm going to explain you this in a minute. So, knowing this fact, don't feel wondered why linked list also has such methods as add first, add last, remove first, remove last, get first, get last, and others. Now you know that linked list must give implementations to this method since it implements DAG interface. We will not review these methods today since this is lesson about implementation of the list interface, but we'll discuss the other methods for sure during the lessons about queue, so don't worry. Now, I suggest practicing a bit with using linked list and array list. For the sake of the demo, before the lesson I created this demo file. I will leave link to it in the lesson attachments, and if you have all my training project cloned from the GitHub, just pull the latest changes. Let me also run this program and we will explore console output together. Okay, at the beginning here I created two variables of type list, both of them initialized with array list objects. Do not forget to do imports. Eclipse will remind you to do that, so don't worry. You also can see that the first list here is underlined with yellow line, the same as array list here, but in the next line there are no any warnings. What is the difference between these two declarations? Probably you already saw in the source code this diamond operator, but you couldn't understand what does that mean. Let me explain you this on the next example. I add string object to the list 1, and I also add integer object to the list 1. Now my list 1 contains objects of different types, but all of them are compatible with the one type, object. That's why when we want to get element of this container, we always get object of type object. Can you understand why? Because Java compiler doesn't know what object will be on the first index in the list and what its type. Now let's look at the second list. I also can add string in it, but I can't add integer because this would cause compilation error. Why? This is called generic mechanism. We are going to have separate lesson where I'm going to describe you generics in detail, but right now you have to understand it at least on the high level, because this will help you during the homework implementation. Here in diamond operator we specify type of elements in this list. That is sign for our compilator that in this list we will store only string objects. We also have to specify diamond operator here next to specific collection implementation. Before the Java version 7, engineers should also specify type here. But after Java version 7, in case type is the same as it is specified for variable, we can keep it empty. This would be the same as in case we would specify type here. That's why compilator allows only add string objects there. Pretty cool feature. Don't you think so? This saves developer nerves when we get object from the container, call some method on it, and we see some exception, and program stops execution, because somebody in some other method put in the container object of incompatible type. And when compilator is sure that we'll store only string objects there, we also can retrieve objects of the string type. For example, here when I get element from 0 index, I get object of string type. Hope this brings some clarity on how you may use diamond operator. More advanced scenarios and how generics work will be reviewed during the separate lesson. Okay, let's move on. Here you may see that I initialized my variable of list type with linked list object. And this is one of the advantages of Java Collections framework. Here it is. We may change implementation of the list, but the application programming interface is the same. I still may use the same methods and count on the same result. That's why all examples that you are going to see in this and in the next lessons will be the same for different implementations of the specific interfaces. For example, if we are reviewing list interface, you may use different implementations of the list. All of them have the same set of methods, but the way how these methods works inside are different, and that may impact on your decision which list implementation to choose. Does it make sense? Now, let me share with you the tip and the popular way to initialize some lists. All lists implementation have constructors that takes collection of elements and initialize new list with these elements. Arrays class has asList method that takes multiple parameters of the same type and returns the list, which in turn we use here to pass it to the constructor of ArrayList. So, here is the example how you can initialize your list with multiple elements in one line. For learning and debugging purposes, you always may pass list implementations to the println method, because all list implementations have toString method overridden to display elements in such way as you can see here in console. Also, another important and practical thing to share with you. All collection implementations can be used in for each loop. I believe that you remember that collection interface implements iterable interface. This fact guarantees that each implementation of collection should have iterator method that will return iterator object that knows how to iterate over the collection of elements. That's why all collections can be used in for each loops according to Java syntax. And you can see example here. So, now you remember that all arrays and everything that implements iterable interface, even if this your own custom class, may be used in for each loops. And here you can see example of clear method. What I would recommend is to play with other methods like I do here. Call clear method, call other methods and investigate console output. Writing code and calling different methods will help you to understand material better, and probably that would cause some questions, and I will be always happy to answer those. Now, when you know how to use list implementations in Java source code, I suggest understanding what list implementations you have to use in which particular case. And to make a choice, I'd like to explain you what big O notation is. Big O notation is a mathematical notation that describes the limiting behavior of a function when the argument tends towards a particular value or infinity. We are not going to do math in this course, but we need to understand big O notation while working with different implementations of collections. In computer science, big O notation is used to classify algorithms according to how their runtime or space requirements grow as the input size grows. In very simple words, big O notation can tell us how efficient algorithm as number of elements that algorithm work with increases. We are going to use only few classes of functions. Let me explain you what they mean. O1. That is constant. For example, get an element from array by its index is always constant. On. That is linear class. That means that performance of the function directly depends on the number of elements. For example, function of finding element in unsorted array has On notation, because you have to check each element one by one to find the exactly one you need. This operation takes time, and the time will depend on the number of elements. Does it make sense now? O logarithm n. That is logarithmic class. Function of finding element in binary tree has O log n notation. For example, imagine that you have sorted array of elements. If you are looking for specific value, you can predict in which part of the array it is most likely stored, and you shouldn't iterate exactly over each element. We are going to learn what binary trees are in the next lessons. Right now, you can understand this as something what still depends on the number of elements, but the dependency is not linear. I try to say this as easy as possible without going deep in mathematics. Believe me, when you will see this on practice, that would be much easier. Now, I'd like to answer the question which implementation of list to use and when. The first thing you have to answer during the interview in case you would be asked what would you use, linked list or array list. You should ask in which environment we plan to use list implementations and regarding amount of data. To answer when to use which implementation, let's review performance of each list implementation, and based on this, we will give an answer. Now let's compare big O notation of array list and linked list. Here on the slide you can see big O notation for different operations for array and linked lists. Let me go over each one. Get operation in array list is constant. That's why we see here O1 notation. When on the other hand, get element from linked list has linear complexity. And I want you to not memorize big O notation, but understand it instead. Can you understand why retrieving elements from linked list is a linear function class? Correct, because we have linked list without indices. And to get any specific element, we should iterate over each element unless we would reach exactly the one that we need. Linked list also defines from which side of the list to start. If index in the second half of the list, then iteration starts from the end of the list. In case index is in the first half of the list, then iteration starts from the beginning. Does it make sense? Okay, then let's move further. Add elements to the list. Array list adds always for constant amount of time, the same as linked list. I'd like to make a note here. This notation is from the book Java Generics and Collections by Philip Wadler. You may find it on the internet if you wish, and I want to say that this is an average value listed here. Why? Because adding elements to the end would take constant amount of time in both containers, but for array list you already know one exception. That is the case when arrays inside the array list is expanded and additional time is needed to copy all elements from old array to the new array. Also, there is another note. Adding elements at the beginning or in the middle of array list would also trigger creation of the new array, and depends on the actual size of the array, this can take some time. Even despite native method written on C++ is used to copy an array and it works really fast, on huge amount of data that may cause some performance issues. That is something what you have to remember. Let's move on. Remove operation. This algorithm in array list is linear and is constant in linked list. And I believe you already understand why. Because to remove element from the middle or beginning of the array list, we have to copy array, and again, the time that it will take will depend on the number of elements. The things are completely different in linked list. There we have to only change the references to the next and previous element. That's why algorithm of removing elements is constant in linked list. Now let's make conclusion based on these facts. We have to use linked list when we plan constantly add elements at the beginning or at the end of the list. We also should opt for linked list when we want to remove elements constantly from the beginning of the list. If we plan to use container to always add elements to the end and read elements from the list, then array list is our choice. But I told you that algorithm of array copying works really fast, and everything will depend on the amount of data that we are working with. I'm going to give you a home task where you would be able to test whether linked list really has advantage over array list while working with not so big amount of data. But I will give you insights even before you finish that task. In majority of cases, even during the work with 1 million of elements that are relatively small objects, array list still is going to be faster rather than linked list. And with regards of the business cases, I would say that array list is your choice almost in 99% of cases. The rest of the cases are when you need either thread-safe container or you have millions of objects that you need to add in the beginning of the list and constantly remove them. I believe you would agree with me that it is even hard to come up with example here of such case. Time for linked list will come. When we'll talk about queues, we'll discover that linked list works the best for us if we need implementation of queue or DAG. Now let's recap what we have learned today. Today we learned how linked list works. Now we know what the node type is and how nodes are connected between each other in linked list. We had a practice with linked list and array list. Now you even know how to use generics. We learned what big O notation is. And using this knowledge we compared linked list and array list. Now you know in which case you have to opt for either array list or linked list. And now I suggest reviewing your homework. I have a lot of tasks for you today. All of them has different level of complexity, but nothing what we didn't discuss. So the first exercise is to test and compare the performance of array list and linked list. It is not complex from the coding standpoint, but it is also good for you to practice with creating objects of different types, declare variables, and to remember in which case you have to use which container. Here is the guidance what methods should be created and methods declarations. And here operations that I'd like you to test. We are going to insert different number of elements into the beginning, middle, and at the end of the list. We'll test these operations with 100, 10,000, and 1,100 elements. Also, we'll test removal of elements from the beginning, middle, and the end of the list. We'll perform the same operations with array list and linked list. And we'll measure how much time execution of specific method takes with array list and specific number of elements and linked list. After you're done with coding, I want you to fill out these tables. You may see that these tables have different rows and columns based on which list implementation you used and what operation you did. If you are wondering how you can measure the time of method execution, here is a small hint for you. You can capture time before some method execution, after that call some method, and after that calculate delta. This value you can insert into the table. After you finished, you may compare your results with my results and to evaluate the trends. I don't want to make any conclusions right now, primarily because some of them we already discussed during the lesson, and the other reason is that I want you to draw your own conclusions. The second exercise here is to update existing backend system for online store. It is a console application and you may find it in this repository in this package. This solution uses arrays. Your task is to substitute arrays with list implementations. You are provided with a sample project here. Your goal is not to break anything and to make sure that all scenarios work as expected. This task should give you a clear understanding of how you are going to use list implementations in your applications. And the last but not the least task is to create your own implementation of custom list interface. You have to create interface first with such content, and after that you have to create class and to implement this interface in it. Team, I promise you, in case you would implement these 3 exercises, you would understand list implementations like nobody else. Remember, learning programming it is about coding and a little bit about reading, but definitely not vice versa. And by the way, you also shouldn't worry in case something is hard for you to implement. We are all learning new things here. I'm going to leave links to the solution in attachments to this video. So even in case you can't complete some of the tasks, feel free to look through my solution and rewrite it very attentively. and always ask me questions in case you have any. That's all for today. Thanks a lot for your attention and have a great day. See you in the next lesson. Hello dear students. In this lesson we are going to learn what comparator and comparable is. We'll review these two interfaces and we'll answer when we have to use them. After the lesson you will understand the difference between them and will never confuse these two interfaces. Today, on real example, I am going to show you how you can sort your collection of elements. We are also going to learn what a quick sort algorithm is. Let's start. And today, the best way to learn the topic is to jump directly to the Eclipse and investigate the source code. We are going to start our lesson today from comparator interface overview. Comparator interface has only one abstract method that you have to implement in your own implementation. The method name is compare. This method takes two method arguments. This may be different reference types as you can see here, but they should be the same. This method according to the interface contract should compare two objects and tell us what object should go before the other one. How it can tell us this? By returning int value. Everything is simple here. In case first argument is less than the second one, negative integer is returned. In case first argument is equal to the second argument, then 0 is returned. And only in case first argument is more than the second one, in this case positive integer is returned. And this function is enough to sort all elements in your collection according to the quicksort algorithm. A bit later today we are going to learn how quicksort algorithm works. Right now let's investigate what else we have here in the comparator interface. We have here abstract equals method, but it will have implementation in any your class, because each class is extended from object. An object class has implementation of equals method. That's why equals usually is not overridden in comparator implementations. Now I want to share with you information how you can quickly get comparator for natural and reverse ordering. Here is reverse order method. It returns comparator that sorts items in reverse order. But what is reversed order? To explain you this, let me open demo program that I prepared specially for this lesson. Let me also run it to explore console output together with you. Imagine that we have list of integers. We have 1, 15, 2, 37 and 100. And it is obvious for us what the natural order of these numbers is. The same as it is easy for us to understand what a reversed order is. Each list has sort method that takes object of comparator type as an argument. Let's call sort method for our list and pass reverse order comparator into this method. And after we printed to console the same collection, we notice that our collection becomes sorted in the reverse order. But the things that are obvious for us are not obvious for the machines. I believe you understand that for Java it is not obvious by default how to sort numbers. There should be some code written that would tell Java to sort our collection exactly in this way. So let's understand how to describe logic of natural ordering. To explain you this, let me open integer type. And here we can see that integer implements comparable interface. What is this? Let me open this one. Comparable interface declares the contract only for one method, that is compare_to method. It takes another object as a method argument and can compare this, the current object, with the object that was passed into the method. And you already can see the difference between compare and compare_to methods. Compare method takes two arguments. Compare_to takes one argument. In more simple words, comparator interface tells us something like this. Give me two elements and I will tell you which one is greater than the other one. Whereas comparable interface tells us something like this. Give me an element and I will tell you if it is greater than me. Can you feel the difference? Usually comparable interface is implemented by types when we expect that objects of this type will be sorted in containers, like we have with the integer type. Creator of integer class foresaw that objects of this type will be compared between each other a lot of times in the future. Let me open integer class again. Let me show you how compare_to method is implemented here. You can see the internal method compare is called here. We pass there the current value of the integer object, because integer object has value variable, and we also pass int value of another integer. Let me open this compare method. And here we can see that in case the first argument, that is x, is less than the second argument, that is y, then we returns negative integer, -1. And in case the statement is false, we check if x and y are equal. And if they are equal, we return 0. And if no, that means x is greater than y, and we have to return positive integer. That is 1. To be honest, I still don't know why developers of GDK decided to write so many texts here. Imagine that in case you have two integers and you need to compare them. Just write here x minus y, and that's it. In case x is lower than y, we would get negative number. In case they are equal, we will get 0. In case x is greater than y, we will get positive integer. Sometimes guys from Oracle overcomplicating the things, really. But as true professionals, we have to understand this and respect their solutions. According to the contract, compare_to also returns int value to sort elements. The way how compare_to method is implemented in the type is called natural order. So, I believe now you understand how Java made reverse comparator. It is required just turn positive result of this method into the negative and vice versa. Let's get back to our example. Now imagine that we want to sort elements in natural order. In the comparator interface there is also another default method with the name natural order. It looks like that is exactly what we need. You already know what natural order is, and you can understand how numbers in our list will be sorted. Things are pretty straightforward with the list of integers. But what will happen with our list of products? Here I created a list that contains all products from our online store application. In case you skipped homework, I will explain you. We created our own service that is default product management service that implements singleton pattern and can be created only in single copy. That's why we call getInstance method here. This class contains all products for our app. Products are described with the help of another custom type, product type. If you want, you can explore this class in the details, don't worry. I will leave a link to this class, it is still located in our training project that I am sure you all already cloned from the GitHub. So, when we fetched all products, we print them to the console, each product from the new line. I created custom method for that, nothing special, just for each loop, that's it. Please don't pay attention to this wildcard in the method signature, we'll talk about that when we will learn generics topic. What happens when we try to sort products in natural order? We see compilation error. Why? Because our custom product type doesn't implement comparable interface. So what we have to do now? We have two options. Either we have to implement comparable interface in our product type, or we have to implement our own comparator that would contain the logic to compare elements. Let me show you all these options. To save the time during the video lesson, I created a product type that implements comparable interface, and by default, we sort products by ID. To implement comparable interface, I added one more interface here after implements keyword. You're already familiar how to use generics with lists. Here's a similar thing. I specify product type here in diamond operator to tell that our comparable implementation should compare product type. This generic usage allows me to get product type in parameters here in compare_to method instead of pure object. And to sort elements by ID, I just perform subtraction here. We already reviewed on previous examples in which cases I return positive, negative or 0 here. That's why I suggest moving further. Now, when we have comparable product, let's create few objects of comparable product type and add them to the list. In the real app, probably you would extend product interface from comparable interface, or you would implement some abstract product type where you would implement comparable interface, and you would use that level of abstraction across your whole application. That's just a few ideas to think about. Now in case we would sort comparable product, we would have all our products sorted according to IDs. And as you can see, it doesn't matter in which order we added our products to the list. But what if we want to sort by product name? And natural ordering doesn't work for us. In this case, we have to implement our comparator. We have 4 ways to implement comparator. They are: declare anonymous class, create separate class, write lambda expression, use method reference. Today we are going to review first 2 options, and the rest 2 we will learn in the separate lessons when we will talk about functional programming in Java. We have our list of products where products don't implement comparable interface. Let me use that one for sorting. I write new comparator and specify product type in diamond operator to tell Java compiler that this comparator will work with product type. And after that I am going to declare anonymous class. In case you missed my Java lesson about anonymous classes, please check that. It will help you for understanding of anonymous classes. And here I gave implementation for compare method. The second option is to implement separate class. You can create separate file for that one, but for the sake of the demo, I will declare another class in the same file here, to keep all code examples from the lesson in one file. So, I have product name comparator class that implements comparator interface. The implementation is the same as we have in our anonymous class. I can sort my products by passing the reference to the object of my comparator. So, these 2 ways to sort elements are similar. It is up to you which one to choose. I am going to give you a home task where you may practice in implementation of comparator interface. If you want me to answer what is better, comparator or comparable, I wouldn't answer that question. Using of any of these interfaces depends on the real case. For example, you need to sort elements by specific field in one method. Then comparator usage would be justified. In case you don't have possibility to rewrite the type and implement comparable there, you also have to use comparator in this case. But if you know that objects of your type will be sorted on regular basis, during the creation of the new type you can consider implementation of comparable interface. Does it make sense? Before we proceed, I want to finish overview of methods in comparator. We have overloaded then comparing method, which I would say not used very often. Originally this method is built to create chain for comparison logic in case elements are equal. But to be honest, you can write the same logic in one method. But it is also worth to mention that such architecture would allow you to be more flexible in describing your comparison logic and to use different chain of comparators in different situations. While this brings a lot of flexibility, I can't come up with an example right now or any business case where this flexibility will be needed. We also have here null first and null last methods that return comparators with a specific logic for sorting null values. And here are also different variations of comparing method. Those are pretty interesting. For example, we can call comparing method and pass functions there that will extract the field that we want to use for sorting, or extract the field and override natural ordering for it by providing another function. In return, we will get comparators that we can use to sort elements. Review of these methods lies outside of our today's agenda, but we will definitely talk about these when we learn functional programming topic. The last thing for today that I want to discuss is to answer one of your potential questions. Taking into account this is video course, I always try to predict what questions you might have. But in case I didn't answer all your questions in video, feel free to post questions under this lesson. Probably you are wondering how a function that takes only 2 arguments, that is our compare method, how it can sort all elements. That is because algorithms with the name quicksort is applied. This is not the course about algorithms, but I believe for the general understanding it will be useful for you to know how quicksort algorithm works. As I said, I am not going to dive deep into the details. Someday I will create course about algorithms and we are going to learn all algorithms in a nutshell. But right now I want you to look at this GIF image. It explains exactly how quicksort algorithm works. Quicksort algorithm, it is still a commonly used algorithm for sorting. When implemented well, it can be about 2 or 3 times faster than its main competitors, merge sort and heap sort. The algorithm finds pivot element and after that split all elements into two subarrays. Comparing each element with pivot element, algorithm sorts element by telling whether particular element less or greater than pivot. As we go over each element, we constantly compare two elements and swapping them. That's why Java needs methods that can compare two elements. If you would open source code of the sort method, you would discover that compare method will be called multiple times until all elements will be sorted. Now I believe you understand why we need to pass two parameters into our compare method. We did a great job today and learned a lot of things. Let's recap what we have learned today. Today we learned what comparator is. We also learned what comparable interface is. We learned how to sort elements in list by using natural and reverse ordering of elements. Now you know what the difference is between compare and compare to methods. On real examples we learned when we need to use comparator and when we need to use comparable. We created our custom comparable product and created comparator for existing type. And at the end of the lesson we learned quick sort algorithm. Now I suggest reviewing your homework. In your homework you have to implement comparator in the separate file that would sort products by category names, then by price and then by product name. Here you may find links to the product interface type and implementation of product interface. Also here you can see a list of products that you can use during the testing. I believe that you will be able to accomplish this task easily. I believe in you. That's all what I have for you for today. Thanks a lot for your attention and see you in the next lesson.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Hello team, in this lesson we are going to talk about what iterable and iterator interfaces are. We would investigate source code of these two interfaces and also will answer what is the role of these two interfaces in Java Collections framework. After this lesson you will never confuse these two interfaces. We are going to learn three types of iterator. And at the end of the lesson I also want to demo you what list iterator is and how it is different from iterator. Let's start. I believe you remember that first time when we looked at collection interface we found that collection interface is extended from iterable interface. Do you remember that? As you can see on this class diagram, iterable interface has only one method, iterator. This method should return object of iterator type. That means that each implementation of collection interface in Java should have iterator. I believe that is all what we can say about iterable interface. This interface is to tell that I'm the type that has iterator. More interesting to talk about what an iterator is. And to answer this question I suggest reviewing source code of iterator type in Eclipse. In few words, iterator is a type that can go over each element in container. That's it. You might be wondering, is it really so hard and separate type is needed? It is not so hard. But imagine two simple cases. You have array list and linked list. In array list we have to get elements from the array by their indices. In the linked list we have to get the reference of the next node from each node to iterate over elements. Can you see that the way how to iterate over each element, even in these two collections, is completely different? That's exactly the reason why we need to come up with some abstract type like iterator to set the interface that should be implemented by specific implementations of collection interface. So, let's sum up what iterator is. Iterator is an interface that allows access to the elements in container and navigation in collection, including iteration, or in other words looping, over each element in any collection without knowing the details of implementation of specific collection. Now we are going to learn the interface of iterator type. It has two abstract and two default methods. Let me explain what each of these methods is about. HasNext method returns true or false. It tells us whether the next element is present. We'll use this method in loops to check if it's worth to go on with our loop, or we reached the end of the collection and we have to break the loop. Next method returns the next element in collection. Be careful. This method may throw no such element exception and interrupt your program execution in case you called next method, but there are no any elements there. That is the contract of the iterator interface. We can do nothing about that. That's why before calling next method we have to always call hasNext method. Remove method. Supposed to remove the last element returned by next method. And now attention, this method can be called only once after each next method call. We can't call 2 times next method and after that call 2 times remove method. That is the way how iterator should work. In case you would call remove method without calling next method, or will call remove 2 times in a row in your program will be stopped with illegal state exception. But there is more interesting thing here. By default, remove method throws unsupported operation exception. That means that in case we would call this method, our program will be stopped with the exceptional situation. Now I'm going to say not only my opinion, but opinion of different engineers too. It is senseless to declare a method in the interface that is not needed. Yes, exactly. This exception here, unsupported operation exception, tells us that by default this method is not supported. Don't do that during implementation of your interfaces. Why? Let me explain. Here we can see violation of one of the solid principles. Can you guess what solid principle is violated in the iterator interface? Exactly. I principle, interface segregation principle. According to this principle, no client should be forced to depend on methods it doesn't use. Originally, according to the documentation, iterator type was created to iterate over elements, but not to remove them. How would I recommend implementing this? I would create something like removable iterator that extends iterator type and would let client of my code to decide whether they need remove method or no. Because right now each implementation of iterator interface has a remove method even if it is not overridden there. This is default method and there is no need to override it. But this doesn't make life of engineers easier, because we still can call remove by mistake and rely on the fact that this behavior should be supported in iterator. Now you know that there is an exception here. The other side of this violation is that in case in Java Collections Framework engineers would follow all OOP principles, including interface segregation principle, there would be big bank of interfaces that is hard to learn and hard to remember, and even harder to maintain. So, as you can see, programming, like everything else in our lives, is all about trade-offs and compromises. The last but not the least method here in iterator interface is for each remaining. This method takes functions that should be applied for each element that remains in the container. The usage of this method requires knowledge of functional programming in Java and knowing interfaces from the Java util function package. That's why today we will not demo work of this method, but we will demo it in the lesson about functional programming. Okay, now when we know iterator interface, I suggest learning how it works and to practice a bit. And I'd like to visualize the way how method next and remove works. Let's take a look at this slide. I want you to imagine that iterator works like a cursor. Namely, at the beginning it stands right before the first element. When we call next method, it returns the next element to us. And now cursor stands between the first and the second element. In case we call next method one more time, cursor is moved to the position between second and the third element, like you see on the slide. Now, when we call remove method, iterator works as a backspace key on the Windows machines. It removes elements that stands right before the cursor. Does it make sense? Now let's get back to Eclipse. For the sake of the demo, I created this demo file to practice a bit with iterator. Let me run this program and walk you through the different cases that are listed here. At the beginning, I created a list of integers to play with. You already know this construction, so there is nothing special for you here. Now let's iterate over each element in container. I call iterator method on our list that returns iterator object parameterized by integer type. This means that when I will call next method, iterator will return object of type integer, like it's specified here in diamond operator, but not the object of type object. After that, we have while loop, and I check in condition statement here whether iterator has next element or no. And if yes, I want to print it to console. Next method returns me the reference to the next element in my container. Is everything clear here? Hope it is. The next example is more like practical tip. Some of my students that I taught offline feel concerned that they can't reuse the same iterator once we iterated over all elements. So, after the previous loop, our iterator cursor is at the end of the container, and hasNext method will return false. That is exactly the reason why we see this console output here. But what to do now? We can use the same variable and initialize it with a new iterator object, because there are no methods to reset cursor of the iterator back again to the beginning, like we did here. So that is fine. Now I want to demo how remove method works. Let's remove all even numbers from our container. We call next method to get element from the container. After that we check whether this number is even, and if yes, then we remove it. You can see that I don't violate the rules of remove method usage. I call remove method only after I called next method. And also, there are no multiple invocations of remove method. You also can notice that iterator that is implemented in ArrayList overrides remove method and doesn't throw unsupported operation exception like default implementation of remove method does. Now, if you are not familiar with the exception topic yet, let me show you an example what exception means and how iterator may throw exceptions. Let me uncomment these lines of code. I initialized again my iterator variable with the new iterator object. After that I call remove method without calling next method. Let me run my program now. And here we can see illegal state exception. The same exception will be thrown in case we would call remove method 2 times in a row. That is something what you have to remember. At the end of the lesson I will share with you home task where you will have opportunity to practice your skills in writing your custom iterators. Let me comment these lines to be able to execute code that is written after this one. Let me also show one more important exception that might be thrown by iterator. That is concurrent modification exception. I will uncomment these lines of code and will demo it to you. Imagine that we created iterator. And when we started iteration, we removed element from the container, but not with the help of iterator, but just by using remove method of our list. This is just an example. In real life, it might happen that you created an iterator on the list that is shared between different threads of execution, and somebody in other thread did some modifications to your list. And after we would call next method, we would see concurrent modification exception. That means somebody modified the collection after iterator had been created. Iterator object noticed that and want to let us know that collection that we are iterating over is not up to date, and that information about elements that I will read with the help of this iterator is not relevant anymore. This type of iterator is called fail-fast iterator. That is default implementation of iterators in majority of collection implementations that are not developed to be used in multi-threading environment. What to do in this case? In case you have iterator, make sure there is no other place in your code where you modify the same collection simultaneously. If you do modify collections from different threads of execution, then you need fail-safe iterator. That is the second type of iterator that usually called fail-safe. Let me comment the concurrent modification demo code to be able to proceed with the next one, and I run the program again. Usually thread-safe implementation of collections also implements fail-safe iterator. To explain you in short how it works without going deep into the details, fail-safe iterator makes copy of the internal data structure and iterates over the copied data structure. Any structural modification done to the iterator doesn't affect the copied data structure. So, original data structure is changed. This type of iterator creates a snapshot and iterates over elements in this snapshot. The drawback of such iterator type is obvious. In some cases, you may not receive latest and up-to-date version of elements in case collection is modified from the different threads. But sometimes it might be not critical for you. Here we have thread-safe list implementation, copy and write array list. I initialize it with the elements that are in our integers list. I create iterator. Interface of the iterator is the same everywhere. That's why I use the same variables that I had created. As I already mentioned, failsafe iterators create the snapshot of the container. To prove you this, here I add another integer to this container. And now when I iterate over elements, and as in previous example I remove elements from collection without iterator, I still print elements from the container to the console. But when I print the collection to console, it has only one number that we added after iterator creation. This proves that iterator creates snapshot with elements, and this snapshot is not updated as we update collection after creation of iterator. There is also a third type of iterator that is called weakly consistent. It is called so because this type of iterator can reflect some, but not necessarily all of the changes that have been made to the collection since iterator is created. Let me show you this. I declare a new variable of collection type parameterized with the integer type, and I create object of concurrent linked deck. This collection implementation has weakly consistent iterator implementation. I create an iterator, and now attention. Similarly to the previous example, I add new integer here. And now when I'm iterating over each element, I can see that new integer already was taken into account here. But as it is said in the documentation, there is no guarantee that all updates to the collection will be taken into account by the moment iterator would reach the specific element. Can you understand now what is weakly consistent iterator? So now we may say that we learned three types of the iterator. The last thing that I would like to learn with you today is a list iterator. Let's look at this interface. The first thing that you can see is that list iterator extends iterator interface. The main feature that is introduced in list iterator is to iterate over elements in reverse direction. If iterator can go over elements from the beginning to the end, the list iterator can go from the end to the beginning. It also declares methods that are absent in iterator interface. They are hasPrevious. It is similar to hasNext method but checks if there are any element in another direction. Previous returns the reference to the previous element in the container. NextIndex to get the index of the next element. PreviousIndex. It returns the element that would be returned by previous method. Set replaces the last element that was returned, and this is important to understand. It replaces element that was returned after calling next or previous method. In case set method is called without calling next or previous method before that, illegal state exception is thrown. Add method adds element to the container. So you can see few more important features of the list iterator. It also allows us to add element to the container during the iteration over elements or to substitute element. Let's look at the list iterator demo now. I created separate file for that. Let me also execute this program. I have the same container with integers as in previous example. The list interface declares list iterator method, as you remember. This method returns us the object of list iterator type. One more interesting feature. We can get list iterator from the specific position if we need. I can't imagine the case when I would use it, but it is an interesting feature to know about list iterator. For example, here I set list iterator as the second index. Here is the position of the cursor in the index 0, here position of the cursor in the index 1, and here is 2. So, the next call of the previous method should return number 2. And now you can see in the console output that 2 is returned. Now I want to update this element. I call set method and pass 20 to this method. So the element that was returned previously is substituted with 20. So my next call of the next method should return 20. And here in console you can see that list iterator works exactly in the way we expect it to work. In case I want to add element with the help of list iterator, I call add method. And the item is inserted right before the cursor. So in case I added 21, I can get it now by calling previous method. And here's 21. And remove method will return the last item that was returned either by next or previous method. In this case, after invocation of remove method, 21 will be removed. And here we printed all elements to console to prove this. Now, I believe you have full understanding of how iterator and list iterator works. Let's recap what we have learned today. Today we learned what iterable is. We also understand what iterator is. Now we know the difference between these two interfaces. On real examples we saw how iterator works. In this lesson we saw what exceptions might be thrown by iterator, including concurrent modification exception, illegal state exception, unsupported element exception, and no such element exception. We learned 3 types of iterator: fail fast, fail safe, and weakly consistent. And at the end of the lesson we learned list iterator and how it works. Now let's review your homework. In short, you have 2 coding exercises here. You have to implement iterator and list iterator for the default myList class that you implemented in scope of your homework about lists. Read attentively all requirements here. I prepared for you method signatures and description of interfaces. All you have to do is implement methods. You will see here some requirements related to exceptions. In case you're not familiar with exceptions topic, there is absolutely no harm, because I wrote the line of code that you have to write when exception should be thrown. That's it. Don't skip this homework, it is important for understanding of the topic. Thanks a lot for your attention. See you in the next lesson. Hello team, today we are going to learn with you another collection sub-hierarchy. Today we will talk about queue interface and one more important interface that extends queue, that is DAC interface. We'll learn methods in queue interface. And I hope you didn't skip lessons, because in previous lessons during the general overview we already talked about queue and discussed methods that this interface has. But today we'll dive into the details. After that we'll learn methods in DAC interface. Today we are going to learn what is the difference between these two interfaces. Also we'll learn what FIFO principle is and what LIFO principle is. After we learn interfaces, we'll take a look at the most popular queue and DAC implementations, and I will share with you practical tips and practical cases. And at the end of the lesson we are going to review your home task and I will explain you how you can practice your skills. Let's start. And to understand what queue is, we have to understand what FIFO principle is. If you don't skip lessons, then you remember that FIFO is a method of organizing of a data structure where the first elements that enter the queue, the first leaves the queue. In other words, the head of the queue always processed first. FIFO stands for first in, first out. Here on the slide you may see visualization of the queue. The queue has the head and the tail. Students usually wondered where the head of the queue is and where is tail of the queue. By convention, the end of the queue at which elements are added is called the tail, back or rear of the queue. The end at which elements are removed is called the head or front of the queue, analogously to words used when people line up to wait for goods or services. Does it make sense now? If yes, then let's answer our next question. Where queue is used? Imagine that you have 2 services. The first service is in charge of onboarding of new customer. This service processes information about the user, verifies his payment method, adds him to the CRM, checks whether this user already registered, etc. Let's call it onboarding service. And another service is in charge of handling all payments from the user for his subscription on monthly basis. Let's call this payment service. Those are 2 independent services, because the first one is in charge of selling subscriptions to customer only on one site. But they are different of the similar marketing sites that promotes different products and services of the company. Our onboarding service is one out of many services. But the service that is responsible for charging clients on monthly basis is used by all websites and systems within the same company. This is real-life scenario that my team implemented. In simplified format though, but still, I believe you got my point. And before process payment information from any of the website, the queue exists. It exists right in the middle between all services and charging service. and all services, including our onboarding service, submits the message in the queue. The message contains payment profile of our customer and product details, and our payment service processes all these messages one by one and implements all necessary logic related for recurring payments. Does it make more sense now? Can you understand now why do we need queues? Hope this brings more clarity and you understand why we need to use queues. Okay, if you understood queues, let's understand what a DAG is. And to understand DAG, we have to understand what LIFO principle is. LIFO is a method of organizing the manipulation of a data where the last element that entered the container should be processed first. LIFO stands for last in, first out. If you remember stack class that extends vector, that is also implementation of LIFO principle. And on the screen you can see visualization of stack. But where we might want to apply LIFO principle? The easiest example of DAG usage which you face with on daily basis is in Eclipse. Have you ever used undo operations in Eclipse? How do you think undo operation works? Each batch of changes is put in the stack, and in case undo shortcut is clicked, the latest operation is removed from the stack. For example, you wrote hello world. The world word is on top of your stack. When you want to undo operation, it leaves the stack first. Or imagine your browser history. You open new pages and then you need to return on the previous page. Or imagine method invocation chain in your Java program. We can call one method from another one and after that call one more method. How to track the flow of program execution? Only with the help of the stack data structure that stores elements according to LIFO method. Does it make more sense now? Can you understand now when do we need stack? Awesome! And now when you understood what queue and DAG is and why we need them, I suggest dive deeper into the details and learn interfaces. Here is a queue interface. We have add and offer methods here. Both exist to add elements to the queue. Both returns true in case element was added to the queue. Then why do we need two similar methods? And why do we need add method here if it is present in collection interface? Let's understand the difference. Add method is present in queue interface to highlight the specific behavior of add method in queue type. Add method adds elements to the queue, but, as you can see from the documentation here, illegal state exception will be thrown in case element couldn't be added because of the capacity restrictions. To be honest, in most of the cases you wouldn't see this error while working with the implementations of the queue interface. Why? Because most of the implementations have no restrictions on capacity and they are unbounded. And in this case, there is no difference between add and offer method. Offer method doesn't throw exception in case element is not added because of the capacity restrictions. It also can return false. Hope this knowledge will help you during the interview in case you will be asked what the difference is between add and offer method in queue interface. Let's move on. We have two methods to retrieve element from the head of the queue and remove it from the queue. They are remove and poll. The only difference between them is the way how they behave in case there are no more elements in the queue. Remove method in this case will throw no such element exception, and poll method will just return the null. What to use in real life? I would say evaluate the logic of execution of your program first. In case you would ask me what method I would use poll method and would just perform null check. I'm just afraid of all exceptions. And I would rather opt for option that doesn't throw exception. But all cases and programming styles are different and I can accept that. And that's why it's up to you which method to choose. The similar situation with the next two methods. We have two methods that allows us to get the element from the head of the queue, but that don't remove element from the queue. They are element and pick. The only difference is that element method may throw no such element exception in case there is no more elements, and pick method would just return null. You already know what I would choose. That's all methods that are declared in queue interface. Let's move further and let's investigate what methods do we have in DAG interface. So, as we already discussed, DAG extends queue interface and it organizes data according to LIFO principle. Let's review methods now that are present here. In the top of our list we can find a lot of similar methods that can work with the head and with the tail of the queue. Add first and add last, offer first and offer last, remove first and remove last, pull first and pull last, pick first and pick last. I believe it is clear how they work since we discussed similar methods in queue interface. Notice that there is no element first and element last methods, if to follow the analogy in methods naming. But do we have methods that doesn't remove element from the queue and throws an exception in case there is no element? Yes, we have. Get first and get last methods, here are they. Here are also two interesting methods. Remove first occurrence and remove last occurrence. When we are referring to the first occurrence, we mean first in case we would traverse elements from the head to tail. So, the first occurrence will be closer to the head of the queue, and the last occurrence is closer to the tail of the queue. After that, abstract methods from the queue go here. add_on method adds all elements to the container, the same as it is declared in collection interface. There is only one clarification, that all elements will be inserted into the end of the queue. And here are stack methods. We already discussed what a stack is, and here are the methods to manage stack. Push method adds element in the head of the queue. This method will throw illegal state exception in case element can't be added due to capacity restrictions. This method is similar to add_first method. This is even specified in Java documentation. Then why do we need it at all? For compatibility reasons, with legacy class stack, the push and pop methods exist. This means they are there only to make transition of old code easier for programmer. The pop method is here and it is equivalent of remove first method. And I believe you already understood why Oracle left this method in this interface. The last method that we didn't talk about is descending iterator. This method, according to the interface, should return iterator object that can iterate over the elements in reverse sequential order. That is from the last element, from our tail, to the first element, to our head. That's all methods that we have in our DAG interface. Now let's investigate the most popular queue and DAG implementations. On this slide you can see the most popular implementations of queue and DAG interfaces. I recommend you pause the video and read this slide attentively. I believe there is no need to investigate each of these classes in details. It is better to put our focus on the most popular implementations. The most popular implementation, in my opinion and based on the official Oracle tutorials, can be split in two major categories: implementations of DAG interface and implementations of just queue interface. In case you need DAG implementations, then most likely you will be happy with linked list or array DAG class. If you need queue implementations, most likely you will opt for linked list or priority queue. If you need thread-safe implementations of the queue, I'd like to draw attention to array blocking queue and priority blocking queue. If you need thread-safe implementations of DAG, then your choice is linked blocking DAG. As you can see, there is really a lot of options. But in my opinion and based on my experience, in 95% of cases when you would need to use DAG implementation to implement some stack, or in case you would need queue, you would use linked list class. The rest 5% of cases is for thread-safe implementations of the queue and DAG, and also priority queue. Taking into account we already had lesson about linked list and we already learned the queue and DAG interfaces, there will be nothing hard for you just to call these methods on linked list. And that's why, for the sake of the demo, I'd like to show you how queue works on the example of priority queue. So here I prepared demo file. I will leave link to this file in attachments to the lesson so that you could copy and run this file on your local computer. Here I declared variable of type queue parameterized with the integer type. Here I created object of priority queue. And in these lines you can see that I added to the queue 5 elements. They are 2, 8, 3, 1, 10. So, in case I'd like to take the first element in the queue, what it would be? Take your time to think about this question, because this is a trick question. We all know how queue works and what is FIFO principle, but priority queue has interesting feature. It automatically sorts elements according to their natural order. Hope you didn't skip the lesson about comparator and comparable, and you know that natural order is an order that is described in compare to method because of implementation of comparable interface. And that's where priority word comes from in the name of the queue. It prioritizes elements. So in case I would print to console the element from the head of the queue, this would be 1, even despite integer object with value 1 wasn't inserted the first. Let me run the program to show you this. I used poll method to get element from the queue and remove it. So the size of the queue right now is 4. Now, in case I call pick method, I get the head of the queue but don't remove element. Here you can see in console output that our next object in our priority queue is 2. And the size after pick method is still 4 because I didn't remove element from the queue. Pay attention to the fact that all elements that you put into the priority queue should implement comparable interface. Because in case type doesn't implement comparable interface, priority queue object would throw exception, class cast exception, that would say that your type can't be cast to comparable type. Let me show you an example. Let me uncomment these lines of code. Here you can see that I create queue parameterized by product type. Just to remind you, product is our custom type that we created during our work on online store implementation. After that, I want to place my product into this queue. Let me run the program to show you what would happen. And here you can see class cast exception. What to do now? We have two options here. The first one is to use only types that implement comparable interface. The second option is to say to our priority queue how to compare elements. Let me comment these lines of code to show you the next example. Here you can see that I created the same queue parameterized by product type, but I passed the product comparator to the constructor of priority queue. Now my priority queue knows how to compare products and sort them. Let me run the program. And we can't see error anymore. That is because our queue knows how to prioritize products. Where to use priority queue? Imagine that you want to implement help desk. During the day you receive tons of requests and complaints, but you have limited number of operators in your company that can process these requests. And you have special app for your operators, where each operator can click button, take new request, and move it in progress. And it is obvious that most critical requests should be processed first. In case customer can't make a payment in your online store, or customer already paid but some error happened and he or she can't get details of his order, that is more critical rather than some random question like when sorting by manufacturer will be implemented on your site. Do you agree with me? And what you have to do? Probably on the front end you would implement some drop-down where you would ask your customer to categorize requests. For example, here on the slide you can see example of support of Payoneer. In your system you have some object, something like support ticket type. You also have to implement logic that would assign support ticket type, and based on the type of the request you would assign priority, high, medium or low. And after that you would put your support ticket object into the queue. And you already know that we have to either implement comparable interface in our support ticket, or we have to create comparator and pass it to priority queue. Interesting? I hope it is. And moreover, implementing something like this already real-life task for Java software engineer. This will be your homework. But before I would share with you the details of your homework, let's recap what we have learned today. Today we learned queue and DAG interfaces. We learned in detail how methods that are described in these interfaces work. We learned what FIFO and LIFO data store methods are. We reviewed queue and DAG implementations and learned the most popular ones. After that, on real example, we learned how priority queue works. And now I suggest reviewing your homework. You have to implement help desk facades that would serve as a main interface for a support engineer to interact with the system. Help desk facade interface has only three methods: add new support ticket, get next support ticket, and get number of tickets. According to our requirements, get next support ticket method will be called when your support engineer would click on the button. This method should return top priority item. I almost explained you how to implement help desk in your online store. Here you can find the details about what request type might be and priority for specific request type. During the creation of the support ticket, we specify only type of the request, and its priority is defined automatically based on the mappings that are written down in the table. And there is one more requirement. In case support tickets have the same priority, the one that was created earlier should be processed first. I can give you a small hint here. You can implement counter. This even might be static field, and you may consider the value of this field when you would compare two support tickets, for example. Does it make sense? Hope the task is clear for you. This is really interesting task that will help you a lot in understanding of the queues and will give you some close to real life experience. Thank you all for your attention. Have a great day and see you in the next lesson. Hello dear students, today we have important topic. We are going to review another hierarchy of Java Collections framework, that is map hierarchy. Today we are going to learn map interface. We are also going to review such interfaces like sorted map and navigable map. I am going to hold overview of implementations of map interface and what features they have. Also we will talk about what dictionary is and how hash table class is different from hash map. After we learn theory, we will focus on map interface and its methods. During review of map interface, we also will learn what entry type is. As you can see, today we have a lot of things to learn in our plans. Let's start. And I'd like to start with you from the overview of map hierarchy first and key features of map. And after we learn this, we are going to dive deeper in the details to investigate each interface in particular. On the top of our hierarchy we have map interface. This type exists to map keys to values. All keys are unique. Values may be duplicated. And there are a lot of places in our programs where we can apply map implementations. If you remember, on one of the lessons I showed you example of mobile app for sport betting tips. For example, we can receive from server a lot of sport events. After that we can group them by date. And your keyword would be the specific date, and the value would be collection of sport events on this day. Or another example. Recently you have implemented home task help desk. In that task you also could use map implementations to map support request type with its priority. In this case, support request type would be the key, and it will be unique, and priority would be the value and can be duplicated. And I keep creating examples on the fly because there are really a lot of cases where you need some data structure where you would store key value pairs. Okay, so we already understood why we need map. Now let's understand what specifics different implementations of map interface have. Abstract map gives implementations for some of the methods of map interface. Hash map, implementation of map interface. It stores element using the mechanism of hash tables that guarantees constant amount of time for retrieving and placing elements. That's why everyone loves hash map. Linked hash map, besides storing elements, also memorize the sequence of adding entries in the map. So, the order of elements during the iteration is predictable because linked hash map maintains double linked list running through all of its entries. If we need thread-safe implementation of the map, we would opt for concurrent hash map. That implements concurrent map that in turn extends map interface. We have few more interfaces that extend map interface. They are sorted map and navigable map. Sorted map provides ordering of a map based on its keys. The map is ordered according to the natural order of its keys that is defined according to implementation of comparable interface. Or alternatively, sorting order may be defined by comparator. Navigable map extends sorted map and provides developers with possibility to return the closest matches for given search targets. The most popular implementations of this interface are tree map and concurrent skip list map for multithreading environment. We also have abstract class dictionary. How it is different from the map interface. Dictionary class was created in Java version 1 and supposed to be a parent class for all types that map keys to values. Since multiple inheritance in Java is not supported, the map interface was introduced in Java version 2. So, I would say that dictionary is an old version of map interface, and it is considered as an obsolete and use of map is preferred. But still, you might be asked about dictionary during the interview, and for your common Java literacy you have to be aware about it. Hashtable is a concrete class that extends dictionary type and implements map interface. It was considered as a thread-safe version of hash map unless concurrent hash map was introduced in Java version 5. The synchronization mechanism is not so efficient as it is implemented in concurrent hash map. In case you are not familiar with multithreading topic, I would explain the difference in implementation of multithreading support in these classes in simple words. Hashtable closes the door in your home. Concurrent hash map closes the separate doors in your home to allow everyone to walk around the home until only one room is closed. Can you feel the difference in implementation of concurrency support in these two classes? A bit later in the separate lessons we are going to learn multithreading together, and we will get back to thread-safe map implementations. That's how map hierarchies look like. Before we proceed with the details, I want to finish the topic of differences between hash map and hashtable. So, the first thing that is different we already discussed. All methods in hashtable are synchronized, and that's why hashtable is considered to be a thread-safe map. Hashtable also doesn't allow neither null keys nor null values. On the other hand, hash map allows us to store one null key and multiple null values. Hashtable is a legacy class, whereas hash map is newer. And now I suggest opening the source code of map interface to learn the documentation and methods of this interface. Here is map interface. Pay attention that this interface doesn't extend iterable interface like collection. While reviewing map interface, I'm going to use entry word. By saying entry, I would always mean key value pair. Is it clear? For example, size method returns amount of entries in the map. In other words, number of key value pairs. Is empty. This is self-describing method. It checks whether the current map is empty or no. Contains key. Verifies whether map contains specific key. Contains value. Similar method to check value in map. Get method. To get value from the map, we have to use key. So, we pass key to get method to retrieve our value. There is no add method in map. Instead we have put method. We can put key value pair in map. That's why put method takes two arguments. Pay attention to the return type here. Imagine that you put in map integer value 1 and some custom reference type user as a value to the map. In this case, put will return null. And now imagine that you put new value but with the same key. You call put method again with integer value 1 and new user object. In this case, put method will return value that was previously associated with the key. That means previous user. Does it make sense? If you want to remove some entry from the map, you have to call remove method and pass key as a method argument. Map interface declare methods for bulk operations. For example, put all method can add all entries from one map object to another. Clear method removes all mappings from the current map object. KeySet method returns container of set type that contains only keys from this map object. Why set? Because all keys are unique in map. That's why set type is returned. In case we want to retrieve all values from the map, we have to call values method that returns collection of elements. Why collection? Because values are not unique and collection is returned. Here's one more very useful method, entry set. This method returns set of entries of this map. Each key value pair is represented as a single object of type entry. You already understand why set is returned. Because each key value pair is unique. Entry is inner interface in map. Let's look at it. Entry type has two methods that are used more often than others. They are getKey and getValue. For example, we can iterate over a set of entries in for each loop. And in the for each loop body, we can use reference to the entry object to get either key or value. It depends on what exactly we need according to our logic. There are also other methods that in my opinion are not used very often. For example, setValue. It allows us to set value associated with the current key in the entry. In my opinion, if there would be such need, to update the value associated with a specific key, most likely you won't do this with entry type, but instead would just call put method with the same key on map object to update the value. But probably one day you would face with the case that while iterating over entries you need to implement logic that under some specific conditions you have to update value that is associated with a specific key. And for this case you already know what method can help you with that. Here you can see equals and hash code. You already know these methods. And also, entry has few interesting static methods. We are going to use them in our next lessons. Right now, let me explain you in theory what are they about. We have comparing by key method that sorts entries by keys in case they implement comparable interface, and with comparator parameter in case keys don't implement comparable interface. These methods return comparator that we can use to sort, and now attention, to sort our entry set, but not elements in map by its key. And we also have comparing by value method that returns comparator that can compare entry set by values. Imagine that you want to sort your map by values. To be honest, comparator that sorts by keys is not so cool. Why? Because we can create object of tree map and put all elements from any map there, and elements will be sorted automatically by keys. But sorting by values, that is really helpful comparator. Now, when we answered what entry type is, let's investigate what methods are left here in map interface. Equals and hashcode methods. And after that default methods are described. For example, here is interesting and useful method. Imagine that you need to get element from map, but you don't want to get null in case element is absent in map. Instead, you would like to get some default value. We can call get or default to retrieve element by key in case the mapping for such key is present, or to return default value in case there is no mapping for such key. Pay attention to the fact that in case key exists and value that is associated with this key is null value, then null will be returned. Default value will be returned only in case there is no such key in map. For each method takes functions that should be applied for each entry. When we will learn functional programming with Java, I'll show you how you can apply this method. Replace all takes functions that will be applied to each entry, and each entry in turn will be substituted with the result that will be returned by this function. Put if absent method should be used when you don't want to override the value that is already associated with a specific key, so new value will be put into the map only in case there is no entry with such key, or key is associated with null value. The remove method can help you to remove entry by specifying key-value pair. Here also replace method. They are different from put method because you can say that you want to replace element only with a specific key and with a specific value, or in case of overloaded method, only in case such key exists. Compute if absent method allows you to compute value in case key is absent. We can pass the key that doesn't exist in map and functions that can compute new value. In case such key exists, the value won't be updated. Compute if present method takes key and function that can compute the value based on the current key and previous value that is associated with it. In case key exists and previous value is not null, the result of the function will be associated with this key. Compute method attempts to compute a mapping for the specified key and its current mapped value if there is no current mapping. Merge method works in the following way. If the specified key is not already associated with a value or is associated with null, associates it with the given non-null value. Otherwise, replace the associated value with the results of the given remapping function, or removes if the result is null. Last four methods require knowledge of functional programming in Java. That's why they will be reviewed in detail separately in the lessons about functional programming. Right now, it is enough high-level understanding what these methods do. And now, We are done with all default methods in map interface, and it is time to review static methods in this interface. Here we see overloaded static method with the name of. These methods are here since Java version 9 and they can create immutable, that also means unmodifiable, map that contains limited number of mappings. And you can see that the only difference between all these methods is number of mappings that it takes as a method parameter. Here is a method that takes variable length argument of type entry and based on this creates unmodifiable map. Entry method returns unmodifiable entry type based on the key value pair that is passed to the method. Why this method is needed? This method is needed, for example, for the previous method that we have just discussed, because you want to eliminate the case when your entry is changed because somebody got access to it by reference. That's why you might want to create unmodifiable entry first, and this method will help you in that. And the last but not the least method for today is copy of. If we want to create the copy of the map that nobody will be able to modify, we have to call this method and pass the map that we want to copy as an argument to this method. That's all method from map interface. I believe that right now you know map interface even better than some senior software engineers. Let's recap what we have learned today. Today we learned map hierarchy. We talked about features that are introduced in the implementations of map interface. We also talked about sorted map and navigable map. We discussed what dictionary is. Now you know what the difference is between hash table and hash map. After that we learned methods of map interface. We also learned what entry type is. That's all what we have for today. Thanks a lot for your attention. See you in the next lesson. Hello dear students, in this lesson we are going to learn how hash tables work, and on example of hash map we'll learn how to use maps. This is important because a lot of the most popular map implementations are based on the hash tables. To understand how hash tables work, we'll learn how to override equals and hash code methods in our types. Today we'll have practice with hash map. You're going to learn what a capacity of hash map is and what load factor is. I'll share with you the best practices of selecting keys for map. During the lesson we are going to answer the question what immutable objects are. Also, I will show you how you can sort entries in your map by keys and by values. Let's start. Probably you already know from the previous lesson that it takes constant amount of time from hash map to perform its major operations like get, put, remove. And big O notation for major operation of hash map is O of 1. But what implementation brings us such performance? This is because hash map, the same as linked hash map, concurrent hash map and hash table, use hash tables to store and retrieve data. And for us it is important to understand how hash tables work so that we could use and tune our hash map when needed for better performance. Let's learn what hash table is. I'll try to explain a hash table in very simple words that are easy to understand. I can explain it in Wikipedia language, but I won't. In simple words, hash table consists of buckets, or also sometimes they called slots, where you may put any value. I want you also to learn things on example, so we would discuss also few things that are specific for hash map implementation. By default, hash map object has initial capacity of 16 buckets. That means that at the beginning, when we only created hash map object, we have 16 buckets. Load factor is equal to 0.75. What is a load factor? Load factor is a value that tells when our hash table has to be resized and increased. Inside the hash map type you would find int variable with the name threshold that is a result of multiplication of capacity and load factor. So 16 times 0.75 equals to 12. That means that when 12 buckets will store some value, our hash map will be resized. After some investigation of hash map source code, we would find that threshold is doubled when we need to increase our hash map. When new threshold is reached, hash table is rehashed so that the hash table has approximately twice the number of buckets. Can you understand what capacity and load factor is? Hash map has specific constructor that allows you to pass integer value to initialize capacity and float value to initialize load factor in case you want to tune hash map performance. but in real life, default values are used most often. Okay, let's move on. Now, let's imagine that I want to put new entry in my hash map. Here you can see that I have entries that consist of the key and value. Let it be some string object key1 here and some value. Okay, what happens next? After that, hash function is applied to compute index of a bucket of the key. Hashcode method is invoked on the key object. After we received hashcode, we may perform modules operation and the remainder would be the index of a bucket. After that, I place key to the bucket and associate the value with that key. And after that, each new element is placed in new bucket. Based on this, can you understand why adding elements in the hash map always took constant amount of time? Because to put element we need to define bucket for that element and just put it there, and this operation doesn't depend on number of elements. Okay, what happens in case two keys has the same hash code? This situation may happen because of the hash collision. I will explain you in detail why this might happen a bit later. For now, just take as a fact that theoretically two different objects may have the same hash code. According to the flow that I have described, the elements would be put in the same bucket. Is that true? Yes, it is. Inside each bucket, linked list is created. This is not doubled linked list, it is connected only in one direction, and it looks like this. Element in the bucket has reference to the next object, with one exception. In Java version 8, additional improvement was introduced in performance of hash tables. In case type of key object implements comparable interface, that means keys might be sorted, and in case there are multiple objects in one bucket, there is no linked list with its O of n, that is linear, algorithm complexity. Instead of the list, there is a binary tree that brings us O of logarithm n complexity of the get algorithm. Does it make sense? Let's move forward. To understand why retrieving of elements take constant amount of time, let me show you how element is retrieved from the hash map. To retrieve element from the map, we pass key object. Hash function is applied to the key. This allows to define the bucket. After bucket is defined, keys are checked for equality. Why? As you already know, there might be two different objects with the same hash. That's why algorithm should call equals method to compare two objects. And in case there are multiple objects in one bucket, algorithm will check equality until it finds the match. That's why it is said that hashcode and equals method are work in pair. Can you understand now on which step hashcode and equals method is used? Awesome! Now, imagine that we have type where we have overridden hashcode method and hashcode returns constant value. Imagine that hashcode method just looks like this. Return 1 all the times. What that would mean for the hash map? That means that bucket for all objects of this type would be the same. And instead of taking advantage of hash table and constant amount of time for retrieving elements, we would get linear time, because all elements will be stored in one bucket. That is exactly the reason why we need to override hashcode functions that would return the most unique integer. Now let's talk about requirements for hashcode and equals methods that should be met during the methods overriding. There are three major requirements that hashcode function should meet. They are: multiple invocation of hashcode method must consistently return the same integer. The second requirement: if two objects are equal, that means if equal method returns true, then their hashcode also should be equal. What another statement is follows from this rule? That fields that are used to compare objects and fields that are used to calculate hashcode of the object should be the same. Does it make sense? And the third requirement: in case two objects are not equal, it is possible that hashcodes will be the same. Let me comment on this statement. Probably you are wondering how this may happen. It is an easy math rule. Hypothetically, the set of objects is infinite. We can create as much objects as our heap size will allow us. And as we increase heap size, we can create even more objects than before, whereas hashcode value is not infinite. It exists only within the integer range. No more and no less. That's why, hypothetically, hashcode collision may happen. Hash collision, that is the state when two different objects that are not equal have the same hashcode. Hope the things are clearer now. Now let's talk about rules that equals method should meet. Equals method should meet 5 rules. They are: equals method should be reflexive. This means that for any non-null reference value x, x equals x should return true. That is obvious, but still, it is worth to mention for complete understanding. Equals method should be symmetric. This means that for any non-null reference values x and y, x equals y should be true if and only if y equals x returns true. Equals method should be transitive. For any non-null reference values x, y, and z, if x equals y returns true and y equals z returns true, then x equals z should return true. Equals method should be consistent. For any non-null reference values x and y, multiple invocations of x equals y should be consistent. And last but not the least requirement is that for any non-null reference value x, x equals null should return false. A bit later today during the practice we'll review how to override hash code and equals method. Let's start our practice exercises. We have enough theoretical knowledge right now to understand the next examples. Before the lesson I prepared a demo file with examples that will help you to understand how maps work. Let me run the program and walk you through console output. Here I declare a map variable. Similar to collection and list types, map type is also parameterized. Hope you don't skip lesson about list implementations where I explained on the high level how diamond operator works. We're also going to learn generics in the separate lesson, so don't worry much about that. Here in diamond operator I specify that keys in this map would have integer type and values in this map would have string type. I initialize this object with the reference to the hash map object. If we wanna put entries in the map, you can see example here. I just call put method and pass integer and string. If I wanna get element from map, I have to use key. For example, if I wanna retrieve string 1, I just pass 1 to the get method like this. And in console you can see that we printed the value that is associated with the key. Taking into account key set returns the implementation of set interface, and we already know that set extends collection, that in turn extends iterable. This means I can use for each loop to iterate over elements. And here I printed all keys to console. The next thing I want to show you is an example how you may iterate over all entries in map. I take entry set from my map here and specify a variable here of map entry type. Since entry interface is declared inside map interface, from the syntax standpoint, I have to put dot here. My entry will be parameterized by integer and string type, the same types that keys and values have in my map. You can see that I use entry variable to retrieve key and value. Here also demo of the get or default method. I want to draw your attention that in case our entry exists in the map, like entry with the key 4, default value won't be returned even in case the value is null. The default value will be returned only in case the entry doesn't exist in map, like with entry with the key 5. PutIfAbsent method will put value associated with the key in case if key is not already associated with the value or associated with the null. And here you can see that I called this method for the entry with key 4. And after that I checked whether the value is updated, and it was successfully updated. And now let me show you a few examples that are related to all maps that are implemented on the basis of hash tables. Imagine that we have some type called default product and default user. If you don't remember these types, they are from your previous homework about implementation of online store. Let me create a map where keys will be of type user and values will be of type product. I create default user object and default product object. Now let me put one entry to the map. Now imagine that in some other part of my program I retrieve user from the database or receiving user information from the front end, and I create the new Java object but with the same state for my John Smith user. And after that I want to get product object for this user from the map by my user key. I receive null. Knowing how hash tables work, can you understand why I received null and why my product value is lost in my map? Pause the video for a second and try to answer this question. Let me answer this. This is because hash function is applied for the user object, but what value is returned? Here in console you can see what hashcode method returned for my user object and user copy object. They're different. That means I have to override hashcode method in user class so that it would constantly return the same hashcode for equal users. To save time during the lesson, I created one more implementation of user interface that overrides hashcode and equals method. Let's look at it. So here you can see that I have hashcode and equals method overridden. How to override method? Personally, I use Eclipse for that in most of the cases. I press hotkeys Alt-Shift-S. In case you forgot hotkeys, just press mouse right click, source, and find here generate hashcode and equals. Eclipse asks whether I need to override this method one more time, taking into account I already have these methods. I will click yes to show you the interface of Eclipse here. Here you can choose fields that you want to use for equals and hashcode method. Please pay attention that you will never want to use static fields in equals and hashcode methods. Can you understand why? Because static fields are related to the class itself rather than to object of this class. And in case you would use static fields for calculating hashcode or equals, these methods wouldn't meet the requirements which we talked about in this lesson. Here's one checkbox that I usually check, is to use methods from object class. This makes our methods written in a bit different way that takes less lines of code than without using objects class. There is also another checkbox that you might want to select sometimes. I will show you the difference. So here you just click generate and methods are generated. I will click cancel because I already generated methods. Here is a hashcode method. Optionally, you can investigate how hash method is implemented. You can see that I call hash method on objects class and pass all fields that I want to be taken into account to compute hash of the object. Now multiple invocation of hashcode method on different objects will return us the same integer value. Here is our equals method. At the beginning we check equality by references. If references are the same, we return true. If object that we pass to the method is null, then we return false. Now I get class of the current object and get class of the object that we got from method argument. And potentially you can use here instance of operator. For example, in case it is not critical for you that objects are created on the base of different classes. Sometimes for you the fact that two different objects are compatible with type and have the same state is enough to tell that both of them are equal, but it depends. Personally, in most cases I use getClass here, but I have to warn you that you might want to use instance of operator here to check compatibility, and that is also fine. After this check, we can cast object to the current class type and check for equality field by field. In case all state from the other object is the same as state of this object, then we return true. Can you understand now why the set of fields that we use in equals and hashcode method should be the same? Great. Let's get back to our demo file. Now we create object of our type that overrides hashcode and equals method. We put it as a key in our map and map it against our product. After that I create the same copy of our user, analogously we did previous time. And now I want to get my product by the key. And here it is. I managed to retrieve product from map because my hash table was managed to find the right bucket and value in it. Now imagine that for some reasons the state of the user is changed in the database. Let's imagine that John Smith decided to change his email address and now he uses new email domain. Let's retrieve the product again. And in console we see null. Can you understand why? Because in our case we use all fields of user to compute hashcode, as you remember. And when email was changed, hashcode also was changed. But the object that is used for key in map still uses the old email. And definitely our hash map can't find the right bucket with our key to return us product. That's why it is recommended to use immutable objects for keys. What are immutable objects? The objects the state of which is never changed after its creation. The example of a mutable type is string. This object is designed in the way that there is no any method that can change state of the original object after its creation. Pay attention to replace method, for example. It should replace some characters with others. You would notice that this method returns new object of string, but not modifies the previous one. In case you use mutable keys in hash map, pay extra attention that the key is stable, but usually either string or integer objects are used as keys. I believe we learned a lot about hash tables. And the last thing that I'd like to share with you is to show you how to sort map by keys and values. Here is a separate file with the examples of map sorting. The same hash map object is created here with a similar dataset as we had in previous example. Now, if you remember from the lesson about map interface, we have comparing by key and comparing by value methods in our entry type to sort entries in map. You already know that list interface has sort method. Neither collection nor set interface has sort method. That's why we have to use list object. I create variable of list type parameterized by entry type that in turn is parameterized by integer and string. Probably you notice that I use just entry word in this file. That is because I have import statement here for map entry type. After that, I create array list object and pass to the constructor entry set of my map. Now I can sort elements in this list. And entry type has default method that returns comparator to sort entries by key. I want to shuffle elements before sorting to make sure that sorting works as expected. To shuffle elements, I use special method from collections class with utility methods. Don't worry, we'll review this class in the separate lesson. Right now, I will use only one method from that class for the demo purposes. I print shuffled elements to console to prove you that they are not sorted. After that, I sort elements and print sorted list to the console. Let me run the program. And here you can see that all elements in list are sorted now. Awesome! Just want to pay attention, this sorting only for keys that implements comparable interface. If your key doesn't implement comparable, there is overloaded version of comparing by key method that also takes comparator as an argument. And we already had separate lesson and homework regarding comparator. That's why I will not stop on this. In case you would face issues, let me know and write in comments, I will help you. To sort by keys, it is also super easy to create an object of tree map and add entries to that map. To put all entries to tree map, I use special constructor that takes any map as an argument. We are going to have separate lesson about sorted map and tree map, but you're already familiar with key features of this interface and class from the map hierarchy lesson. And taking into account we are talking about sorting of elements, it's worth to mention tree map here. And last but not the least for today is how to sort your map by values. We again shuffle entries before sorting. After that, we used comparator that can be created by entry type. And again, this comparing by value method has overloaded version that takes comparator as an argument. That is in case your values don't implement comparable. And here we print list of entries sorted by value. You remember that to convert array of entries to map, we have special method of entries. But to use it efficiently, we have to understand functional programming in Java. So, conversion looks something like this. This is one of the options. I showed you that just to make you understand that I remember everything and I want to separate lessons in the way you would understand everything. Don't worry, we will cover that topic separately in other lessons. Right now, I want to recap what we have learned today. In this lesson we learned how hash tables work. Now you know how to override equals and hashcode method and what requirements exist for these methods. Today we had a lot of practice with hash map. You saw main methods and how to work with hash map. Also, we learned what immutable objects are and understood why immutable objects are good keys for our maps. And at the end of the lesson we learned how to sort map by keys and by values. I believe this was extremely fruitful lesson. Thanks a lot for your attention. See you in the next lesson.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Hello dear students, in this lesson we are going to talk about one more implementation of map interface, linked hash map. We're going to understand how linked hash map is different from hash map, we'll review structure of linked hash map, and we'll review methods that it has. I'm going to explain you what a cache is and how we can implement our own cache with the help of linked hash map. Also, we'll learn how to implement logic that would keep fixed number of elements in our linked hash map object. Let's start. To understand how linked hash map work, let's look at this slide. First of all, what we have to understand is that linked hash map is also implemented on the base of hash table. Linked hash map has predictable iteration order. How is this achieved? It is achieved because of the support of doubled linked list inside. On the screen you can see the image that represents the structure of each bucket in hash table, and in addition to that, the properties that allows us to link elements in both directions. That's why when we insert each new entry in linked hash map, each entry knows about the next and previous entry. That allows us to iterate over this data structure with predictable order. There are also a few more differences in linked hash map that I'd like to show you in the source code. Here is the source code of linked hash map class. Notice that it extends hash map class and implements map interface. I'd like to draw your attention to the special constructor that also takes boolean flag as one of the arguments. The documentation said that we have to pass true for access order and false for insertion order. When I read this first time, for me it is not obvious what is the difference between access order and insertion order. I would say that these are two different ordering mechanisms. By default, it is insertion order, but we can set access order by passing true into this constructor. Access order strategy will ensure that order of iteration of elements is the order in which the elements were last accessed, from the least recently accessed to most recently accessed. You might be wondering when this can be used. I know that the things are better learned when you know that you can apply your knowledge on practice. Access order may become handy when you want to implement cache. Probably you heard this word the first time. Let me explain you what a cache is. Cache is a hardware or software component that stores data so that future requests for that data can be served faster. The data stored in a cache might be the result of an earlier computation or a copy of data stored elsewhere. For example, you can always keep in cache information about products that are reviewed most of the times. To save time on retrieving all information for product details page, we can just store these products in cache and retrieve them only when it is needed. To be cost effective and to enable efficient use of data, caches must be relatively small. That's why there are several content eviction policies that keep size of the cache fixed. Sometimes it is also called cache replacement algorithms. When the cache is full, algorithm should choose which items to discard to make room for the new ones. There are really a lot of different eviction policies. Some of them are first in, first out, last in, first out. You already know what FIFO and LIFO means. Last recently used. According to this strategy, we discard elements that were not used for a long time. The logic that stands behind that is in case element is not used, there is no sense to keep it in cache and it is better to substitute it with a new element. And in case you either put new element or read existing element, that counts as usage and element is moved on the new place in this data structure to not be removed. By the way, this is one of the most popular ones. You're going to have a homework to implement your own cache with the help of linked hash map. Most recently used eviction strategy, it works in the opposite way from least recently used cache. Among the other eviction strategies, it is also possible to mention random replacement, least frequently used, least frequently recently used, etc. So I believe now when you know what a cache is, you can imagine how we can use linked hash list to implement cache. The access order in linked hash map allows us to implement LRU cache in easy way. But what else we need to implement cache with the help of linked hash map? We need to set the size of our cache. And linked hash map can help us to support fixed size of our cache. How? Let's get back to the source code. In the source code of linked hash map we can find remove eldest entry method. This method is invoked by put and put all methods after inserting a new entry into the map. And in case this method returns true, that means map should remove its eldest entry. You can see that it has protected access modifier. That means it is not available by default outside of this package and outside of this class and its child classes. The idea is, in case you have to implement cache, we have to override this method and implement the rule that would tell us when we have to remove the eldest element. Does it make sense? I prepared an example to show you this. Here is the class that extends linked hash map. I also declared a field with the name capacity that contains the int value of max elements in the current map. How elements will be removed automatically? I will let linked hash map to handle all removals. What I have to do is to override remove eldest entry and return true when element should be removed from map. So, when the size of map will become more than capacity, then we have to remove eldest entry. Our capacity by default is 3 elements. Now let me create the object of the current class and add 4 entries here. By default, I have insertion order, and that means that when I add 4th element, the first one should be removed. Here I print elements to console. Let me run the program to show you console output. And here we can see that the first entry is removed. Now you have enough information that will help you to implement your homework. From the public interface that linked hash map provides, there is no methods that are present in this class and absent in hash map. Since this class extends hash map, that means all methods that we reviewed in hash map lesson and that we reviewed during the review of map interface are also available for objects of linked hash map type. That's why we won't review those methods again. So that's all what I wanted to share with you regarding linked hash map. Now let's recap what we have learned today. In this lesson we reviewed linked hash map class. We learned how linked hash map works and what are key features of this type. Now we know what the difference between insertion order and access order is and how to change this mode in linked hash map. After that we learned what a cache is. Now you know the theory of different eviction policies and you know that linked hash map can be used to create LRU cache. Also we learned how to override the methods that would keep constant number of elements in linked hash map. Now I suggest reviewing your homework. You have to implement LRU cache on the basis of linked hash map. Here I provided you with the interface that you have to implement. According to this task you have to implement 3 methods. Get, that returns value by key or -1 in case the key is not found. Put method that should put key value pair of ints or update the value for key if such already exists. And set capacity method that sets maximum number of elements that can be stored in cache. Try to use knowledge that you gained in this lesson to implement this task. I'll also share my solution for this task in attachments to this lesson. After you're done, you can compare 2 solutions if you wish. That's all for today. Thanks a lot for your attention. See you in the next lesson. Hello dear students, in this lesson we are going to learn another implementation of map interface, that is tree map. We are going to learn in detail such interfaces as sorted map and navigable map. This would help us a lot in understanding of tree map behavior. And at the end of the lesson we'll have practice with tree map and I'll show you how you can use this map with keys that implements comparable interface and with keys that don't implement comparable interface. We are going to learn what a binary tree is, what red-black binary tree is, and why big O notation of tree map for its major operations is O of log n. Let's start. And to start with, I'd like to jump to the source code of the sorted map interface to investigate what methods are introduced there. Here is the source code of sorted map interface. It extends map interface as you can see here. The first method here in our list is comparator. This method should return comparator that is used in map to sort keys or null if such comparator is absent, and map uses natural ordering of keys. To be honest, this method wasn't used by me and I think it is not very popular, because if you use some comparator to sort keys in the map, that means you have the reference to this comparator already somewhere in your program and there is no need to get it from the map. And in case keys are sorted according to natural ordering, there is no sense to call this method because null will be returned. But now you at least know about this method and can use it someday in the future when this will be needed. The next method here is submap. I would even say that it is similar to sublist from list interface, The principle applied is the same here. We have to specify key from inclusively and key to exclusively, and we will get new sorted map in response. It is also worth to mention that majority of methods in sorted map potentially may throw class cast exception, in case keys can't be cast to comparable interface or in case there is no comparator available in this map. Besides this exception, there are also a few more potential exceptions that are pretty straightforward. Do not pass null as method argument in case you don't want to catch null pointer exception, and do not pass from key that is greater than to key to not get illegal argument exception. The next method is headMap. It returns the view of the map that is less than key given. For example, if you need to retrieve all entries that are less than some specific key, you can use this method. TailMap works in opposite way. It returns the view of the map that contains entries with keys that are greater than or equal to the key that would be passed as method argument here. Also, sorted map provides the method that allows us to access first and last key that in turn will allow us to retrieve value from map by this key. That's why we have first key method that returns the lowest key and last key method that returns the highest key. Key set. The method similar to the one we have in our map interface but with clarifications to its implementation. The set that will be returned has iterator that returns the keys in ascending order. Values method returns collection that has iterator that returns values in ascending order of the corresponding keys. And the last method here that is also familiar to you, that is entry set. It returns entries in ascending key order. That's all methods that are introduced in sorted map interface. Let's move further and look at the popular interface that extends the sorted map interface. I'm talking about navigable map. Here is the source code of navigable map interface. Let's look through the methods that are declared here and I will give my comments. The main feature of this map is that it returns the closest matches for given search targets. Main methods that are introduced in this interface are created to reach this goal. For example, here is the first method in our list, lower entry. It returns an entry that is key value mapping associated with the greatest key that is strictly less than the given key. I'm going to show you this method during the demo in a few minutes to make you understand how this method works on example. Lower key method returns not entry, but only key. It returns the greatest key that is strictly less than the given key. The next method is floor entry. It is different from low entry because it returns key value mapping associated with the greatest key that is not strictly less of the key, but is less than or equal to the given key that will be passed as method argument. Floor key returns not entry but only key according to the logic that we have just discussed. Ceiling entry returns entry associated with the least key greater than or equal to the given key. I always do analogy for myself with the real ceiling in my house to remember the logic for this method. So, this method should return the element that is right on my ceiling or above it, but not the element from the next floor. That's why it is said about least entry greater than or equal to the given key. Does it make more sense now? Hope this understanding will help you the same as it helps me. Ceiling key returns key according to the ceiling logic that we have just talked about. The next method, higher entry, return entry with the least key that is strictly greater than the given key. In this particular case, I always want to get element from the next floor that is closer than other elements to my ceiling. This is example in case we want to continue real-life analogy with the house that we started during the learning of previous method. Higher key. I believe you already understood the way how these methods are structured here. Also, navigable map will provide you fast access to the first entry in the map, that is the entry with the least key. To get it, just call first entry method. And also, access will be provided to the last element in the tree. To get it, just call last entry. Here you can find methods similar to those that you saw in queue and deck interfaces. We can get and remove first entry from the map. For that, poll first entry method exists. And we can get and remove last entry from the map by calling poll last entry. Taking into account the navigable map is sorted map, we also can get navigable map in reversed order. We have to call descending map in this case. We also can get navigable key set and descending key set. By the method name, I believe it is clear that order of keys in descending key set is reversed. Here is submap method that we also saw in sorted map, but it works with additional method parameters. In this case, developer can specify whether we want from key inclusively or no, the same as with to key. That's the level of flexibility that is added in addition to submap from sorted map interface. We also have head map and tail map methods declared in this interface with the only one difference, that we can specify boolean flag to include or exclude the key from the result. And the last three methods here are equivalent to the ones that are declared in sorted map interface. Now it is time to practice a bit, and for the sake of the demo I prepared the file with examples. I will also share it with you so that you could practice and run the code on your computer. Let me run the program and walk you through the console output here. I declare the variable of navigable map type and initialize it with treeMap object. TreeMap extends abstract map and implements navigable map. It is considered as the most popular implementation of navigable and sorted map interfaces. For the sake of the demo, I just put integers and strings into this map like this. And here you can see different examples of me using first entry, lower entry, floor entry, higher entry, and ceiling entry methods. I used 3 as a key for all methods invocations so that you could see the difference. Here you can see that even despite the order in which we put entries, when we retrieve first entry, we got 1. Because integer object implements comparable interface, and integer objects know how to compare themselves with the other integers. Does it make sense? Now, when I call lower entry, I receive 2, because the condition for this method is that entry with the greatest key that is strictly less will be returned. But when I call floor entry for key 3, I receive entry with the key 3 because condition is different, and it allows that key would be equal to the one given as method argument. Similar story with higher entry and ceiling entry, but in another direction. Here I printed map and you can see that it is ordered. I can easily get map in descending order by calling descending map method. And here you can see in console that all entries are sorted in reverse order. Now, the thing that you should remember is that treeMap will throw class cast exception in case you would put objects that don't implement comparable interface. But what to do in such cases? We have to pass comparator to the treeMap constructor that is going to be used to compare keys inside. Here I created one more map where our keys will be of type product that we used for our online store creation, and our values would be of type user. But the type of the value doesn't make big difference since sorting is performed by keys. And here you can see that I created object of comparator that we implemented during one of our homeworks and pass this object in constructor here. Now I add few entries here, and when I print it to console each key from new line, you can see that all of them are sorted in order that is defined by our comparator. That's why treeMap is often used to sort map by its keys. That's it regarding examples of how you can use treeMap. The next thing that I'd like to talk about is performance of treeMap and how sorting is implemented in this container. The first thing that is worth to mention is that treeMap is not based on hash table. It is based on red-black self-balanced binary tree. That's why complexity of algorithms for main operations like get, put, remove is a big O of logarithm n. To not dive into the details and explain what a logarithm is, I will try to explain it in easy words. The performance is not linear, that means it doesn't depend on number of elements in the map in 1-to-1 proportion, but performance is scaling as we have more elements. To visualize this in your head, take a look at this slide. You can see the visualization of mapping between number of elements and time that it takes for specific operations mapped to the big O notation. You also can find big O of logarithm n on the picture. Hope this makes things clearer. How is this achieved? Because of the red-black self-balanced binary tree. Let's learn what is it. Let me start from explaining what a binary tree is. In simple words, this is a searching algorithm that consists of the nodes or leaves that stores links to nodes that are greater on the right and nodes that are less on the left. This tree has the root, And that's why we can say that all elements that are greater than root are stored on the right, and all elements that are less than the root are stored on the left. That's why when I need to find the specific element, I don't iterate over all elements. I go only the shortest path I have to go to find the elements that I need. What potential problem you can see in binary tree? The problem is to define the root of the tree. In case we will define the root and all following elements will be greater than the root and will be placed on the right, then I will get linked list and performance of main operation will be worse than in binary tree and will be linear. What to do in this case? It might be a good idea to recalculate the root of the tree on regular basis to have the same or almost the same number of elements on the right and on the left side of the root. That's the moment when red-black tree comes into the game. Each node stores an extra bit representing color, used to ensure that the tree remains approximately balanced during insertion or deletions. That also ensures big O of logarithm n complexity for main operations with red-black tree. Tracking the color of each node requires only 1 bit of information per node because there are only 2 colors. Does it make sense? Now you know how sorting is performed in tree map and how it works inside. That's all what I wanted to share with you. Let's recap what we have learned today. Today we learned sorted map interface and navigable map interface. Now you know methods that are declared in these interfaces. Also we had a practice with tree map and now you know how you can use it. We learned what a binary tree is and what a red-black binary tree is. Now you know why performance of major operations of tree map has logarithmic big O notation. That's it for today. Thanks a lot for your attention and see you in the next lesson. Hello dear students, today we are going to learn implementations of set interface and talk about utility methods from collections class. We'll learn how set works inside. We'll review hash set source code. After this lesson you will understand how set are different from list. We'll answer what mechanisms is used to keep only unique elements inside the set. I'm going to show you thread-safe implementation of set interface and we'll have practice today. And at the end of the lesson we'll review with you class with utility methods, that is collections class. Let's start. As you remember, set interface is located in collection hierarchy and doesn't introduce any new methods. Do not forget that set is not a list and set by default doesn't guarantee any order of elements and index access to the elements. The main feature of set interface and all of its implementations is that it contains only unique elements. There are various business cases when you need to use set. For example, you're retrieving data from different data sources and you know that data might be duplicated, but you don't need any duplication. In this case, you just add elements to the set that takes control over all duplicates. Or, in case you interact with user and want to avoid any duplication in information that was provided by user, you use set. There are really a lot of cases where you can understand that you need set. And now imagine that if you would be asked to implement something that keeps only unique elements in container, how would you do that? Would you use any other containers that you already know? Something that already stores only unique elements? Try to think for a second before I would give my answer. All map implementations store set of keys and each key is unique. There is no sense to have duplicated keys. That's why, in case we would need to implement set interface, most likely we would use any map implementation and delegate method invocations to the map. But, from the client-side perspective, it would look like we interact only with keys and we have regular collection, but not the map. Let's review the most popular implementations of set interface. I would say that one of the most popular set implementations is a hash set. Based on my experience, in most of the cases when I need set implementation, I use hash set. It extends abstract set that gives implementation to some basic operations, namely to equals, hashcode, and remove all methods, and implements set interface. Hash set is based on the hash map. Hash set aggregates map inside, And we'll see this today when we'll investigate the source code. Another popular implementation of set interface is linked hash set. This one uses linked hash map inside. It extends hash set. Main feature of linked hash set is that it provides predictable iteration order. The next set implementation is called tree set. Can you guess what it is based on? You are right. Tree set uses tree map inside to keep all elements sorted according to natural ordering or with the help of comparator that was provided during the construction of the object. It also extends abstract set and implements navigable set interface that in turn extends sorted set interface. And I really believe there will be no need to investigate these interfaces from scratch, taking into account we reviewed in detail sorted map and navigable map interfaces. When we'll look at the source code, you'll understand that implementation of set interface is pretty straightforward for you, in case you learned maps well. That's why I always learn with my students map interfaces first. If you need thread-safe implementation of set, you have to choose among different options. Some of them are copy and write array set, the set that is based on copy and write array list, but that keep only unique elements in container. Concurrent skip list set, that is based on concurrent skip list map, where elements are sorted according to natural ordering or according to the comparator. In other words, this is thread-safe implementation of navigable set. And there is also one more option, is to use utility methods from collections class that will turn any map to set. There is also one more implementation of set interface that is usually mentioned in books, that is enum set. This type exists specifically to store only enum elements. To be honest, I didn't use it very often, but it's worth to mention it. Okay, it looks like now you are familiar with the set hierarchy and now you are ready for the demo. And we'll start our demo today from overview of hash set source code. Here you can see the property of type hash map parameterized by the any type for keys and object for values. Also, you can see here a constant object. That is dummy value that will be used as a value that will be associated with all keys in this map. Taking into account in hash set we are not bothering about the values in internal map, there is a way to save some memory by putting always the same object as a value into the internal map. Does it make sense? You can find different variations of constructors here, but also, considering the fact that hash set is based on the hash map, that in turn is based on the hash table, we can specify initial capacity and load factor in case we want to tune performance a bit. And after that you can see that implementation of all methods just delegate the calls to the map and adapt interface when it is needed. Here is a size method that just calls map size inside. Here is empty method that just calls map is empty inside, and so on. Let's look at add method. Here you can see that we call put method from map. We put the element that was passed as an argument to this set into its map and associate it with the constant dummy object that we saw at the beginning of our review here. According to collection interface, add method should return true in case element was inserted and false in case element wasn't added to collection for some reasons. I believe you remember that put method in map returns the last value associated with this key, and in case this is a new key, it returns null. So, in case this statement is true, that means element was added to set. Does it make sense? Hope this makes things clearer. Let's quickly review sorted set and navigable set interfaces to make you sure that these interfaces are pretty similar to sorted map and navigable map. Here is the source code of sorted set interface. You can see pretty familiar to you interface that has methods for retrieving first and last element from container and create different variations of a subset. Now let's open navigable set interface. If you remember navigable map interface, you already can see that methods name are familiar to you. The only difference is there are no methods that returns entry type, but the rest is really similar. Now let's practice a bit to see how set actually works. I created this demo file to show you how you can interact with any set implementation. Here you can see that I declared variable of type set parameterized by integer. That means compilator will watch for me that I would add only integers in this set. Okay, Let me add few elements to the set here and print the output of each add operation. After that, I will print all set to console. Let me run this program. And you can see that when I added 1 the first time, it was successfully inserted. But when I tried to insert 1 the second time, it wasn't inserted and we got false. 2 and 3 were added successfully, and here you can see my set of numbers. Only 3 unique numbers are here without any duplication. Just one comment here. I believe you understand that uniqueness of elements is determined based on the hash code and equals methods, because these two methods help us to place element in hash table. Let me prove you this. I create new set parameterized by user type. In case you missed homework about online store, that is our type from the online store application. I create 2 objects of default user type that are the same. But default user class doesn't override hash code and equals methods. That's why, even in case logically these 2 objects are equal, set will store both of these elements. And here I printed all set elements to console, and you can see that both users are in the container, even despite they seem to be logically the same. Now, let me show you another example. I create 2 objects that overrides equals and hashcode method. If you remember, during one of the lessons we created user for hash tables, and this is exactly the object from our lesson about hash tables, if you remember it. Here you can see equals and hashcode are overridden. In case I would put these 2 objects in the set, only one will be added. Here I changed first name to William and set a different ID to distinguish users without hashcode and equals methods and with these methods overridden. Here, when I printed all users to console one by one, you can see that only one William was added here. Also, the thing that you have already noticed is that you can use iterator and for each loop to iterate over all elements in set. Take into account it also implements iterable interface and has its iterator. Now you know how to use sets in your work. And the last thing that I wanted to share with you today is collections class. Why do we need it? Sometimes we need utility methods like sort our collection, for example. Let me open the source code of this class and explore it together with you. It has really a lot of the methods. I will not provide my comments for all the methods listed here, but I will tell few words about only the most popular ones in my opinion. And I encourage you to review the source code of this class after the lesson and practice a bit with this class by calling different methods. Here we can see sort method. So, sometimes instead of calling sort method on the list, we can call sort method of collections class. You can reverse order of elements in your list if you wish. You can call reverse method and pass reference to any list object there if you wish. Here is the shuffle method that you saw we used for the demo purposes in one of the lessons in past. Also you can see swap method to swap elements by specifying position indices or fill method to fill container with the specific elements. Here is very useful copy method that allows you to copy list. Methods to find the least and the greatest elements in collection are also here. And here one of the coolest methods. You can take either list or set or navigable map or anything other to get unmodifiable object. In other words, there are methods that can wrap your objects with unmodifiable wrapper. When you need this, imagine that you implement getter method for cart object in online store, and you don't want to return products of cart and to let anyone else in other parts of the program to add products directly to the list. Does it make sense? What you want instead is that in case somebody wants to add product to the cart, they have to use addProduct method that contains additional business logic. It can be tax recalculation or discount of cart recalculation. And now we can say that we return unmodifiable list. Because if clients of our cart want to investigate what products in it, they can look at them. There is no harm in this. But in case they would like to modify the cart, they will catch an unsupported operation exception. Besides creation of wrappers for unmodifiable collections, we also can create wrappers to turn our regular containers to thread-safe containers. You can find a bunch of methods here that can return you synchronized list or map or set or anything else if you wish. Let me open another demo file to show you a few more examples. Collections class also has methods that can turn any map implementation to set. For example, I can create thread-safe set on the basis of concurrent hash map, just like this. Taking into account all methods are static in collections class, I write collections class name. After that I call method new set from map and pass the concurrent hash map object where keys are parameterized with the same type as my set. According to interface, the values should be parameterized by boolean type. And I assign this object to my set variable. When you might want to use this, for example, you're extremely satisfied with the performance of concurrent hash map and you don't want to use synchronized wrappers suggested by collections class. That's why you might want to use this method to create set implementation exactly on the basis of specific map implementation. Does it make sense? And the last but not the least super useful feature of collections class is empty constants. To make you understand what the benefit we can get, I prepared example here for you. Imagine that you have some method in your program that is supposed to return to you list of products that are associated with a specific cart ID. Let's call this method getProductsByCartID. Awesome. Now we are trying to retrieve products from database by cart ID. And imagine we got null in response because there are no products associated with this cart. Remember the rule, by returning null from any method you increase the risk of facing with null pointer exception in case somebody would interact with the result of this method in other part of the program. What is recommended? It is recommended to return empty list instead to avoid null pointer exception. Okay, let's look at this option. Now imagine that you have huge online store and this method is invoked very often. This will lead you to creation of thousands of objects of array list. Do you need to load your memory even with empty lists? I don't think so. But what is the best option? In my opinion, the best option in this case is to use predefined constants from collections class. Empty list method will return you parameterized collection based on the empty list constant. If you need, you can also use empty set or empty map for example. Hope this information will help you a lot in the future. Okay, now I believe we can recap the things that we have learned today. Today we learned set hierarchy. You learned the main interfaces and the most popular implementations of set interface. After that, we reviewed the source code of hash map and saw how set implementations use map implementations inside. We also had a practice with hash set, and you saw how hash set keeps only unique elements. And at the end of the lesson, we learned a lot of utility methods from collections class. You also learned best practices of using unmodifiable and synchronized wrappers. You also know when and why you have to use empty containers. Thanks a lot for your attention, have a great day and see you in the next lesson. Hello team, today we are going to answer questions what are generics in Java and how they work. We'll start from understanding of why do we need generics. After that, we'll understand how you can parameterize your methods and classes. You're going to understand what bounded generics in Java are. We'll discuss generics with multiple bounds. Also, in this lesson, we are going to learn what wildcards are and how to use them. Today, we are going to have a lot of practice that will help you to understand generics. And at the end of the lesson, I will explain you what a row type is and what type erasure is. Let's start. And to make you understand what generics are, I suggested starting from examples to make you understand what problem generics intended to solve. Imagine the next situation. You have an array of strings, and you want to have methods that process this data. For the sake of example, let's imagine that you need to have methods that would print all elements of array to console in some custom way. Here I created method printArray that takes array of strings as method argument. Inside I create for each loop, and before printing any new element, I also print word element, and only after that some element is printed. Now you realized that you have not only array of strings in your program, you also want to apply the same behavior for array of integers. But the existing method will not work with the array of integers, since it is specified that it works only with array of strings. Let me uncomment this line, and you can see compilation error here. What to do in this case? Create another method that will work with array of integers? Are you sure? What would you do in case you would need the same method for array of doubles, or array of your custom type user, for example? That is definitely not the best option. But what I would recommend to do in this case? It would be perfect to create the method that would work with arrays of different types. What do you think? But how to do this in Java? That is exactly what generics mechanism is created for. In other words, we can create parameterized methods and classes that would work with different types. And here you already can see the first advantage of using generics. You can avoid of code duplication and increase code reusage in your program. Let me uncomment this parameterized method and explain you the syntax. This method is similar to the one we already have, but before the type of returned value we have just void here, I write e in diamond operator. These characters from both sides are called together as diamond operator. We specify our parameterized type in the diamond operator. This is also called generic. I will explain you in simple words what this e is about. This is a placeholder for some specific type. Theoretically, I can write any letter here. The main thing is that letter that I specified here will be the same as in the method parameters and in method body. And after I wrote e here, I can treat this e as a specific type and use it with method parameters, for example, or anywhere inside the method body. Here you can see that I have array of type e, and while iterating over each element in this array, I also use e type for my variable here. Now I can call this method for both string and integer array, the same as for all other types. Let me comment print array method that works only with strings and leave my generic method. Awesome! And you can see that I don't have any compilation error anymore here. Let's make a definition of generic method now. Generic method is a method that introduces its own type parameters. I believe now you understand what generics are and why do we need them. Also, you know how to parameterize your methods now. But what is the potential issue in this case? In this case, for the type inside the method body, I can use only methods that are available for object type, but not any other methods that are specific to string or integer or any other type. Why? Because compiler doesn't know what type would be here during the runtime. I can't call here any string methods because compiler can't guarantee that only objects of type string will be here. As we can see on this example, objects of any type might be here. And what to do in case I need some behavior that is related to some specific hierarchy of objects? What if I know that this method wouldn't work with any objects at all, but this method has to work with any type that implements comparable interface? In this case, I can count on the fact that objects inside my method body will have compare_to method, and I will be able to use this API in the method body. Does it make sense? To help you understand this, let me open another example. Here I open another file where I prepared other examples for you. Let's imagine that I have to create methods that would be able to find the greatest value out of 3 variables. And I want to implement generic method, but not the bunch of separate methods that works with only strings or only integers or only double values. How to do that? Generic with boundaries will help us with this task. They are also called bounded type parameters. Here you can see method declaration. The method's name is max value. The next thing that you can notice here is that we use different letter here. Now instead of E we have T. And here is parameterization of my method. Here in diamond operator I say that this method should work with some type that extends comparable, and comparable in turn is parameterized with this type. In other words, some type T should either extend comparable interface or implement comparable interface. This is called upper bounded parameterization, because we set boundary from the top. Does it make sense? Also, one more comment here. It is possible to make multiple bounds like it is specified here in commented line. I will leave it here commented so that you could learn this when you will download the source code that I am showing right now. So, you can say that T should extend both comparable interface and comparator interface. That's just for the sake of example. I believe you understand that instead of comparator you can specify any other type here. And only in case our custom type T will implement both of these interfaces, only in this case we could work with this method and method arguments of type T. You even can see that I have compilation error because neither string nor integer nor double implements both of these interfaces simultaneously. Let me erase this to proceed with our demo. Pay attention that you can also use type that is specified for parameterization as returned type. So, you can get the type that was used as parameters here. The main thing in all of this is that this type should be the same everywhere across the method. In case the first argument is string, it is not possible that other arguments would be of different type or return type would be different. And now compiler is aware that this type will be compatible with comparable interface. That means that all variables that are passed as arguments to this method have compared to method. That's why all logic that is written in this method is rely on the fact that we can use this method. And there are no any compilation errors. That's great! And here you can see in main method that I can invoke max value method with different types of arguments, no matter either this integer, double or string type. Let me run this program. From the console output we can conclude that our method works as expected. Now you know how to parameterize methods with bounds. Hope this makes things clearer. Let's go to the next example. In this example I'm going to show you how you can parameterize your class. Here you can see diamond operator right next to my class name. That means I parameterized my class. For example, I can declare a property of type T, and method parameters, like in this set method, also can be of my type T. I can initialize my field with the value that will be passed as method argument here. The get method will return me a value of type that we use to parameterize my class. And here is example. I declare the variable of type generic demo3 with the name integer box, and used diamond operator to parameterize this type by integer. After that, I created the object and used diamond operator. After Java version 7, there is no need to duplicate parameterization type in diamond operator here. But you can, if you wish. For example, here I left integer type, and in my second variable with the name string box that I parameterized by string, I left blank my second diamond operator. In most cases, type is specified only when you declare a variable. And here you can see that my integer box can work only with integers, and there is a compilation error in case I would try to set any string object. The similar story with my string box. That is because these two variables are parameterized with different types. And in first case, set method accepts only integers, and in the second case, set method accepts only strings. When I use get method, I receive integer and string type accordingly. And here you can see that I print values to console and used special format specifiers for decimal numbers and string accordingly. Let me run this program. You can see that everything works as expected without any errors. Let's create a definition of generic type now when you saw the example. A generic type is a generic class or interface that is parameterized over types. And now let's continue our lesson. Even if you wouldn't use parameterization and generics for your own custom classes, you would use generics a lot with classes from Java Collections framework. It is super useful. Because it wasn't possible to create collections for all possible types. That's why all types from Java Collections framework are parameterized and use generics. Let me open source code of ArrayList. You can see that it is parameterized with eType. And if I open add method, you can see that it adds elements of eType. And get method in turn return elements of eType. Does it make sense? Some types even parameterized with two types. For example, all map implementations specify separate type for key and value. Let me open HashMap source code. Here you can see that I can specify type for key and the separate type for value, just two placeholders. And in put method, you can see that I put key of type k and value of type v, and type of returned value is the same as type of the value v. Because according to this interface we receive the last value that is associated with a given key. But the details of the interfaces of Java Collections framework are covered in the separate lessons. Now you know how to parameterize your class and you know how types from Java Collections framework are parameterized. We have one more important and practical thing to talk about. I want to talk with you about the wildcards with upper and lower bounds. Let me open another demo file that I prepared before this lesson. To make you understand this example, let me show you all classes that will take part in our demo. I declared all classes in one file to keep everything grouped for the demo and to not switch tabs. Imagine that we have some parent class, and child class extends parent, and grandchild class extends child. Is it clear? Cool, let's move on. Now, imagine that I have list parameterized by type child, and I have methods that can work with any list objects that are parameterized by type parent. It is called process parent elements. How do you think? May I call process parent elements method and pass collection of child elements there? Logically, it seems to be okay, since each child class should have all methods that parent class has, and compiler should not be worried about this. But if I ask you this question, you already suspected something, don't you? You are right if you are suspicious. This wouldn't work. You can see compilation error here. Why? Because list of child elements is not a list of parent elements. That's it. But what to do in this case? Usually in this case engineers use wildcards. Let me show you the next method. We have process elements method that takes list of elements that is parameterized by any type that extends parent. This question mark is called wildcard and can be treated as any type. This is called upper bounded wildcard. In this case, I can pass list that contains elements of type child to this method. And here you can see that there are no errors. Does it make sense? Now, I want you to put all your attention to the next example. When you use wildcard, that means you can get elements of type parent from this collection. I believe that is clear that you wouldn't be able to extract element of type child from this list because there is no guarantee what type would be here instead of the question mark during the runtime. It can be child, but it also can be parent type, and that's why casting parent object to child type would cause exception. And most likely parent doesn't have all methods and behavior that is described in the child type. Is it clear? Okay, we understood that we can get elements of type parent in case we use upper bounded wildcard. But can we add elements to this container? Unfortunately, we can't. And here on examples you can see that I can't add neither parent nor child nor grandchild objects. I can add only null value. You might be wondering, why? Why I can't add object of parent type to collection of elements parameterized by parent type? But let's look at this from another side. This is a very smart mechanism created in Java to save engineers from potential errors. The main issue is that because we don't know what type would be here during the runtime. That's why interactions with such collections are limited. Imagine that during the runtime I will pass list of elements of type child, and I will add element of type parent, and after I modified this collection in this method, I will get the element and I would think that all elements in this container are of child type. And I will call some child specific method. What will happen? I will get error during the runtime. Because indeed, I will get here object of parent type. And this object wouldn't have child specific method. That's why compiler wants to eliminate cases like this and just doesn't allow me to add any elements in this method. Does it make sense? I believe now you understood how upper bounded wildcards work. Now, let's take a look at another case. What to do in case I have to create methods that will be able to add new elements to the collection. In this case, we have to use lower bounded wildcards. Here you can see that I created two more lists. One of them is parameterized by parent type and another one is parameterized by child type. And you can see that I call process elements2 method and pass the first and the second list object there. But I can't pass list of elements that are parameterized by grandchild type. Let's investigate process elements2 method. This method has lower bounded wildcard. You can see super keyword here. What does that mean? That means that this method can take as an argument any object of type list parameterized by any type that is parent, or in other words super type with respect to child type. That's why I can't pass parent type or super type of child. This could be any super type including parent and even object. Is it clear? If yes, then let's proceed. In this case, I can get only elements of type object, and I believe you already understood why. Because there is no guarantee what super type of child type will be here during the runtime. But what types I can put into this collection? I can put any type that is child with respect to child type. Here you can see that I can add object of type child and grandchild. And also I always can add null, for example. I can't add any super type of type child, including parent type and object. Why? If this sounds completely not logical, then consider the next case. Imagine that we have passed here a container full of objects of type child. And in case compiler let me add parent object, and after this collection was modified, I retrieve object of child type from here and called child specific method. And program fails because that object doesn't have child specific behavior. In case I passed here list parameterized by any other type that is super with respect to child type, there is no harm in this at all to add child or grandchild object in this container, because each of the specific types for sure has behavior of its parent type. Does it make sense? We can make a conclusion. In case you want to create a method that will work with collections parameterized by different types and you wanna use this method to modify the collection and to add elements there, you have to use lower bounded wildcards. But in case you wanted to use this method only to read elements from the container to process that data, then you have to use upper bounded wildcards, because upper bounded wildcards allow us to read from the container specific type and use its methods to get all necessary data. You already learned how to use bounded wildcards, but should we use wildcards without bounds? I would say that this is super rare case. That's why let me show you this on example. Let me open source code of abstract collection. You can see that abstract collection is parameterized by e-type. But let's look at contains all method. Can you see wildcard here? That means that contains all method can work with any collection that contains any types inside. Then what is the difference between e-type and wildcard? The point is that e-type will be erased and substituted with the specific type everywhere, with the type that we will specify. Whereas wildcards would always mean any type, but not the exactly one type that we use to parameterize instance of our object. Does it make things clearer? I will leave link to this example in attachments to this lesson so that you could investigate it. But pay attention that this specific example you won't be able to run, because I described various scenarios that causes compilation error. But still, you can play around with compilation process to understand wildcards together with upper and lower bounds. Let me open the next demo file to show you the next example. In this example, I want you to understand that generic exists only for our compiler. There are no generics during the runtime because of the type erasure. Type erasure can be explained as the process of enforcing type constraints only at compile time and discarding the element type information at runtime. That means that during the runtime, it can be that objects of another type will appear in collection. Let me show you this example and give my comments as we go. I created list variable and list is parameterized by integer type. Everything looks good so far. But now I created list without specifying any generic type. That means that during the runtime, this type E that is declared in the source code of list will be erased. And everywhere where E type was used, it will be substituted with object type. For example, add method will work with any object. But in case I use bounds in generics, like for example in our demo with bounded generic for our method, during the compilation this T type will be erased and substituted with the first bound class, in this case comparable. Does it make sense? You can see that our compiler tells us that there is a warning here. It is not an error but still worth of our attention, in opinion of compiler. If I hover mouse over this warning, I see explanation message that tells me that list is a raw type. What is a raw type? A raw type is the name of a generic class or interface without any type arguments. We can still work with such types, but compiler wants to warn us that something bad may happen. Now, I tell that list reference is pointing out to the same object as integers reference. And I put string object in that list. And again, I see here the warning about type safety, but not an error. This is very unlikely that you will be able to reproduce this mistake, but I want to prove you that generics exist only to help us during the compilation time, but not during the runtime. And as you can see, I successfully added my string object to the list. But when in other part of the program or somewhere else we'll use the reference of our parameterized type integers, and when we'll call get method, we'll get object of type integer, because this variable has parameterized type. But what would happen during the runtime? What do you think? Let me run the program and show you this. And we see runtime exception, class cast exception. Java tells us that in line 15 it can't cast string object to integer. I believe you got the trick. That's it. Now you know about generics even more than some senior software engineers, believe me. Let's recap what we have learned today. Today we learned a lot of different things. Now you know what generics are and what potential problems they help us to solve. You saw how to parameterize your method in Java. We learned what bounded generics are. Together we created parameterized class. You saw what wildcards are, and we practiced a bit with upper bounded wildcards and lower bounded wildcards. And at the end of the lesson we talked about type erasure during the runtime. And now let's look at your homework. I believe you already implemented our custom list from the other homework. I left link to that homework here just in case. Also, I count on the fact that you implemented iterator and list iterator for this container. Here is the link to the homework about iterators. Now, I want you to make my list interface parameterized. And I want you to use generics for default my list class implementation. Besides that, I want you to make your inner classes that implements iterator and list iterator interfaces also parameterized. This would be a great practice for you to work with generics. That's it. Hope this task will be like piece of cake for you. That's all what I have for you for today. Thanks a lot for your attention. See you in the next lesson.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Hello dear students, today we are going to start an important and very interesting topic. I'm talking about functional programming. In this lesson we are going to understand what functional programming is, we'll understand how it is different from object-oriented approach. After this lesson you will know what the difference between method and function is. And only after we will understand the basics of functional programming, we will talk about functional programming in Java. We are going to review Java util function package and understand its structure. We will not have enough time to learn all types from that package today, but you will understand the structure of that package and what it exists for. The things that we are going to learn in this lesson will help us to boost our learning of functional programming in Java. Let's start. And let's understand first, what is a functional programming? Functional programming is a programming paradigm where programs are constructed by applying and composing functions. In functional programming, functions are treated like the main core element of each program, and they can be assigned to variables and can be returned from the method the same as other data type. To understand functional programming better, let's discuss concepts that are specific to functional programming. The first concept is a concept of first-class function. Usually this term is applied to programming language that can treat functions as first-class citizens. That means language supports passing functions as an argument to other functions, returning functions from other functions as value, and assign functions to variables. The next concept that is related to functional programming is pure functions. These are functions that have following properties. The first one, its evaluation has no side effects. That means the function doesn't modify some state variable values outside this function. And the second property is that return value of pure function is the same for the same arguments. That means given the same input will always return the same output. This can be used for code optimization. For example, if the result of pure function is not used, it can be removed without affecting other expressions. That also means that pure functions are completely independent from outside state and can be used in parallel or asynchronously. It is easy to move them around in your code, making your programs more flexible and adaptable to future changes. The third concept of functional programming is recursion. In functional programming there is no for and while loops, but what is used instead? Calling the same function from another function is called recursion and can be used for iteration. The fourth concept is that functional programs don't have assignment statements. That means the value of a variable is immutable and doesn't change state once it was defined. This is called referential transparency. The next concept in our list is lazy evaluation. What does that mean? Each programming language has strategies to evaluate code blocks. And when we call a function, programming language should define the strategy to process arguments. There are two possible main evaluation methods. They are strict, sometimes called eager evaluation, and non-strict, so-called lazy evaluation. What is the difference? In strict evaluation, arguments are processed immediately. When we invoke a function and give a list of arguments, each argument is processed and calculated before calling the function. Whereas in lazy evaluation, expression evaluation is deferred. Evaluation is delayed as long as possible, until it is necessary to evaluate the expression to produce a result. That's only 5 key concepts. In different literature you can find the different list of concepts or just different names for the same concepts that I've just described. I would say that the list of the current concepts is enough to understand the functional programming. What advantages and disadvantages functional programming has? Being true professionals, we have to understand advantages and disadvantages of functional programming approach. To list advantages, it is worth to mention that because of using pure functions that don't change any states and are entirely dependent on the input, they are simple to understand. The simplicity of functional programming is one of the advantages that is mentioned most often. The testing is easier, the debugging is easier. That is the first advantage. The second advantage is that because of the pure functions, implementation of concurrency is much easier. We shouldn't worry about state being changed from the different threads of execution in parallel. To be honest, these are the biggest advantages. You can Google advantages of functional programming if you wish, but all of them can be grouped in these two advantages that I listed. Somebody would also mention that programs are more concise and more bulletproof, but I would rather say that this is associated with the simplicity that we have just discussed and the logical benefits of pure functions. Somebody would also notice that absence of classes in functional programming makes the program code easy to read, but in my humble opinion, these advantages depend on the type of software you develop. While functional programming works great for simple programs and for beginner programmers, I would like to see how people who write articles that functional programming is the best, I would love to see how they would implement some complex enterprise solutions that requires domain-driven design and object-oriented approach. And remember team, we are professionals, that's why we don't say that functional programming or object-oriented approach is better than something else. We just say that each approach works the best for specific cases, and we need to know when to apply different approach if needed. Talking about disadvantages of functional programming, I'd like to mention few items here. The first thing that you probably might think of is that in case all values are immutable and functions doesn't change state, that would cause significant performance issues during the processing of a big amount of data, because a lot of values will be created that are not used. That would also require a specific mechanism for memory management. The second disadvantage is partially we talked through. Imagine that huge online store with customer management, personalized promotions, specific rules for discount management, affiliate program, warehouse management, etc. Imagine that this kind of program is written with only functions. Would that really make code readable? Would that make the code easy to maintain and extend? or onboarding of new engineer to the project will require a month or two for learning all functions that exist in the project. That's why among disadvantages of functional programming sometimes mentioned that in particular cases, programs that are written with the help of only functions are hard to read. The third important disadvantage that is worth to mention is that while writing of pure functions might look easy, it is a hard task to combine pure functions and make them work together to achieve some specific goal and integrate them with the rest of application. Now you know advantages and disadvantages of functional programming. Functional programming is a form of declarative programming. After you understood what a functional programming is, it will be easy for you to understand the definition of declarative programming. Declarative programming is a programming style of building the structure and elements of computer programs that express the logic of a computation without describing the order in which individual statements, instructions, or function calls of program are executed or evaluated. Does it make sense now? On the opposite of declarative programming, we have imperative programming. In computer science, imperative programming is a programming paradigm that uses statements that change a program's state. To make you understand imperative programming, I would like to use object-oriented development approach as an example. We have objects that have state and methods to modify this state. Usually Java is considered to be an imperative programming language. And in Java we usually use term method instead of function to describe some specific block of code that can be executed. What is the difference between function and method? Or this is the same? A function is a piece of code that is called by name. A method is a piece of code that is called by a name that is associated with an object. And I believe you can see that these two definitions are close but not the same. There are two main points to consider here. The first one is that method is called on the object. That's why method term is considered to be closer to object-oriented programming approach. Function can exist without any object and can be called independently. And the second point, the method is able to operate on data that describes the state of the object. Function works with arguments that are passed to it. Does it make sense? Hope now the difference between function and method is clearer. Let's talk now about functional programming in Java. Functional programming was introduced in Java 8, and I'd like to add more specifics here. In my opinion, it will sound correctly if we say that functional-like syntax was introduced in Java version 8. Java still remains imperative language. Java still uses object-oriented approach, and even functional programming in Java is implemented in object-oriented manner. That is really impressive. Java combines easiness of declaring functions and its pure object-oriented style that didn't deprive the Java feeling during the coding. Java introduced syntax improvements, namely, now we can use lambda expressions and method references during the development. We are going to learn what is this in the separate lesson and we will practice in writing our own lambda expressions and create method references. Java also introduced new package with the name JavaUtil function. Let's hold an overview of this package to understand what was introduced there. And here you can see official documentation of JavaUtil function package. Why do we need it? In this package, functional interfaces are grouped. What are functional interfaces? In short, every interface that declares only one abstract method is a functional interface. In our next lessons, we are going to learn in detail what functional interfaces are, but for this lesson it is enough to imagine interface that always has only one abstract method. And when I will say functional interface, you will understand what I am talking about. The functional interfaces provide target types for lambda expressions and method references. Let me explain you this in simple words. This package groups all types that can be used during the declaring of lambda expressions and method references. All types in this package follow specific naming convention, and this is specified here. We will not learn this right now because in my opinion it is better to learn during the practice. You can see that this package was introduced in Java version 8. And here you can see a list of types that we are going to learn. There are clear explanations written right here next to type name. I can leave the link to this documentation in attachments to the lesson and you would read it after the lesson. Don't try to understand everything, because we are going to have lessons that will teach you how to work with types from this package. But you can try to understand why we need some types here. For example, here you can even see a function type. This type is developed to represent a function that accepts one argument and produces a result. While learning Stream API, we will use some of these types to declare our Lambda expressions. And now, when you can see the whole list of types that allows us to create an object of these types, you can understand why a few minutes ago I said that functional programming in Java implemented with the feeling of object-oriented paradigm. You can see that function is also a separate type, and I can create an object of function type. I believe this information is more than enough to understand what functional programming is and what we are going to learn. Let's recap what we have learned today. Today we learned what functional programming is. We discussed main concepts of functional programming. After that we discussed advantages and disadvantages of functional programming. Also, today we learned what is imperative and declarative programming. We learned what the difference between a function and a method is. And at the end of the lesson I told you what functional programming in Java is and hold an overview of Java util function package. I believe now we have enough theoretical knowledge to proceed our learning of functional programming in Java. That's all what I wanted to discuss with you during this lesson. Thanks a lot for your attention. See you in the next lesson. Hello dear students, in this lesson we are going to learn what Lambda expressions and method references are. Today we are going to have really a lot of practice. After this lesson you will be able to write Lambda functions like a pro. I will explain you what functional interfaces are, and we will learn the difference between regular and functional interfaces. By the end of the lesson you will know how to create your own functional interfaces. We are going to learn what Lambda function is and what method reference is. I prepared special examples that will help you to grasp the knowledge faster. I am going to show you how you can write Lambda functions and how you can use method references. Let's start. And today, the best way to learn the topic is start from examples. That's why I suggest switching to the Eclipse and start our lesson. To understand how to use Lambda functions and method references, we have to understand first what functional interface is. As we briefly discussed in previous lesson, functional interface is an interface that has single abstract method declared in it. Take a look at this example. This interface is called distance calculator. It is declared to have a hierarchy of types that can calculate distance of delivery of customer's order in miles. Calculator can calculate the shortest path, the most optimal route for interstate delivery, distance from the closest store or from the specific store, and lots more. All this might be implemented in calculate distance method in other types that will implement distance calculator. This method also takes two objects of city type that store inside coordinates. We have city type declared here. This is a type created just for our example. The state of the city can be described with the help of the coordinates, longitude and latitude. And we have getters and setters here. Now, you have the context of real-life business case. I believe that understanding of real-life example will help you to grasp new knowledge faster. That is great. You can see new annotation here. Functional interface. What is it for? First of all, this is a great sign to notify clients of your code that originally this interface is created to be a target type for Lambda functions and method references. And the second reason to use this annotation is that in case somebody would try to add additional abstract method, there will be a compilation error. Let me uncomment this line of code that contains declaration of additional method. And here you can see we have compilation error now. That's why functional interface annotation helps us to prevent cases when someone wants to add additional behavior to the type that we already used in other part of the program as a type for Lambda function. Hope it is clear what function interface is. Let me comment this method again to proceed. Pay attention to the fact that functional interface can contain as much default methods as possible and as much static methods as possible. This doesn't violate the rule for functional interface. That's it regarding functional interface. That was easy, agree? Let me congratulate you. Now you know how to create your own custom functional interface. And now, when you know what functional interface is, let's learn what lambda expressions are. Let me open the next example that I have prepared before this lesson. I have few more classes grouped here in one file, just for the sake of example, to not switch tabs between different files. Imagine that we have a class with the name order management, and this class requires an instance of distance calculator type to perform all operations related to order management. We can pass instance of distance calculator type either with the help of constructor or with the help of the setter here. That means you need to create an object of type distance calculator in your program. But you know that you can't create objects on the basis of interface, right? That's why you declare a concrete class, let's say default distance calculator, and implement distance calculator interface here. Now, when we create object of type order management, we create object of type distance calculator. But what to do in case we need to change distance calculator to take into account specifics of interstate delivery? In this case, we have to create another concrete class. And we need this just to override calculate distance method only once. Is it worth it? We think that this doesn't worth of our efforts, and we decide to declare anonymous class and create an instance of anonymous class. This time we take into account logic for interstate distance calculation. Okay, but can you see how much lines of code it takes? It is super weird that we have to declare a concrete class just to give implementation of one single method. We can create dozens of concrete classes to implement dozens of functions. But do we need to overwhelm our application with additional classes if we just need one function in one single place? No. That's where lambda function is going to help us. But what is lambda function? It is also called anonymous function. It doesn't have any name. Usually, anonymous functions are passed to higher order functions. Also, in case the function is only used once or limited number of times, it will be easier to use lambda expression rather than declaring concrete class. Indeed, to create an object of type distance calculator, we have to just implement one method. Take a look here. I declare a new variable of distance calculator type to describe new logic for calculate distance method. And here you can see the lambda expression. Here it is. Lambda function, anonymous function, we can call this in different ways by using different names. Let me explain you the syntax. Here you can see parentheses that we usually use for method invocation or to pass arguments. You can see that I pass city1 and city2 arguments. Where I took these? I didn't create any objects. This is just local method variables, similar to ones we use in method declaration. Using these variables, I can get access to objects that my function should work with inside the method body. I will show you that in a second. Why I don't write types of these local variables? Because compiler knows that I wanna give implementation of the method from distance calculator type, and the first argument in this method has type city, the same as the second argument. That's why compiler knows that these local variables should be of type city. But in case I will add types here, there is no harm in this. Just like this. In case if distance calculator wouldn't declare any method parameters in calculate distance method, in that case we would skip method arguments here and would leave just blank parentheses. Like this. Here is lambda and here goes returned value. Here is some dummy calculation. For example, I perform subtraction of longitude of city 1 and city 2. That doesn't give us the true distance between cities, but makes you understand that you can perform any calculations here. And the result of this calculation is returned from the method. We are skipping return keyword here, because compiler knows that I wanna give implementation of the abstract method of distance calculator type, and compiler knows that this method should return value. Technically, creation of object of anonymous class and this is the same, because calculate distance implementation is the same as here. The next point you have to know about our syntax. In case our anonymous function consists of more than one line, then we need to use braces. And here you can see an example. Also in this case we have to write return keyword. I believe you see that in this case, visually, this lambda function is closer to the method we have here in anonymous class. we are missing only return type value, method name, type of local variables, and access modifier. So in case I write here public double calculate distance, and in case I would add types to local variables, does it make more sense like this? But for lambda expression, we don't need to specify access modifier. It is already accessed here. Let me remove it. Also, we don't have to specify return type, because our Java compiler can understand that we are going to implement method from distance calculator functional interface, and the method inside this interface has double return type. Can you understand now why it is important that functional interface has only one abstract method? Because in case functional interface has more than one method, then it is not clear what method I try to implement with the help of anonymous function. Is that clear? So I can remove return type, and also I can remove method name, because it is clear what method I want to implement, and I don't need any other identifier to access this function. And I believe you already understood why I can remove also types of my local variables, because compiler knows that these variables will be of type city according to the interface. Here you can see that I can call calculate distance method on my reference here, and I believe you already understood that these lines of code will be executed. Let me prove you this. I run the program, and here you can see console output from the lambda function. And when I need implementation of distance calculator interface, and I need it only one time only, it is easier for me to create lambda function rather than declare a concrete class and create an instance of a concrete class. For example, here in the set method I can pass any function I need, and that will be enough for order management. Because order management is interested not in the fact of getting object of type discount calculator. Order management is interested in getting behavior to calculate distance, and I give the specific definition of behavior with the help of lambda function. Usually it is not instantly clear for my students where we will get arguments for the lambda function. I want you to understand that lambda function, it is not a method invocation with arguments. It is just a definition of the method with parameters, similar to the thing we do when we implement any interface in concrete class. So, the city objects will be passed here to this function, wherever it will be needed according to the logic described in the order management. Sometimes we only know that some type, like order management, just needs logic to calculate distance between two cities. And sometimes we really don't care where order management will get those cities. Probably they will be passed to other methods of order management or will be present in order details, but we let order management object decide when to call our function, and we let order management bother about what cities to pass there. Does it make sense? Hope you understood what lambda function is. Now let me explain you what a method reference is. Imagine that you already have methods that do exactly the same what you want. Probably it is from some external library, or probably it is just from another class. Then why do we need to declare a concrete class to override method or create lambda function? Why don't we just tell to order management object to use the method that already exists, in all cases when order management needs to calculate distance? We can do so. And for this we have to use method references. Let me show you the next example. Here is the example of some third-party class. Imagine that it is called Google Distance Calculator, and it has method for distance calculation. It is called getDistance between cities. You can see that we have static and non-static method. That is for the sake of example to cover few cases. Please pay attention to the fact that type of returned value and type of method parameters is the same as we have in distance calculator interface. This is important. And now, when I need to set new distance calculator into my order management object, I just pass the reference to this method. Let me explain you the syntax here. Here is the name of our class that contains the method that we need, followed by double colon. This is the syntax of method reference. I'm referencing to the getDistance between cities static method in Google Distance Calculator class. Does it make sense? And again, this is not method invocation. That's why I don't pass any method arguments here. Order management just needs something that can take two cities and will return double value. That's all what order management object expects from distance calculator type. And this method from Google Distance Calculator do the exact things that order management wants. That's why there is no compilation error here. Pay attention that I use class name to make a reference to static method. In case I wanna make a reference to non-static method, I have to create object. And here you can see that I created object. Now I can use variable of my object to make a reference to the non-static method. Does it make sense? Hope now it is clear how method references work. We learned a lot today. Let's recap what we have learned today. Today we learned what functional interface is, and we even created a custom functional interface. Now you know what lambda function is and how to write your own lambda expression. After that, we learned what method reference is. On real example, we learned how to apply your knowledge. That's it for this lesson. Thank you for your attention. See you in the next lesson. Hello dear students, in this lesson we are going to learn interfaces from Java util function package. They are function and by function. In this lesson we are going to have a lot of practice. To help you understand these types better, we'll use map implementation for all examples. That will give you understanding how you can apply your knowledge in real-life cases. And while learning different types, we'll create a lot of lambda functions and method references. We are going to learn default methods from function interface. You will learn what is the difference between and then and compose methods. We'll discuss identity method from the function interface, and I will explain you how it works and what benefit we can get when we use it. At the end of the lesson, I will show you how you can create comparator with the help of function. Let's start. And to learn this topic, it is better to learn it from the source code and on real examples. We'll start our lesson from the function type. Function interface is a functional interface that declares one abstract method that takes some value as an argument and can return something. Pay attention that function interface is parameterized by two types. In case you don't remember what generics are, please look at generics lesson to refresh your knowledge. Two types are needed here in parameterization to put a stress on the fact that type of the argument may be different than type of returned value. The function is usually applied where you need to produce some result of different type on the basis of other argument. Let me show you function example. I created separate file for all examples that we are going to review today. I will leave link to this file in lesson attachments. And as I said in agenda of the lesson, we will use classes from Java Collections framework to show you how you can apply the knowledge of functional interfaces. I created an object of hash map type. Our hash map is parameterized by integer type for keys and string type for values. I fill out the map with the dummy values for the sake of our demo. In this line of code, I want to print the value that is associated with the key 4. I believe you can understand that null will be printed to console because I didn't put any value for key 4. Now, on my map, I want to call computeIfAbsent method. Let's look at the source code of this method to understand what it is for. This method should compute the value for the key in case the key is not already associated with the value or is mapped to null. And this method will compute the value using the function that we pass to this method. You can see in method arguments that this method takes key as a first argument, and also it requires a function type argument. And here you can see apply method is called on our function. The function that will be given to this method is parameterized by any type that is compatible with the type of our key and any type that is compatible with the type of the value in this map. And knowing how a function works, we already can understand that key will be passed to our function and value that should be associated with that key will be mapped to it. Now, let's get back to our example. I created all examples here before the lesson to save the time during the video recording. Let me explain you what is written here. I call computeIfAbsent method and pass the key, and the second argument is a function. From the syntax standpoint, you can see that in case we have only one argument, we can skip parentheses. Here is the local variable key, And I have to return string type, because the returned value should be compatible with the value type of our map. For the sake of the demo, let me return string representation of 4. Does it make sense? So now, during the execution, this lambda function will be called inside computeAbsent method. Let me show you source code one more time. Here, apply method of our function will be called and key will be passed to it. We'll return string value that is not null, and after that it will be inserted into the map. Is it clear? Let me run the program and print to console the value that is associated with the key 4. And here you can see that before we call computeAbsent method, there was no value associated with this key. And after we call the method, we can see the value that is associated with our key. Hope this example brings you understanding how we can create lambda functions for function interface. You saw how smart computeAbsent method is written. It uses function interface as an abstraction, and we can pass any implementation of the interface that we want. Now, I want you to understand that lambda functions and method references are interchangeable. By saying this, I mean that instead of lambda function here, we can use method reference. Let me show you how. Here in this demo class, I declared static method that takes some integer as an argument and returns string. It looks like this method meets the requirements of function interface and work with types that are compatible with the current map key and value types. If computeAbsent method needs some function that can take integer and return string, then I will tell it to use convert into string method. And in this line, you can see that I used method reference to the static method. Does it make sense? Hope you understood how method references work. Let's move on. The next thing I want to talk with you about is by function. Let me open the source code of by function interface. You can see that this is also a functional interface that is parameterized by 3 types. It has one abstract method that takes 2 arguments and returns result. Now you can understand the naming convention in Java util function package. Depends on arity, we add different prefix to interface name. Just to refresh your knowledge, I want to remind you what arity is. Arity is a term that is used in computer science to specify the number of arguments taken by function. Regular function takes 1 argument. By function takes 2 arguments. This prefix is widely used in Java util function package. Now you will understand what it means. You can see that 2 arguments here and return type, all of them might be of different type. Let me show you the by function in practice. Let's return to our demo file. Now I want to compute new value on the basis of existing key and existing value. I call computePresent method on map object. I suggest investigating the source code and documentation for this method. As we can see here in documentation, in case value for the specified key is present and non-null, this method will compute a new mapping given the key and its current mapped value. From the method declaration we can understand that we have to pass some key to this method and by function that is parameterized by type that is compatible with the key and types that are compatible with the value. Based on the by function interface we can understand that the first and the second type in diamond operator are types of the arguments, and the third type from the diamond operator is the type of returned value. You can also understand the same after investigation of the source code of computePresent method. Now let's write our own lambda expression in our demo class. Taking into account by function requires 2 method arguments, I declare 2 local variables here, and we have to return string that will be used as a mapping value to key 3. Just for the sake of the demo, let's create custom string values that consist of the key itself and previous value associated with the key separated by colon. And you can see in console that the value associated with the key 3 is updated. I believe you already understood how to use method reference in this situation, but just in case I also wrote an example here to reach complete understanding. Here is a method that is compatible with the expected return type and type of method parameters. And here you can see that I use this method as method reference instead by function here. Now, when you understood what function and by function are, I want to draw your attention to the methods that we didn't discuss. Those are default methods from function and by function interfaces. The way how they work are similar, that's why we will review only example with function interface. Let me open again the source code of function interface. Here you can see that we have default methods compose and then methods. These methods allow you to compose new function from existing ones. To understand this, let me get back to the demo file to show you an example. Consider the next case. We have product type. Product has price and ID. That is unique product identifier. We also have getters and setters declared here. Besides that, I override toString method. This will help us during the debugging when we will print product to console. For the sake of the demo, I declared all types in one file to not switch between tabs in Eclipse. That's why you can find this class at the bottom of our demo file. Now, imagine that we have map object that should map product against discount amount so that I could get discount by product. That's why my map is parameterized with product type for keys and double type for values. This example is just to help you to understand the case. Imagine that I have a list of products. In real life, I can fetch this data from the database or parse from some file. Each product has its ID and price. Now I have to fill out my map. How I would do that? I create for each loop to iterate over all products. And on each iteration I compose two functions. The first function just extracts the price. The second function calculates discount based on this price. I use constant value for that. This means 5% discount. And I want to get amount of money for my discount. That's why you see multiplication here. After that, I combine these two functions. I combine them in the way the first function will be getPrice function and the second function will be getDiscount function. Probably you think that it is a lot of code and you could calculate discount in one function here, but focus on the fact that you can combine two functions. This example is about that you can create new function on the basis of already existing functions. You can mix them as you wish. Next time, you don't need getPrice combined with getDiscount function, but you need getPrice and, for example, getTax function. Can you understand now the benefit of function composition? This gives you flexibility in combination of functions. And after that I call computeIfAbsent method, pass the key to this method, that would be product, and function that calculates the discount. Let me print the map that we received to console. And here you can see that each product is mapped to the discount. Is it clear? Now, when you know how then method works, let me show you how compose method works. The only difference between these two methods is the order in which functions are combined. In case I use function, then call then method and pass another function, this function will be executed after the first one and will take the result of the first function as an input argument. Does it make sense? In case I use compose method, then I should specify a function that should go first. So, technically, these two functions are the same, but the order that I used in syntax is different. In my second function, I use getDiscount function to call compose method and pass getPrice function to it. That means getPrice function will be executed first, and after that, getDiscount function will be executed with the result of getPrice function. Hope I didn't confuse you. Now you know the difference between then and compose default methods in function interface. Let me open by function interface now. Here you can see only one default method, then. Knowing how to create lambda function for by function interface and knowing how then method works in function interface, I believe you would be able to apply this method during the development when it will be needed. There is also one more default method in function interface that we didn't talk through. I'm talking about identity method. Pay attention to the source code of this method. This function always returns its input argument. Here is simple lambda expression for that. But should we use this method instead of similar lambda function? Yes, we should. Because writing lambda expression will create an instance of function type after each occurrence of lambda function, whereas calling identity method you would get always the same instance of the function. So, using function identity instead of this lambda function might save you some memory. But that shouldn't drive your decision if you really think that lambda function is more readable than function identity. I would love to show you the example of this method and tell you where and when you can apply this method, but we need knowledge of Stream API to understand the example. Basically, we use this method only when we are forced to pass function, but we don't need to modify input argument. You will face with such cases while working with Stream API. Don't worry, in the lessons about Stream API we will talk about this method. And the last but not the least example that I wanted to share with you today is how to create comparator with help of function. Let me open comparator interface. I believe you remember that comparator interface has a lot of default methods. Some of them use function interface. I'm going to show you one example that will give you understanding how you can use the rest of the methods that take function as an argument. Here we have really cool method that most likely you will use. It is called comparing. It creates comparator on the basis of the function that extracts the comparable key that should be used to sort by. To help you understand this, let me show you in the example how this works. Today we created list of products, I believe you remember that. Imagine that I want to sort list by its price. That's why I call sort method on my list. I have to pass comparator here. I don't need to create a concrete class of comparator type. I also don't need to implement comparable interface in my product type. I can just pass the function that can extract the field that should be used during the sorting. And I already have this function. Let me pass the method reference to getter in my product class. This getter knows how to retrieve price from each product. Taking into account I have list of products here, and I don't have identifier of a product, I can use a class name to make a reference to method. Compiler is smart enough to understand that this method should be called on each object from this list to extract key. Double is comparable type. That's why sorting will be performed without any issues. And here is analogy written with the help of lambda function. These two lines are similar. In console we can see that when I printed list, all elements are sorted by price. So now you know how to create a comparator by using function. That's all examples that I wanted to discuss with you in this lesson. Let's recap what we have learned today. Today we learned what function and by-function interfaces are. We learned what methods they have, and we know how to create lambda functions and method references for these interfaces. We learned how and then and compose methods work. Now you know the difference between these two methods. I believe after this lesson you also know how identity method works in function interface. And also, today we had a lot of practice, and on real-life example we learned how we can use function and by function during the work with map implementations. At the end of the lesson you saw how to create comparator with the help of a function. That's all what I have for you for today. Thanks a lot for your attention. Have a great day and see you in the next lesson. Hello dear students, in this lesson we are going to learn what consumer, by consumer, predicate and by predicate interfaces are. As usual, we'll start from investigation of a source code of all interfaces. We'll review all methods that are defined there. On real examples I will show you how you can use these types and how to implement lambda functions and method references to implement consumer, by consumer, predicate and by predicate types. After that we'll talk about two other types. We are also going to review default and static methods from these interfaces. We have a lot of things to learn today. Let's start. The best way to learn this topic is to investigate the source code and real examples. I suggest starting our lesson today from the overview of consumer interface source code. As you can see, similar to other types declared in JavaUtil function package, consumer is a functional interface that has one abstract method with the name accept. It takes some argument and returns nothing. So, this type exists to perform an operation on the given argument. Unlike other functions, this type of function usually produces side effect. I'm talking about that the reasoning to use this type is to modify the state of the argument and create a function for that. This interface also has one default method, this is an then method. In the previous lesson we learned how we can use an then method to compose new function on the basis of two other functions. It works the same way with consumer. That's why we'll not pay a lot of attention to this method, taking into account we reviewed it in previous lesson, but instead I will show you examples of consumer on practice. I prepared real-life example for you that will help you to grasp new knowledge faster. I will leave the link to this file in the lesson attachments. Imagine that you have a list of products. This is product type that we used for some of the home tasks while learning collections. Let me remind you how it looks like. This type sets contracts that allows us to retrieve ID, product name, category name of each product, and set price if needed. In our example we will use default product type that implements product interface. Nothing special in the source code of default product type, just state with getters and setters. In our example I created few test products. I passed to constructor ID, product name, category name, and price. Hope this is clear for you. Now, imagine that I want to give possibility for administrator to increase price of products. For example, administrator could select the specific products, those products will be grouped in the list object on the backend, and price will be increased for each product from this list by amount of money set by admin. Here I created method increasePrice for product list that takes as arguments a list of products and specific amount of dollars to increase price. And in method body I take iterator of my product list and call for each remaining method. Let me open the source code of this method to explore it together with you. As you can see, this is a default method declared in iterator type. It takes consumer as an argument. In simple words, it takes some action that has to be performed with each element remained in this iterator. You can see that we have while loop here, and accept method of consumer is invoked for each element from this iterator. Now, let's get back to our demo file and we will implement lambda function for our consumer. Here you can see the anonymous function that takes one argument and that returns nothing. I call setPrice method on each product and set the result of addition of current price and local variable that passed to the method. And in my program, I can call this method and pass list of products and amount of money to increase price. After that, let me print each product from the new line. I run the program. Here you can see in console output that price is increased by $10 for each product. Can you understand now how we modified state for all products in collection with the help of consumer that we passed to for each remaining method? Hope it makes sense. By the way, I believe from the previous lesson you already understood that this lambda function is interchangeable with method reference. Please let me know in case there are any questions. When you understood how consumer works, let me show you how ByConsumer works. I open source code of ByConsumer interface. We learned with you specifics of naming convention in Java util function package during the previous lesson. Now you can understand that this by prefix is associated with the arity of accept function. You can see that accept takes two arguments and returns nothing. This interface also declares one default method and then, that is similar to other interfaces from this package to compose new functions on the basis of already existing functions. Now I want to get back to our demo file to show you an example. For our next demo, I created an object of type hashMap. It is parameterized by integer and product type. Imagine the similar case. I have product IDs that are mapped against the products, and I want to have opportunity to update each entry in map. For that purposes, I have created increasePrice for product map method that takes map of IDs and products and price to increase. Here you can see that I call for each method on my map object and pass ByConsumer there. Here's lambda function that takes two arguments and returns nothing. In case I don't need to modify key, I just ignore it. And you can see that body of this function is similar to the previous one. The only difference here is that I have access to the key in case I need it. Now in my program I can call the method and pass map object and price to increase. After that, we print each product from new line in console. And in console output, you can see that price is increased. Knowing the difference between consumer and by consumer, you can use either of these types during the development. Also, you saw how to investigate the method signature to understand what type is expected. Usually it is obvious what will be passed to the function as arguments. But in case it is not clear, you can investigate the source code of method that requires function. One of the goals of this course is not to teach you all possible things, but to teach you how you can learn these things by yourself. Let me show you how you can understand what values will be passed to the anonymous function during the runtime. For example, I open the source code of for each method in map type. The first thing I want to know is where accept method is invoked on the byConsumer argument. Here is method invocation, and I see that k and v variables are passed. But what object stands behind k and v variable? Based on the variable's name, it is clear what key and value are referencing to. But just in case, we can check it few lines above. We can see that k variable is initialized with key value on each iteration, and v variable is initialized with the mapped value. You can see that operation is performed for each entry. That's how you can easily understand what values will be passed to the function. Okay, now when we learned consumer and byConsumer types, I want to learn with you predicate and byPredicate types. I believe that knowledge of lambda functions and method references will help us to learn predicate type faster. Let me open the source code of predicate interface. Predicate has one abstract method with the name test. This method takes an argument and returns Boolean value, either true or false. In Stream API, predicates are used very often to filter values and remove elements, for example. To help you understand how predicate works, let me show you a simple example. For predicate example, I created separate file. I will also leave link to this file in attachments to the lesson. Imagine that you have list of products. Here you can see product list that is similar to one we have in consumer demo file. And we have to remove all products from this list that have price more than you specified. To address this requirement, I created remove products if price is more than method that takes list of products and price as arguments. On my list object I call remove if method. Let me open source code of this method. As you can see, this method is from collection interface, and it takes predicate as an argument. Test method will be invoked for each element in this list, and in case test method will return true, then this element will be removed. Based on this, we can make a conclusion that we need to write a function that will return true for elements that must be removed. Is it clear? Now let's get back to our demo file. I wrote function here that returns true in case product price is more than price value that was passed to this method. And in my program I call the new method and pass list of products there and 100. That means that all products that have price more than 100 will be removed. We can see that I have only one product with price more than 100. That's why when I print all products to console from the new line here, I still expect to see the rest two products. Let me run the program. Based on console output, we can make a conclusion that product with price more than 100 was removed from my list. Awesome! Now let's investigate the default and static methods from predicate interface. It has AND method that allows us to compose two functions and add additional predicate. This gives us a similar flexibility that we learned in lesson about functions when we combined different functions. Let me show you the next example in the source code. Imagine that I need to remove all products that have price more than some specific value and category name is category 1. I create a method where I create two functions. The first one is already familiar to you. That function is to test the price. And the second function checks category. And when I call remove if method, I create the new function that is returned as a result of AND method invocation. I combine these two predicates. Now element will be removed only in case requirements of two predicates will be met. In my program I pass list of products, price and category 1 name. Based on the current state of my product list, I can see that only one product will be removed after the method invocation. Product with ID 1 has price more than 90 and category name is equal to category 1. And in console output you can see that product with ID 1 was removed. And I want you to understand that you can compose multiple predicates together. Not only 2, but even more if you need. That will allow you to create customized predicates when it will be needed. In case we want to compose predicates to receive predicate that will return true in case we meet requirements of at least one predicate of combined ones, then we need to use default OR method from predicate interface. I believe that is logically clear and doesn't require any additional demo. The next default method in predicate interface is negate. It returns logical negation of the current predicate. Is it clear? Let me show you this on example. In case in our previous example I would call negate method, the result would be opposite. That means in case this function returns true as a result, the false will be returned after negation. Let me call negate method here and run program one more time. And in console output you can see that product with ID 3 was removed. So the product that is less than 90 and the product that has category name that is not equal to category 1 was removed. Can you understand now what negate is? If yes, then let's proceed. We have 2 more static methods here. IsEqual method returns you the predicate that will check if 2 arguments are equal. To make sure that predicate will work as expected, we need to check that equal method in the type that we want to use for comparison is overridden. This is needed because for comparison will be used objects equal method. And the second method is not, that takes predicate as an argument. This method negates the result of the supplied predicate. You can see that this is achieved by using call of negate method inside. So technically you can use either negate method in case you have variable of type predicate, like I showed you an example, or in case you don't have variable of type predicate, you can call predicate not method and pass lambda function here. To help you understand these 2 methods, let me show you an example. In our predicate demo file, we have one more example at the bottom here. Imagine that we have list of users. I use user for hash tables type that implements user interface. I use exactly this implementation because it has equals method overridden. We added few users to the list. You can see user ID, first name, last name, password, and email. That's just for the sake of example. And according to business requirements, I have to be able to filter the list of users to leave there only users that I need. Here I created user object that will be used during filtering. I call removeIf method on my list of users, and I call predicate isEqual method here. But in case I would call just this method, I will get predicate that will remove only user that equals to this one. I need exactly the opposite. I need to keep only this user. That's why I have to use negation here. And technically I could call negate method here, but also I can pass this predicate to static method not. Is it clear? And when I print the list of users to console, I see that I have only users that I wanted to keep in the list. Awesome! Now you know all methods from predicate interface. And the very last thing that I wanted to discuss with you is by predicate interface. I believe you already understood how predicate works. The only difference is that test method takes 2 arguments here. We'll use this method when we'll learn Stream API. But the principle of writing and using by predicate is similar to examples that we saw with predicate. Besides one abstract method, this interface also has 3 more default methods. They are AND, negate, and OR methods. We have just reviewed similar methods from predicate interface, that's why I think that there is no need to review examples with these methods. But let me know in case you have any questions. That's all what I wanted to share with you today. Now let's recap what we have learned today. Today we learned with you consumer and by consumer interfaces. On real examples you saw how you can create lambda functions for these types. After that we learned predicate interface, we learned all methods from predicate interface and had practice exercises with this type. And at the end of the lesson, we talked about by predicate interface. That's all for this lesson. Thanks a lot for your attention. See you in the next lesson.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Hello dear students, in this lesson we are going to discuss topics that will help to make your code clean and concise while working with collections and arrays. Today we will talk about Stream API. At the beginning of the lesson we will give an answer what Stream API is. I will explain you why we need to use Stream API with arrays and collections sometimes. After this lesson you will understand what a conveyor belt is and what terminal and non-terminal operations are. You are going to learn how to create stream and how to process elements with the help of Stream API. I am going to show you really a lot of examples today. I will teach you how to create stream from array and how to convert list to map with the help of Stream API. In this lesson we are going to have a lot of practice, because one of the ways to understand this topic better is to understand how you can apply this knowledge on practice. Let's start. And to start with, let's create a definition of Stream API. If we would open official documentation from Oracle for Java Util Stream package, we will see that this package contains classes to support functional style operations on streams of elements, such as map-reduce transformations on collections. I believe for people who didn't work with streams, this definition doesn't bring a lot of clarity. So let me explain you the same in more simple words. Stream Application Programming Interface is a set of interfaces that allow to process elements and to perform operations with them in containers and arrays with the help of functional interfaces. So, to perform operation on the group of elements, you can create lambda functions or use method references that in turn significantly simplifies your code. Does it make sense? Now, let me perform an overview of one important interface from Java Util Stream package. This will help you to understand our practice examples. I would say that one of the most important interfaces is Stream Interface. What it is for? Stream Interface represents a sequence of elements supporting sequential and parallel aggregate operations. This is hard to understand, believe me, I know what you feel. Usually I ask my students to imagine conveyor belt, and on this conveyor you have elements from your collection. And as conveyor belt rolling, you take each element from it and perform any modifications with it. Before we dive deeper to code examples, I want you to understand, at least on a high level, the next example. Imagine that you have a list of products, and you have a task to keep only that products that has more than 1000 items in the warehouse and decrease price for these products on 10%. This business logic should change the price for products, and this in turn should motivate customers of the online store to buy these products while price is reduced. How would you do that? You would create the container of products. Let's imagine that this is a box that is full of products and put all products on conveyor belt. After that, you will check what products has more than 1000 items in warehouse. You will remove from conveyor products that you are not interested in. That means you have to apply function that knows how to filter elements. After that, you will modify price for each product. That means you have to apply function that modifies state of the product. And only after that, at the end of the conveyor belt, you would gather all elements together back to the box. Is it clear? Now you can understand that the function that was applied for each element on the conveyor belt, they are called non-terminal. Also, they might be called intermediate functions, or it would be proper to name them conveyor operations. And the methods that terminate conveyor are called terminal operations. We also can say that each non-terminal operation adds listener to the stream. Listener modifies the element and passes it to another listener. This is called stream processing. Terminal and non-terminal operations create stream pipeline. Stream pipeline consists of the source, that is our collection of elements or array, followed by intermediate operations and ended with terminal operation. Let's consider another case. You may have multiple lists of products. How it can be? You have different warehouses, and each warehouse contains information about the products there. So, you have multiple lists of products from each warehouse. This may happen when domain-driven design of your application declares that you have type warehouse that in turn can return list of products. And imagine that you have list of warehouses. In our example, you have a lot of warehouses with products. We can create conveyor of warehouses. But we can also have the function that would tell how to extract products from these warehouses to have conveyor of products. And after that, we are going to have similar to previous example logic. We'll filter elements and we'll perform price modification. I believe now you understand what we are going to learn today. We are going to learn terminal and non-terminal functions to perform operations with elements in streams. Now, let's look at the code examples that I prepared for this lesson to understand how streams work. We'll start from reproducing the case that you saw on slides. All classes are stored in one file to keep all examples related to this lesson grouped and to not switch between the different tabs during the lesson. Here we have product class. It has price, name, and amount of items in warehouse. Also you can see special constructor, getters and setters to string method for debugging purposes. And here you can see warehouse type. For the sake of our next examples, this class has only one field, list of products. Also there are two methods, getter and setter, to retrieve and to set products accordingly. Now imagine that I have list of products. You can see that I created multiple different products here and put all of them into the list. To create stream from this list, I have to just call stream method. Stream is a default method in collection interface, so all collections have stream method. After we created stream, we can call intermediate operations and add listeners. For example, let's reproduce the situation from the slides that we saw at the beginning of our lesson. I call filter method. Let me open the source code of filter method. You can see that filter method takes predicate. All intermediate functions return the stream objects. That allows us to create chain of method invocations. Filter method returns a stream consisting of the elements of this stream that match the given predicate. That means in case predicate returned true for some element, we should keep this element in the stream. Let's get back to the demo file. We use simple predicate here. We wanna keep on our conveyor belt only products that have more than 1000 items in the warehouse. After that, I wanna apply function to each element. I use map method for this. Let me open the source code of map method. This method returns a stream consisting of the results of applying the given function to the elements in the stream. In our particular case, we modify product and we return the same product to the stream. We set the new price that is 10% less than the original one. Important thing to know here is that intermediate operations are lazy. This means that they will be invoked only if it is necessary for the terminal operation execution. Let's give you the understanding that these lambda functions will be executed only in case there are terminal operation at the end of the chain. And now, when I did everything I wanted, I wanna create a collection of items that are currently on the conveyor belt. I call terminal function collect. Let's review the source code of collect method. Here we can see that this method takes collector as an argument. But what is collector? We have only one way to learn this. From the source code we can understand that collector is a specific type that accumulates input elements into a mutable result container. But where to get the implementation of collector? Usually engineers use collectors class to get any collector that is needed. Let me show you the source code of collectors class. This class also from Java util stream package. And in the method outline you can see that we can get different collectors. The most popular in my opinion are the ones that are returned by the next methods: to list, to set, to map. Also, you can get collectors that will collect all your elements to an unmodifiable list, for example. Most of the methods are self-describing here. That's why I don't see the sense into naming all of these methods. Just open the source code of this class to investigate what other collectors you can use. By the way, at the end of the lesson I will leave a cheat sheet for you where I will gather all the most popular methods including the terminal functions. Let's get back to our demo file. In this case, I want to group all elements from my stream into the container. I call collect method and pass collector that is returned by toList method invocation. Is this example clear? So, you can see method chain here with multiple intermediate functions. At the end, I have one terminal operation. Where did I get these intermediate methods? You can open stream type to investigate the rest of the methods here. We'll review these in a minute. Let me finish the example we already started. Let me get back to the demo file. And after I created the list, I want to print all elements to console from the new line. But instead of creating for each loop, I will use the feature of stream API. I create a stream using the variable of modified products. After that, I call for each method that takes consumer as an argument, and I pass method reference here. Out property of a system class has method println that we use very often during debugging of our programs. So, I just use reference to this method. Let me run the program to prove you that it works. And here we go. You can see that I have only 3 products with modified price. Awesome! Everything works as expected. Now, let me reproduce the second example from our presentation. Imagine that we have multiple warehouses. I created few warehouses objects here. Each warehouse has list of products. That's why I added different list of objects to the warehouses here. And imagine we have to iterate over all products to decrease price only for products that have more than 1000 items. First of all, I group all my warehouse objects into one list. Now I create a stream out of this list. After that, I call flatMap method. What is it for? This method exists to extract elements from another ones. This method will return stream consisting of the result of replacing each element of this stream with the contents of a mapped stream produced by applying the provided mapping function to each element. Is it clear? We'll pass function to this method that will produce stream of elements from each element. In our particular case, we have to get products from each warehouse object and create stream on list of products. Before we called this flatMap method, we have conveyor belt of warehouse elements. And after we called flatMap, we have stream of product elements. Can you understand now how we can transform data in our stream? After that, we have filtering and applying function to all elements. Now, let me show you one more thing. Imagine that according to some method contract requirements, you have to return array. We can call toArray method instead of collect. But in case we would just call toArray method, we would get array of objects. What to do in this case? I have to pass the method that will create array of the specific type that I need. What method can create array of product? Constructor. That's why I specify type here, array of product, and pass the reference to constructor. According to syntax requirements, I have to write the new keyword here. Can you understand now what this means? Now, Java can create object of product array. After that, I wanna print all elements to console from new line. But we have an array this time. Can I create stream from array? Yes, I can. I have to call stream method from arrays class and pass array of products there. That's how easily you can create stream from any array. Also, during the discussion of functional interfaces, I promised to show you one method and how it might be helpful while working with stream API. I'm talking about identity method from function type. Imagine that you want to convert list of products to the map type where you are going to have product name as a key and product type as a value that is mapped to this key. How to do that? You remember at the beginning of the lesson I created products list? In this example I use the same list of products. I create stream, call collect method, and after that I call toMap method from collectors class and pass two functions. The first one should create keys, and the second one is a function that can create product values that are associated with specific keys. Taking into account I don't need to modify product, I should return the same product. That's why I use identity method of function type here. Identity method returns the same object. Does it make sense? The last code example that I want to share with you is map-to-int and some method. I would even say that there are a group of methods that you will use, and these two are just one of many. There are numerous of business cases when you need to process collection of elements and find is a max price or sum all values of some field or something similar. To perform these operations we have to convert our regular stream to int stream or double stream or long stream. That's why stream type has such methods as map-to-int, map-to-double, map-to-long. These methods take function as an argument, then can extract some number value out of current item in stream. And these methods return specific stream type, like int stream, double stream or long stream. These types declare new methods. For example, imagine the case when you need to calculate total amount of items of all products in the warehouse. I create stream and after that call map-to-int method and pass function that returns int value based on each product. Is it clear? And after that I can call sum method. This method will sum all integers in my int stream that I received after map-to-int method invocation. And here I printed total items amount to console. By the way, instead of sum you can call max, min, average or any other methods you would like. Besides examples from this file, I also prepared a lot of other examples for you with other methods. I will leave link to this file in attachment to this lesson. I want you to investigate these code examples by yourself after the lesson, because technically the syntax is the same and you saw already few examples. Some of the methods are used very rare, some of them are used more often. We'll talk about the methods in a minute. But remember that you can find any code example with any method from Stream API by searching through this file. Now, when you saw how you can use the methods in Stream API, it is only a matter of what method you wanna call. We cover all aspects of using Stream API from the syntax standpoint. Now, we have to learn the methods that you might wanna use while working with streams. I wanna show you the cheat sheet, I call it so, with the main operations with streams and short examples. Remember, you can use the cheat sheet in case you forgot something. On this slide, you can see how you can create stream with examples. Some of them we already reviewed. I'm talking about creating stream from collections and from array. Let's review other options. We can create stream of elements if we want. We can create stream of lines in case we read file. We will learn more about this during the topic input-output streams in Java. Also, as you can see here, we can create stream from string. We can use stream builder to add elements and after that build stream. Also, you can invoke parallel stream that would process all elements in different threads of execution. In short, parallel stream will not always bring you better performance, because coordination of multiple threads of execution also requires some calculations. That's why use parallel stream only with big amount of data. It is hard to say what should be considered as big, because it will depend on the operations you are going to perform in stream. It will also depend on the type of the object that you are going to use and how big it is. I would even say that in case you are not sure whether you need parallel stream in some particular case, always opt for regular stream in such cases. Also, we can create infinite sequential ordered stream produced by iterative application of a function to an initial element. Besides that, we can create an infinite sequential stream where each element is generated by the provided supplier. In other words, we can pass function that can generate elements and create stream. To be honest, I didn't use the last two options very often. So now you know all possible ways to create stream. Let's move on. On this slide you can see different intermediate methods. Some of them looks familiar to you because we had examples with those methods. You already know when you might wanna use filter, map, map to int, flat map methods, don't you? You also can use skip method to skip specific number of elements. You can call distinct method to get stream without duplication. In case you wanna apply consumer function to each element, you can call pick method. Usually it is used for debugging purposes to print element to console to investigate the state of a stream. Limit method allows you to limit number of elements in your stream. Sorted method allows us to sort elements in stream by natural ordering. There is also overloaded version of this method that takes comparator as an argument to define the sorting order. Using these intermediate operations you can do amazing things with data manipulation. Let's look at the next slide. And on this slide you can find list of terminal operations. Today during the demo you saw collect method, for each and toArray. Find first method returns the first element from stream. This might be useful in case you sort elements in stream and wanna take the first elements after sorting. Find any method returns any element from stream. Pay attention that these two methods return object of type optional. This is not the lesson about optional, but in short, optional is a type that is used as a container for object that may or may not contain a non-null value. Also, these types introduce API to extract value from container or perform other operations in case container is empty. We can call count method in case we wanna get number of elements in this stream. Any match, non-match, and all match methods take predicate to return true or false. I believe that it is clear from the method names that any match will return true in case at least one of the elements from stream meet the conditions of predicate that we pass to this method. Non-match will return true in case none of elements match the predicate, and all match will return true only in case all elements match predicate. Min and max methods, I believe these are self-describing. These methods take comparator as an argument. For each ordered method is similar to for each method, but it also supports order of elements in the stream. Reduce method performs reduction stream operations that allows us to produce one single result from a sequence of elements. In this operation usually take part three participants. They are original element, it is also called identity. The second participant is an accumulator. This is a function that takes two parameters, a partial result of the reduction operation and the next element of the stream. And the third participant is a combiner. This is a function that is used to combine the partial result of the reduction operation when the reduction is parallelized, or when there is a mismatch between the types of the accumulator arguments and the types of the accumulator implementation. And I know that this can sound not clear, but don't worry about that. After this lesson, take your time to investigate the examples. I didn't show you this example because, to be honest, this function is not used super often, really. So, take your time to investigate examples and feel free to ask questions in case you have any. That's all what I wanted to share with you today. Now let's recap what we have learned today. Today we learned really a lot of things, but let's try to sum it up. We understand what Stream API is. Now we know how to create stream, how to use intermediate operations, and how to use terminal operations. On real-life examples you saw how you can apply your knowledge about Stream API. Also, you got a lot of examples that you can use during the development when you need. And now, let me show you homework. You can find multiple tasks here. The important thing in each task is to implement those with the help of Stream API and functional interfaces. You can practice a lot in writing your own Lambda expressions and in processing elements in Stream. Read tasks attentively. I added as much details as I could in each task. And remember, in case you have any question, don't shy to ask me. That's all what I have for you for today. Thanks a lot for your attention, have a great day, and see you in the next lesson. Hello team, today we are going to learn with you how to work with input and output streams in Java. We will start our lesson from learning how to work with files in Java. We will learn today how to create byte and character input streams, and also we'll create byte and character output streams. On real examples, you are going to see how to work with files with the help of the Java. Today you are going to learn how to close resources and how to use block try with resources. After today's lesson, you will understand how to use different encoding while reading and writing to file. And at the end of the lesson, we will talk about classes and interfaces from Java Neo package. I will show you how you can process files with the help of Stream API. You are going to learn what buffered streams are and how to work with them. Also, I will share with you tasks that will help you to practice your skills of working with streams. Let's start! Java I/O package is about reading data from a data source and writing of raw data to a destination. There are various of data destinations. Some of them are files, pipes, network connections, in-memory buffers, and so on. Work with different data sources are similar from the application programming interface standpoint. That's why I suggest to review all examples of input-output streams while working with files. We have to learn what files are and how to work with files. To be honest, input-output streams topic in Java is one of the most unstructured. A lot of packages, a lot of hierarchies, a lot of classes, and so on. That's why I believe that learning this topic is the best way to learn it by example. I prepared a lot of demo files to help you understand the topic better. Let me open the Eclipse. As I already mentioned, I think it is better to start from overview what files are and how to work with them from Java. I wrote a program here. Let me run it and explore its output together with you. In this example, we'll review type from package Java I/O. We have type to represent file. I can easily create file object by calling constructor and passing the file name to constructor. And I want to pay your attention that we didn't create a file in file system. We have just created file instance, and now we can call methods on this object that will help us to create files in working directory. The string that we gave to constructor is converted into abstract path name. I can create a catalog using this object. In other words, I can create a folder by calling mkdir method. In case you want to create a hierarchy of folders, you can specify directory's name using file path separator and call mkdirs method. But creating programs with Java, we create cross-platform applications, and we should use platform-independent characters. Class file contains platform-independent file separator. mkdirs returns true or false. You can build a logic around this API. Here I will print to console file separator. In one operating systems it is a backslash, in other it is a slash. Java will determine what operating system is used and will provide you with platform-specific file separator. File also provides us with a constant for path separator. Do you remember when we configured Java on our computer, we had to set environment variables? We changed the value of path variable, and as a separator we use semicolon. That is specific to Windows operating system path separator, and you can see it in console. In other operating system, it could be a colon here. By the way, talking about platform-independent characters, I want to pay your attention to line separator. In some operating systems, line separator is a combination of characters like carriage return and new line. In other operating systems, it is just a new line character. So, whenever you need to express a new line, for example, in cases when you prepare text that should be written to the file, I recommend you to use method from system class with name line separator. Now, imagine that you have to create not directory, but just a file. Imagine that content manager of our online store wants to do an export of all products to the specific file. We have to create file for him. At first, we create file object, and after that, we create file by calling a method create new file. After this lesson, I recommend you to open source code of the file class and explore all of its methods. But I want to show you methods that may come in handy while working with files. For example, you may always check whether a file exists by calling exists method. Or you can check if some specific file is directory. When you need this, You are going to have a homework where you would need to implement a program to solve real-life case. You can build the logic of iterating and navigating in your file system by identifying whether some specific item is a directory or a file. In case this item is a directory and you want to iterate over all elements, you have to get files from this directory. To do this, you can call listFiles method. It will return an array of files, and you can work with the file array as with any other array. You can iterate over it if you need. You can get absolute path of the file by calling getAbsolutePath method. Also, you can check whether file that you have is executable. For example, files with the .bat extension are executable files. On Unix systems there are shell scripts with .sh extension. Those are executable too. Similar to the way you can check whether a specific item is a directory or not, you can check if specific item is a file by calling isFile method. Sometimes there are hidden files in your file system. For example, Git folder of our local repository is hidden by default. You can check it by calling isHidden method. Is it clear? Feel free to press a pause to review these methods and make sure that you understood them. Also, I want to remind you that you are always welcome to ask any questions in Q&A section. If you understood the methods that we have just reviewed, I suggest to move further. You already saw listFiles method, but it is overloaded. Let me open the source code of this version of the method. And right near this method, we have another one. This method takes FileFilter as an argument to filter files and return only files that meet the condition that is specified in FileFilter. Let's open FileFilter to understand this interface better. And here in the source code we can see that FileFilter is a functional interface. I assume that by this moment in our course you already know functional programming and can understand what functional interface annotation is. Just to remind you, this annotation means that the interface has only one abstract method and we can use either method reference or lambda function to implement this type. Indeed, FileFilter has only one abstract method with name accept that takes file as an argument and should return either true or false. Let's get back to our demo file with file example. Here in the example you can see that I created lambda function that meets the definition of accept method from FileFilter interface. It takes file object and returns true or false based on it. You can see that I get file name and after that I check whether file name is ended with .java. This lambda function will return me only Java source code files. Does it make sense? Let me run this program to execute all code that we have just reviewed. By the way, after execution of this program, all folders are created here. And here is our result.csv file that we also created in our program. So now you can understand that the path that we specified for file here is relative. And it is relative to our Java project. You can use absolute path if you want. The absolute path on Windows would include your disk C and all other folders. For example, here you can see absolute file path. Usually in your programs you don't want to specify absolute path. Why? You have to understand that your program is going to be executed on different computers and on different servers, and file system will look differently on each computer. For example, on Unix-like operating system there is no disk C at all. Can you understand that? That's why in real life you would usually use relative path to your project. Does it make sense? Cool. Now, I want to share with you another way to manipulate files. Besides Java I/O package, there is also Java Neo package. It is called as new output input streams. That's why it has N letter in the name. During the lesson we'll review in parallel classes and types from Java I/O package and classes and types from Java Neo package. From the practical side I can say that classes from both, I mean I/O and Neo packages, are used. There are no specific preferences, it is just a matter of APIs and how you would like to work with streams. There is a way to do the same things but with different classes. And we, as developers, should be aware of different interfaces in Java, because different APIs would use different types. Let me open another file with examples that will help you to understand how you can manipulate with files with the help of Java Neo package. In Neo package there is one important difference. The concept and all API is built around another abstraction. It is named path. You don't have file like in Java IO package. What you can do is to manipulate with resource by its path. To create path object, we have to use path class with s at the end and static method get. Let me open the source code of path class. This specific method takes variable arguments. You can pass one string that contains file path separators, but also you can pass multiple strings to indicate inner directories. You can see that this is overloaded method. We also have another version of it to pass URI object, but in my opinion, this version of get method with variable string arguments is more popular. Let's get back to the demo file and I will show you path API. In Neo package there is files class that contains a lot of methods to work with files. And the same as other classes from Java Neo package, it uses path type in its own API. The same operations that we did with the file object in the previous example, we can do with the help of files class. For example, we can check whether the file behind this path is a directory or it is a regular file. We can create a hierarchy of directories by calling createDirectories method. You can create a file when you want. We can also delete directory by its path. As you can see, you can do pretty much everything you wanna do with files with the help of files class. What I would recommend you also to do is to open the source code of files class and to review all of its methods. I believe you are smart enough already to read the documentation and to understand what each method is all about, because we did it with the other classes, and you know how to do this. And there is not so much sense to go over each method and read documentation out loud, also taking into account we reviewed the most popular methods in my opinion. So just take your time at home to review the source code of files class by yourself. Meanwhile, we'll go further and I will explain you the structure of input and output streams. Now, I want you to understand the hierarchy of all types in Java IO package. We have two main hierarchies. They are hierarchy of byte streams and character streams. What is the difference between them? Byte streams can work with data with size 8 bits, that is 1 byte. So all reading and writing operations work with 8 bits. These types were created since Java creation. And after that, types that can process data of 2 bytes were created. Now, there is a possibility to process Unicode characters and describe them in 16 bits. That is 2 bytes. All possible Unicode characters. Definitely, character streams are used to work with text data. In case you need to read or write text data, it is recommended to use character streams to ensure that you can read all characters from the file. On the other hand, byte streams are widely used in reading and writing resources. For example, in case you want to store image in your file system, user uploaded an avatar and you want to store profile image on the file system of your server, you can transform this image in byte stream and store it as a sequence of bytes on your file system. And when it will be needed, you can read stream of bytes to restore the image. Does it make sense? On the top of the byte stream hierarchy there are two abstract classes, input stream and output stream. And there are dozens of implementations classes like file input stream, byte array input stream, object input stream, and others. If we talk about classes that extends output stream, it is worth to mention such classes as file output stream, byte array output stream, object output stream, and others. On the top of character stream hierarchy there are also two abstract classes. They are reader and writer. And you can see on the slide that multiple classes extended these two. All classes usually have appropriate suffix, reader or writer. Take a look at this hierarchy. Press pause for a second and make sure this slide looks clear and logical to you. If you think you understood this, let's move on. Let me now show you how you can work with input and output streams. I will share with you this demo file and I want you to execute these examples on your computer separately and would investigate the result. This will help you better understand how input and output streams work. Right now, I'll walk you through these examples to share with you my thoughts. At the beginning of our program, we specify a file path that will be used as a test directory for the sake of our examples. And also we have here tags that contains different characters, including Cyrillic characters. This will help us to understand encoding examples. Let's start. Our first example is writing text to a file with the help of bytestream. We have this method here that takes path and string. Let's investigate the source code. I have try finally block here. Why do I need it? It is a rule of thumb to close the resources once you used them, because having multiple resources opened will make a harm to your application. This could lead to resource leak. To close any of input and output streams, we have to call close method on the resource. To have access to output stream reference, I declare it outside of the try block. Inside the try block, I create an instance of file output stream and specify path to the file. After that, I get bytes from the string, and I call write method to write bytes to the file. After I did everything I need with the resource, I close it in finally block. That's why I have such construction. Let's proceed with the next example. In the next example, there are a few more things to learn. First of all, there is another construction to close the resources. It is called try with resources block. Let's go line by line. I write try keyword, and after that, in parentheses, I specify resources that should be closed automatically outside of the try with resources block. All types that implements closable interface can be used in this block. Let me open the source code of file output stream. And here you can see that it extends output stream type that in turn implements closable interface. That's why this type can be placed inside try with resources block. The next thing to learn here is using the var keyword. This is exactly the case when using a var keyword is justified, because this is just local variable that is going to be used right after its declaration. That's why there is no need to declare abstract type of this variable, and it can be the same as a specific type. For example, there is no need for me to specify output stream type for a variable if I wanna use buffered output stream and all of its features and methods. Let's talk about the next thing. You can see that I create object of file output stream and wrap it with the type buffered output stream. Later, when we learn architectural patterns, you are going to learn that there is a decorator structural pattern that is implemented just like this. You can add new features to the object by wrapping it with new type. Literally, you passed one object as an argument to the constructor of another one. In this particular case, we are adding feature of buffered writing. What is a buffer? Buffer in a computer science is a region of physical memory storage used to temporarily store data while it is being moved from one place to another. Buffered writer use memory efficiently by writing everything to the buffer first and after that writing everything to the target at once. This is considered more efficient rather than to perform write operations to the destination file byte by byte. Can you understand now why we might want to use buffered input and output streams? And now I can write all string to the file. Outside of the try with resources block, buffer is flushed automatically. There is one more thing you have to know about the buffer. It is flushed automatically in two cases: when maximum size of the buffer is reached, and the second case is when stream is closed. That means that in case you wrote just not so much information to the buffer and you forgot to close the buffer, you will write nothing to the file. In the next method you can see exactly this case. Let me comment all methods that are called after this one. And now let me run the program. Now when program is executed, I want to check output file. Here is test directory, and here is our demo.txt file. You can see that it's empty, because buffer is not flushed. Now let's get back to our demo file, and I vividly call flush method to flush the buffer. I execute the program one more time. And if we would look to our output file, we're going to find that the text was successfully written. Can you understand now what buffer is? You can investigate the source code to learn more. For example, let me open buffered output stream and to explore its close method together with you. There is no close method in buffered output stream because it is implemented in the parent type. Let's open parent type and find close method here. Awesome! Here it is. And you can see that during the closing of this resource, flash method is called automatically. That is exactly the reason why we can see that text was written in the file in case we use buffered output stream with try with resources block, because close method is called automatically for all resources specified in try block. Does it make more sense now? Great, let's move on. And before we proceed, let me uncomment all other methods. Cool. We'll review the next examples a little bit faster because they are similar. These examples shows us how to write to the file with character streams. We just create file writer object that extends writer type. By the way, I believe you understood that you can use any other type besides those that works with files. The way how you will use those types are pretty similar to the way how you use types that work with files. So, just feel free to use any implementations of input stream, output stream, reader, and writer classes. Example with buffered writer is similar. Pay attention that in these methods you can pass the whole string to the method instead of array of bytes. Make sure you understood these examples before moving further. If you're okay, let's proceed. Now, let me show you next examples. These examples about reading from file. The first example shows us how to read from file with the help of byte stream. As you can see, we create an object of file input stream in try with resources block. Here you can see that I read file by bytes until I would face with -1. That would mean I reached end of the file. And to print everything to console, I have to convert integer variable to char. But during the reading of files with byte streams, you are going to face one issue. You will be able to read only first 256 characters from Unicode table. That means you won't be able to read Cyrillic symbols, for example. Let me run the program to show you this. In console output you can see that all Cyrillic symbols are turned into question marks, because it is not possible to represent all symbols of Unicode with 1 byte. You need 2 bytes for this. The next example is an example of buffered input stream. Here you can see that you can declare multiple resources and add different features to a stream by wrapping it in different objects. For example, data input stream allows you to read specific data type. It declares additional methods, like readInt, for example, that returns int value, and so on. And you can see and understand how to add additional features to existing stream. You have to create some base stream first, and after that wrap it with other types. In other lessons we'll learn this architectural pattern in details. I believe you can also understand that you can declare each object in a new line, but also you can get reference only to the last object by calling constructor of different types in one line. Taking into account this is buffered input stream, we can read file not byte by byte, but by lines. That's why readLine method is available for us here. It is crossed because according to the official documentation it is deprecated, and it is recommended to use character streams to read files. That is exactly what we have already discussed. And below you can see 2 methods that show how to read file with character streams. With buffered reader you can read file by lines. Please explore these examples by yourself after the lesson. From the syntax standpoint, there is nothing special, just using of different types. By the way, in console output you can see that Cyrillic symbols are read properly with the help of character symbols, and there are no more question marks. Now, I wanna show you how to perform the same operations but with the help of type from Java Neo package. You can easily write text to the file with the help of files class. Just call write method and pass the next arguments. The first argument is a pass object. You already know how to get pass object. After that, pass bytes that you wanna write. And after that, you can optionally pass open options. Let me open the source code of write method. You can see that there is variable length argument of the type open option. That means you can either pass nothing or multiple open options. What open option type is? Let me open this interface. This is marker interface that declares a type that can tell program how to open or create file. I press F4 key to see implementations of this type. The most popular in my opinion is standard open options. Let me open it. This is an enum type that declares main options how to open access to the file. Either you wanna open only read access to the file or also write access. You can specify that you wanna add text to the bottom of the file by using append option. You can clear a file before writing new information there. To do this, we have to pass truncate existing option. If we wanna create file, we have to pass create option. In case we wanna get failure in case file already exists, we have to use create new option. This is important when you're afraid accidentally overwrite already created file. I believe that delete on close is self-describing. In my opinion, those are the main options that we might wanna use. You can review documentation for the rest of the options by yourself. Let's get back now to the demo file. And in our practical case, I specify that I wanna create file in case it doesn't exist and append text to the bottom of the file. Is it clear? Great. Also, in case you have list of strings, you can write them to the file. Each string from the list will be written from the new line. Write method is overloaded, and you can also specify encoding. In case you wanna write to the file with UTF-8 encoding, just use constant from standard charsets class. The next example shows us how we can read from the file with the help of Java Neo package. You read file with the help of the stream. Lines method takes pass, and optionally you can pass encoding to read from file. And when you have stream, you can work with it like with any regular stream where each string is each line from the file. Is it clear? In our particular case, I passed the reference to the method that can print each line from the new line to console. And here you can see content of the file in console. You can see that the last time when we wrote array of characters, we overwrite everything that we had there. Here in commented line you can see that we could use lambda function, but I believe you already know how to use functional programming. There is also another way to read content from the file. There is a method called read all lines. It returns list of strings. The specifics of this method is that all file content will be stored in Java memory. For example, in case you wanna process huge files that contains tons of information, imagine that you wanna process 2 GB of information that contains information about patients from all hospitals around all United States from the last 10 years. And imagine that you have only 1 GB memory reserved for heap space of your Java program. That means you'll face with error during program execution, because all text data will be stored in memory of Java program. But you won't face with out-of-memory error in case you would process file with stream, because it reads file line by line. Always remember that reading and writing are operations that can block thread of execution. For example, in this particular case with read all lines, main thread of execution will be stopped in this line until all file will be read. That's why very often separate thread of execution is used to read or to write information from the file. How to create a separate thread you are going to learn a little bit later when we'll get to the multithreading topic. If you understood this example, let's move on. During all examples today you saw that to specify encoding I use special class that contains a few constants. It is called standard charsets. Let me open the source code of this class. In class outline you can see that it contains very limited amount of charsets. What to do in case you need to specify some custom encoding? You can create object of a charset by the specific charset name. To do this, you can use forName method of charset class. You have to pass encoding name to this method to get exactly charset that you expect. In case you would like to explore all available charsets, you can print them to console. Charset class has available charsets methods that can return sorted map of charset name mapped to charset objects. If you understood this, I want to show you a few more interesting methods that will be helpful during your homework and hopefully during your career. Files method has find methods that can help you to find files that match specific condition, and you can create a stream out of these files. But to be more specific, you can create a stream for path objects. To do this, you can call find method and pass to it path where you want to start looking from and int value of depth. That is how deep we should go into inner directories while looking for files. And the key argument you have to pass by predicate that will define the logic what file you are looking for. The by predicate takes path and file attributes. You can see that in this lambda function we use only path, and we want to find all files with Java extension. After that, I use the stream to process all paths. I sort them, after that I turn path object to string, and collect all strings in one line. And in case I found such files, and final string is not null, and it is not empty, I print it to console. Can you understand this? You are always welcome to ask questions in Q&A section in case something is still unclear. There is also another helpful method. You can iterate over all files by calling walk method. There are different variations of this method. One of them also allows you to set depth during the iteration. This method returns your stream and you can process it as you wish. That's all what I wanted to share with you today. Let's recap what we have learned today. Today we learned how to work with files. We also learned how to work with path type from Java Neo package. After that, we learned what byte and character streams are. After this lesson, you know how to use try with resources block. Now you know what is a buffer and how to use buffered streams. On real examples, you saw how to use encodings during writing and reading. And at the end of the lesson, we learned how to read and write from files with the help of Java Neo package. Now, I want to share with you your homework. I'll leave link to your homework in attachments. During the homework, it is recommended to implement the next tasks to make sure that you learned this topic. I want you to review the documentation for Java I/O package including file class. Similar to that, I want you to review documentation for Java Neo package including files class that is located in the sub-package file. Also, you have 4 coding exercises to implement. According to the task number 3, you have to implement methods that would read configuration map and would be able to return value of the specific property from the config map. In the task number 4, you would need to iterate over files to calculate number of files with a specific extension. In the exercise number 5, you have to implement console text editor. User can interact with console to write text to the file. In the exercise number 6, the most interesting in my opinion. As you already understood, along all course we are going to implement online store application and add additional features to it as we learn new topics. In this exercise, I want you to add functionality of storing users and products in the file. That would be our first external data storage. And when program will be started, we'll read the state from the files. That's it. You're going to have a lot of opportunities to sharpen your skills. Thanks a lot for your attention, dear students. Hope you found this lesson interesting and useful for you. See you in the next lesson. Hello, dear students. In this lesson we are going to learn what serialization is and talk about object cloning. We'll start from understanding why do we need serialization. I will explain you what the serializable interface for. After that, on real example, we'll try to serialize and deserialize few objects. Also, we'll learn externalization today. You are going to find what the difference between serializable and externalizable is. Once you learn that, we'll talk about object cloning. We'll review what is deep and shallow cloning. I'll tell you how to override clone method to support deep cloning. In this lesson, you are going to see a lot of examples. So, let's start. First of all, let me give the answer and question what serialization is. Serialization is a process of converting object to a stream of bytes. Deserialization is a process of converting stream of bytes to an object. In simple words, you can represent your Java object in sequence of bytes. After that, you can either store it on local computer or send serialized object over internet. It's up to you. In case you understood what serialization is, let's understand the problem and why we might want to use serialization. To help you understand this, I'm going to discuss with you a few real-life cases. Imagine that you have two servers that are running the same code, and you need to pass information from one machine to another. You can create an object and serialize it and pass sequence of bytes over the network to another server. The second server will deserialize your message and construct new object out of the bytes that we have sent. That's how you can pass information from one server to another. Another example. It's when you need to store some data on the local computer. Imagine that you have a game or another desktop application, for example, your diary. And when user closes the program, you wanna save the state of the program. It could be game progress or list of users' plans, it doesn't matter. And you can serialize object that contains this information when program is closed and deserialize it when program is started again. It is pretty convenient, don't you think so? One more practical need for serialization is to make an exact copy of an object. Today we will talk about this and you will learn how to clone object with the help of serialization mechanism. How else you can use serialization mechanism? Imagine that you have really huge objects that takes 10 minutes to construct. Just imagine that. It is better for you to cache this object because deserialization of this object will take up to 10 seconds, for example. So, sometimes you may want to cache your objects. These are just few examples when you might want to use serialization. Interesting? If yes, let's learn how serialization works. For this lesson, I prepared examples that I'm going to share with you today. Let's jump to Eclipse. Imagine that we have class employee. That is some class from our application. And this class has next properties: ID, name, and list of properties of map type. This class also has getters and setters. And imagine that at some point in our program we want to serialize this object. The first thing we have to do is to mark specific type with serializable interface. This is important because without implementing this interface, you will get an exception during the serialization. To be more specific, not serializable exception. Let's review the source code of this interface. And you can see that this interface declares no methods. This is a marker interface. It is a rule in Java that to enable serializability of a class, it should implement this interface. Okay, now let's get back to our file. Now we have employee type that is ready to be serialized. Let's open our demo file. I create object of type employee. I set ID, name, and map with properties. Our map includes salary and the city. Great! To serialize object, I created a separate method that is called serializeEmployee. Let's review the source code of that method. I want to declare object output stream type. It can be created on the basis of output stream. So, I create object output stream and pass byte array output stream into it. Pay attention. Here, instead of byte array output stream, you can specify any other type that extends output stream. I declare all streams in try with resources block. Inside the block I call method, write object, and pass the reference to my employee object there. From this method I return byte array output stream, because I want to store the reference to this object. When times come, I will use this byte array output stream object to deserialize my employee object. That's it. I have just serialized employee object. How I can deserialize it? Let's review the source code of another method, deserializeEmployee. I pass to this method byte array output stream. That is the stream where my employee object was written as a sequence of bytes. In this method I create object input stream and pass to it byte array input stream object that is created on the basis of my byte array output stream. In simple words, I redirected my output stream to input stream, and now I wanna read it. All resources are declared in try with resources block. When all objects are created, I call readObject method. Pay attention that this method returns object of type object. In case you wanna have specific type, you have to cast this object to your type, and I return employee object from this method. In our main method, I wanna print the employee that we got after deserialization. Let me run the program to show you end-to-end flow. My program created employee object, after that the program serialized employee, and after that the program deserialized it and printed object to console. And you can see that it is the absolute copy of our original employee. Can you understand now what serialization and deserialization is? Great! Let me add few more details to serialization and deserialization. Let's go one by one. First of all, you saw that my employee class has specific property serial version UID. What does this variable for? Serial version UID is a constant that uniquely identifies a version of a serializable class. During the serialization process, Java Virtual Machine verifies this constant. Why? Imagine that we have a original version of an employee class. We serialized the object. And on the other machine where our program is running, or even on our machine but after user updated version of our application, imagine that there is an updated version of employee class. For example, instead of the map with properties, we have separate properties for salary and city, and there is no more property of type map anymore. That means that error will happen during the deserialization, and our sequence of byte won't be able to be mapped against the current employee type. And to distinguish versions of classes that are serialized, this constant exists. Sometimes developers set default serial version UID that is equal to 1, and that's it. Note that the serial version UID is optional, you can just ignore this. Eclipse will show you a warning, but nothing above that. Let's talk about what a transient keyword is. It is better to understand this on example. Let me add a transient keyword near name property. And now let me run my program one more time. Look at the console output. Can you see this? Name property is null. Why? Because transient keyword tells to ignore this property during the serialization. The string value of name is just not stored to the output stream. Let's get back to employee class. I will remove transient keyword. I want you to pay attention to two methods here, write object and read object. Especially pay attention to the access modifiers, return type of data, and potential exceptions that can be thrown. This is just a convention, and this is something what we have just to remember. In case you want to customize your object before serialization or after deserialization, you can declare these methods in your type and perform anything you need. For example, I printed in console random text just to prove you that these methods are invoked. You can always use default write object and default read object to process your serialization further. In these methods you can handle initialization of transient fields, for example. Hope this makes things clearer. Let's move on. Now, imagine the case that you want to serialize object and you want to explicitly tell that process of serialization should be customized. For example, each user has a password or any other sensitive information, and you want to encrypt this information before serialization and decrypt after serialization. For the sake of the demo, I create one more type called user. Pay attention, it implements externalizable. This type has only two fields. They are nickname and password. Here you can see two constructors, getters and setters, and the most interesting part. In case you implement externalizable, you have to implement write external and read external methods. It is similar to the way we reviewed with the serializable type employee and private methods. This is a more object-oriented way to say that this type contains custom logic for serialization and deserialization. If we would open this interface, we would notice that it extends serializable. In this method during the serialization, I write to the output nickname and custom password. We can encode password here, for example, and in the read external method, I should read properties one by one. You have to read properties in the same sequence we wrote them here. And you can see that I initialize state of the current object. Let me open our demo program to test serialization and deserialization. I create user object first and after that I call similar methods that we saw during the serialization example. Pay attention that I created user with this specific password. Let me run a program now. In console output you can see that password is different. That is because we implemented custom logic of serialization and deserialization. Does it make sense? Awesome! Now, when you completely learned serialization, let me talk about different topic. Let's discuss cloning now. Sometimes in your program you might want to create exact copy of the same object. For example, you want to do some modifications in user object, but you also need to store the reference to the original object. That is helpful in some specific cases when you need to keep both data objects, original and updated one, and pass them to the front end to compare them together. Each Java object has access to clone method. Let me open the source code of object class. You can find clone method here. As you can see, this is a native method and we can't explore its original source code right now. But what we can see is that the method has protected access modifier. What does that mean? That means we can't call clone method on each object by default, but we have access to this protected method inside the class. Let me show you this. All examples that are related to cloning will be stored in cloning package. Let me open this cloning demo file. Here you can see that I created object of a user type, and when I call clone method on this object, I get a compilation error. That is because clone method has a protected access modifier and available inside the user type. In this class, Java compiler just can't see it. To make it available outside of the class, we have to override this method inside the type and increase the visibility by changing the access modifier from protected to public. For example, here is an order type. It contains fields, constructors, getters and setters, and clone method. Here you can see that I override clone method and make it public. Inside the method I just invoke original clone method from the object class. You may think that I implemented clone method. Let's check how it works. Inside the main method I create list of products first. Now I can create an object of order type. I pass some random credit card number, list of products that are associated with this order, and user ID who made this order. This is my original order. I print it to console. In the next line, I want to clone my original order object. Pay attention that clone method may throw clone not supported exception. When? When type that is cloned doesn't implement clonable interface. Let me open the source code of order type one more time. You can see that my order type implements clonable interface. Let's open this interface. You can see that this is also a marker interface, and Java verifies during the cloning that type that is going to be cloned implements clonable interface. Take this as a permission to all objects of this type to be cloned. And in case this interface is implemented in the type, Java believes you that this permission has been granted. Is that clear? Awesome. Let's get back to our demo file. When I cloned object, I print it to console. Let's run this program. In console output we can compare these two orders, but believe me, they are the same. But there are interesting things to come. What if in the cloned object I will modify state? For example, I will clear all products from the cloned order. I get all products and call clear method on the list. After that I print original order. And you can see that list of products is also clean here. How that can be? This may seem to be a weird thing, but this is the way how clone method works by default. This is called shallow cloning. During shallow cloning, only references are copied. Shallow cloning works just fine for primitive types, because they already store the value in themselves. With reference types of data, only references are cloned during shallow cloning, but objects that stand behind those references are not cloned. Deep cloning is focused on the cloning of the whole object's graph, including properties of reference types inside the object and properties of reference types inside those objects. Can you understand this? Awesome. So what we have to do? We have to override clone method to make it also clone objects that stands behind the references. For the sake of the demo, I created one more order type that supports deep cloning. Let's open this type and explore its clone method. In the beginning I clone the whole object, and after that I put all attention only on mutable objects. In this particular type, I have only one mutable property. This is a list of products. String type is immutable. It will be impossible to change its state after creation. It will be possible only to set a new string. That's why I am not worrying about it. Also, I don't worry about int field, since this is a primitive type. But for products list, I did a copy, and I set this copy to my cloned object. Now, let's check how deep cloning works for this type. I initialized product list that was cleared one more time. After that, I create object of our new type. Then I clone this object, and similar to the previous example, I clear the list of products in my cloned object and print two objects to console. I expect that products list in original order won't be empty. In console we can see that we achieved our goal, and product list is not empty in my original order, and it is empty in cloned order. Great! Now you know how to do deep cloning. Feel free to let me know in case you have any questions. Knowing how serialization works, you may think that serialize and deserialize an object doesn't sound like a bad idea in case you wanna clone an object. Because implement clone method that would properly clone all graph of objects, it can be a very complicated task. Sometimes you may consider serialization mechanism to make a clone very fast. That's all what I wanted to share with you today. Let's recap what we have learned today. In this lesson we learned what serialization is. We reviewed serializable marker interface. Now you know how to serialize and deserialize your objects. You also learned what externalizable interface is. After that we learned how cloning in Java works. Now you know clonable interface. Today we learned what is the difference between deep and shallow cloning. Also, we had a lot of practice that will help you to complete your homework. Let's review your homework now. After this topic, you are going to have only one simple coding exercise. I promise you. We keep improving our online shop. Taking into account order type has list of products inside, it will be not very convenient to store it in comma-separated files. In scope of this task, you have to serialize all orders to the file, and when program will be started again, you have to deserialize all orders again. Hope this is clear. That's all what I wanted to share with you today. Thanks a lot for your attention, have a great day, see you in the next lesson.
This video is over. Go to starfreelance.eu to download these videos, materials, and sources. Watch more videos to get premium videos and ebooks. We'll be a Starfreelancer.